In today's video, we're going to be talking about methylation in the cycle of illness. We'll be discussing the signs that you need methylation support, what is methylation, areas that require methylation, methylation imbalances, and reasons for those methylation imbalances, as well as if you're over versus under methylator, the MTHFR testing, and foods you should avoid with MTHFR. We're going to be introducing the methylation cycles, and we're going to be slow and progressive and build upon the information. We're going to discuss what those cycles are, what they do, what food groups go into what particular part of the cycle, and we're going to teach how each cycle works, the genes, the enzymes, the supplements, the foods, and how to heal it. Then we're going to talk about how the cycles talk to each other and their relationship with the organs, systems, and mitochondria. And then we're going to talk about how to manage and heal each cycle. And there's the Methionine Cycle, the Folate Cycle, the BH4 Cycle, and the Ammonia Cleanup Cycle, or the Urea Cycle. We'll discuss home testing for MTHFR and how to interpret your gene results, all from the comfort of your own home. The MTHFR Supplement Healing Protocol, primary vitamins and nutrients that heal methylation cycles, and the action steps you need to take in order to heal your methylation naturally. And this includes diet, reducing stress, sunshine, exercise, sleep, which is in conjunction with your circadian rhythms, and there's a connection there, probiotics, toxins, and glutathione. The topic of methylation is getting its fair share of attention lately, and rightly so. Methylation is a critical component to your daily life and to your physical and mental health. The reason behind this is because it has significant impact on many biochemical reactions in the body. And proper methylation can make all the difference in how you feel both mentally and physically on a daily basis. And surprisingly, this process is a topic that very few doctors know about or understand. But we're going to try and change that today and empower you so that you can heal. There are many common symptoms or things that people suffer with on a daily basis that doctors usually hand out medications for. If you have any illnesses, autoimmune or otherwise, chronic symptoms, you can guarantee you have a methylation issue. It's 100% guaranteed. Examples of this are hormonal imbalances, and this includes things like PCOS, severe PMS, endometriosis, etc. Also, a fibromyalgia diagnosis. Folks, if you've been diagnosed with fibromyalgia, doctors rarely go looking for the root cause that gave you fibromyalgia to begin with. This is your root cause because you're not methylating properly and toxins are building up in your system because you can't detox them properly, and this is causing your symptoms and pain. Infertility, both male and female, miscarriages or pregnancy-related complications, cardiovascular disease, high blood pressure, tachycardia, and poor circulation, mood and mental health issues. This includes mood swings, depression, anxiety, bipolar, OCD, ADD, ADHD, outbursts, etc. Autoimmune conditions like MS, rheumatoid arthritis, autoimmune, mast cells, thyroid, diabetes, kidney issues including kidney stones, digestive issues like IBS, lupus, etc. Memory problems, insomnia, dementia, Alzheimer's disease. Chronic fatigue like ME, myalgic encephalomyelitis, try saying that fast 3 times. Low energy and easily fatigued with very little exertion. Allergies and histamine intolerance. If you have bioproduction issues, which includes excess bioproduction or not enough bioproduction, digestive issues, fat malabsorption, and gallbladder issues. Gallbladder issues will also lead to gallbladder stones, candida if you have an insufficient amount of bile, SIBO if it's insufficient, and there's a whole section about this in the inflammation video under gallbladder if you want to learn more. Inflammatory conditions such as arthritis, IBS, eczema, psoriasis, etc. You experience brain fog after eating. You tend to get red face or flush a lot. And in this next one, this is where the two Southern comedians Bill Engvall and Jeff Foxworthy would say,
"Here's your sign." He did not, did he? Oh.
The MTHFR or other methylation gene and enzyme mutations. That's a dead giveaway. Now, I'm going to address this here because I get this a lot. You do not have to have an MTHFR genetic gene mutation in order to have a methylation impairment. That means something in your diet, meds, lifestyle are causing the methylation impairments. This also means it's much easier for you to fix. So I just need people to understand that you can have methylation problems without any of the MTHFRs. So please do not disregard any of this because of that fact. In this video, I'm going to teach you how all of this works and how it ties into everything in your body. High histamine or homocysteine levels. Stress response is also extremely heightened. You'll get outbursts, extreme anger, irrational behavior, or what I call pinging, or overreacting to stress. You may also get trouble falling asleep or staying asleep, and because of this, you're not getting enough REM sleep. And there is one other that is not mentioned on this slide. You may have a great amount of sensitivity or reactions to medications like hormones or birth control, NSAIDs, etc. Or the medications may build up in the system, creating a toxicity or overdose-like symptom even when used correctly. On that one, painkillers is one that could wind up backing up in your system and create overdose symptoms. And another one is you get, on the backs of drugs, it gives you all these different side effects you could experience. A lot of people with methylation issues are going to experience some of those random side effects. So these are some of the symptoms that you may get that are, everyday normal things that people suffer with. But these are the early warning signs to address methylation immediately before it progresses into something worse. If you're suffering from these items, it'll only take a trigger or a triggering event to really make methylation issues far more noticeable and create havoc for your health. And this is probably a good spot to address this. Even if you develop something like SIBO, Candida, mold toxicity, one must ask themselves which came first. The answer will always be methylation issues which led to these problems. You only have to ask yourself, why do some people have such huge issues with SIBO, Candida, and mold affecting them so much, while others in the area under the same circumstances don't develop any issues? Underlying methylation issues that haven't been fully realized are almost always the culprit. This would be a triggering event, as well as a virus, parasite, extreme stress or trauma, or an accident or surgery, and the medications prescribed could also be a triggering event. Then these issues continue to compound, making your methylation worse. Because remember, a healthy body can fight these things and recover quickly. So now that you've discovered that you need to work on your methylation, let's look at this vital component to your health and what methylation is. First, let's review what we've learned so far in the previous videos. Think of methylation, or its opposite, demethylation, as the mechanism that allows the gears to turn, and it turns biological switches on and off for a host of systems in the body. In science, methylation means the addition of a methyl group or an atom, or it just completely substitutes the atom. So let's look at the pictures above. This picture represents one methyl group in various molecule formations. It has one carbon atom and then 3 hydrogen atoms. The R represents the reaction that takes place. If you look to the picture on the right, this one represents one cytosine molecule. The addition of a methyl group, which is the CH3, to form a methylated cytosine molecule, thus changing the reaction of the molecule and properly turning the gears in your biochemistry. Whoa! You're probably asking yourself, what in the world did all that sciencey gobbledygook just mean? Let's break it down. You are a complex machine, and there are many gears that need to be turning to keep you healthy. Methylation is what controls these gears. These gears are what make all the different components of your body work Methylation takes all these different chemicals in your body and converts or methylates them so that different systems in the body can use them in order to keep you healthy. It uses the methyl groups, the CH3 we're talking about, which is an important component your body needs to make for methylation to work properly. And the majority of this is taking place in the liver itself or the cells of the liver. Making too much or not enough methyl groups impairs our biochemistry, or it messes up the gears. This wreaks havoc on our bodies in any system of the body, our moods and behaviors. So what's important to understand here is that methylation governs all these chemical reactions that can either be positive, which will keep you healthy, or it can be negative and it can be harmful to your body and make you very sick. If you have methylation issues, you may have elevated levels of homocysteine, a non-protein amino acid, as well as increased cytokines, histamine, estrogens, toxins, growth factors, proteases, and leukotrienes because your body cannot metabolize them, and this will affect your inflammation levels and make your symptoms worse. If you've been watching the videos, this is what we've learned so far about methylation. That is the easiest and simplest explanation on the subject, but today we're going to dive in much further so you can understand the processes and know how to heal yourself. In this video, I believe we're going to answer a lot of your questions and fill in the blanks to where some of your symptoms are coming from and where they all fit into methylation. It's my hope that we can turn you into little methylation experts so you can indeed take control of your health. Let's look at the areas that require methylation. All of these areas are dependent on methylation in order to keep you healthy. The cardiovascular system. Improper methylation will affect atherosclerosis, hypertension, and inflammation. Neurological, which we will be discussing in great detail later on in this video. Reproductive. For example, if you have methylation issues, it'll be harder to get pregnant, carry the pregnancy to term, and it will also contribute greatly to morning sickness and possible pregnancy complications. Genes and DNA. Methylation is vital for your DNA and for your genetic expression. This can essentially turn genes on and off. Neurotransmitter synthesis and elimination. This is another big one. Between neurotransmitter synthesis and DNA methylation, they are both profoundly connected to physical and mental health. For example, if serotonin, which is a neurotransmitter, is not properly methylated, it will become inactive. The buildup of the non-active serotonin in the body will lead to depression. Other neurotransmitters such as dopamine, adrenaline, and noradrenaline, if these neurotransmitters build up in the system, it can lead to hyperactivity, ADD, ADHD, etc., depression, brain and nerve damage, and a host of other things. Many biochemicals need to be methylated and metabolized into important byproducts that are used elsewhere, or they're metabolized to become safe for the body and subsequently detoxed. That's how methylation works in so many processes. Detoxification systems. Some of the compounds that methylation helps to detoxify includes histamine metabolism. Those are the chemicals that causes your allergy symptoms of itching, redness, swelling, and irritation. Estrogen metabolism. You don't want estrogen building up in the body because that will cause damage to the body, including risks for cancer. Fat metabolism. And don't forget, what your body can't detox, it's going to stash in body fat in order to protect you from its harmful effects. So if you're not detoxing properly, your body is going to start creating more fat for the toxins to be stashed in. And liver detoxification pathways. This helps with detoxing heavy metals and toxins from your body. And remember, your entire volume of blood runs through your liver 7 times an hour, so it's a very efficient organ. But seeing the liver is an important organ for methylation, methylation issues will affect your liver, as well as the gallbladder and pancreas. So if methylation issues are going to affect the liver, then that means drugs, GMO, processed, carb-rich, sugary foods, smoking, alcohol, allergy foods, toxins, etc. can damage the liver because you can't metabolize or methylate properly, and it won't be able to detox itself efficiently either. And this is where fasting comes in handy. So if you persist with the drugs, the bad foods and bad habits, etc., the things you can control, the damaged liver will further slow down methylation and your ability to detox your body. This will also result in some serious symptoms and cause a vicious cycle unless you address your lifestyle and dietary habits. You'd be surprised how your daily habits can royally affect this. Eye health. Believe it or not, if you have significant methylation issues, it's really going to start messing with your eyes, including vision issues that fluctuate throughout the day. Cellular energy. This includes your mitochondria and the ability to transport nutrients in and out of them, as well as detoxing the waste out of the cells. Liver health and other organs that support digestion. This includes your liver, pancreas, and gallbladder, and if you have methylation issues, this will be impacted. You may recognize this slide from previous videos because it involves the gallbladder, the liver, and the pancreas and the processes that take place. So with methylation issues, this will include things like insulin resistance, gastrointestinal issues like IBS, and gallbladder issues like sludge or gallbladder stones, as well as contributing to candida and SIBO because the gallbladder bile isn't cleaning and maintaining the intestinal tract like it's supposed to. And impaired methylation can contribute to all of this. Another area where methylation is important is the aging process. It will affect your hair, the gray, your wrinkles will all come sooner if you can't methylate properly. Why? Because it brings age-related issues sooner in life due to the body's inefficient processes hampering your health. Immune function. All of these items have direct impact on your immune health and how it responds, its hypersensitivity, etc. So as you can see, if your methylation is off, it can cause some pretty big issues. A methylation imbalance has the potential to impact on numerous areas of your health. Furthermore, when it comes to methylation, what may be considered a personality trait may in fact be due to the impact methylation can have on our brain chemicals or our neurochemistry. And we'll get into that a little bit later in the video. Let's take a look at the symptoms you get when you have methylation impairments. These are a lot of the symptoms associated with methylation issues. However, despite the fact that I filled a whole slide, it's still just the tip of the iceberg. A lot of times, folks who are suffering with these symptoms go to seek medical care and doctors get stumped as to what's going on. Many times, the doctor will tell you that there's nothing wrong with you, and some will even go as far as to tell you that it's all in your head. I rest assure you, it is not. This is where they start treating the symptoms and give you fistfuls of drugs like antidepressants, anti-anxiety meds, painkillers, antacids, antibiotics, sleeping meds, etc. I can assure you, these items will not only make the overall predicament worse, as well as add on additional symptoms, further toxify your body, and possibly break your immune system. Why? Because remember, you're not methylating properly, which means you cannot properly metabolize all the different chemicals entering your body. So what happens, and is quite common, is that the doctor completely missed the larger issue at play here. It's not necessarily their fault. This is still a bit of an emerging new science, and that is why I am teaching this. But many times, docs don't even take a second glance as to the root cause of what's causing your issues in the first place. It's all about get you in, give you drugs, get you out. It's about quantity over quality. But there are still many doctors out there that will listen and try to help you, so don't give up. But you can see here why many autoimmune, mast cell patients, and chronic illness sufferers, either mental or physical, can hope for nothing more than, I don't know, it's in your head, and or large quantities of drugs or supplements. In the long run, these drugs and supplements do more harm than good. But I am hoping to change all that. I hope you're starting to see in my videos just how this is all tying together and getting to the root of the actual problem behind our health issues so that we can heal. And again, remember, there are a lot of side effects that can happen that are labeled as personality traits, when in reality, it's a sign of methylation impairment, toxic overload, and other chemicals and biochemistry getting out of balance. So let's take a look at the things that knock methylation out of balance. Gene mutations. There are quite a few different genes that control methylation, 18 to be exact. However, we're finding that genes have far more than just one role and affect a lot more processes, and that all genes play many roles and contribute to many processes working properly in the body. So just because we know that there are 18 genes, we're finding that they have more than just methylation roles and that other genes also contribute. So again, how we've been talking about your whole body talks to each other, your genes do as well. Your genes are like the blueprints to a building. They tell the construction workers how to build it, the floor plan, where and how the electrical, plumbing, air filtration, and wiring of the entire building go. Then those blueprints also dictate how it's supposed to run efficiently, just like the genes do for the body. Except now your genes are constantly telling the body how to perform the functions. They keep giving instructions day in and day out. However, it's up to you what instructions those genes give to the body, because like I've been saying throughout the videos, the condition your cells live in determine your genetic expression. The most common known gene mutations that affect methylation are the MTHFR, the COMT, the MTR, MTRR, the AHCY, the MAT, MS, BHMT, the AGAT, the GAMT, the CBS, and MT. So just a word of warning, and you'll be seeing this slide again later in the video, but many folks try to address genes alone with supplements, and that can be a common mistake and a big one. Why? Because supplements are extremely powerful and you're already having a hard time methylating, which means this can cause further issues with the liver and other organ toxification. This will slow down methylation even further. Plus, you add the fact that these supplements have fillers, binders, haptens, colors, etc. So when you do get some, be sure to get a high quality, allergy-free, filler-free supplement. Stress. All genes are affected, and pretty much so is everything else in the body. And this can include physical stress, long-term illness, chronic infections, food intolerances and allergies, and insufficient sleep. Psychological stress, like issues with family, work, and life, can also definitely contribute. But just because you have the genes does not automatically mean that you're stuck with a methylation imbalance. We now know through the study of epigenetics that internal factors like your response to stress and external factors like pollution, smoking, diet, etc. have a huge role in how your genes are expressed, i.e., genes can be switched on or switched off. Through following a healthy lifestyle and successfully managing your stress, you may be able to negate an inherited methylation issue. So you can see how stress management is extremely important even for methylation. As we talked about in the previous video, Cycle of Illness, Mitochondria, we learned just how overly deficient our Western diet is. If that is how you normally eat, you can be guaranteed there are nutritional deficiencies in your body and it's affecting your overall health by affecting mitochondria health and messing with your methylation cycles. And these include too many carbs, too much sugar, too much protein, not enough protein, not enough healthy fat, and a shortage of vitamin B, vitamin C, copper, and zinc. Exposure to toxins, air, water, land, pesticides, smoking, drinking alcohol, processed food, preservatives, chemical-laden products, allergens, and other toxins. The body was never supposed to, nor was it built to withstand the constant bombardment of stresses on the body. This continuous exposure does a lot of damage to the body. Infections. Certain types of infections, especially serious infections, can do far more damage than you may realize. They can mess with your metabolics, cause damage to mitochondria, and also mess with your methylation cycles. They can damage certain pathways, damage the immune system, and oversensitize it or confuse it, which can then result in attacking things it should not in your body. The world is riddled with poor souls whose lives were forever changed after only one infection or illness. Certain medications, like NSAIDs, although this is an indirect relationship on this one, antacids, antihistamines, psychiatric drugs, antipsychotics, immune-modulating drugs like steroids or immunosuppressors. Specific drugs like nitrous oxide, the drug that you get at the dentist, the gas, methotrexate, metformin, antacids and acid blockers, proton pump inhibitors like Protonix and pantoprazole, and corticosteroids. These will all affect your methylation. NSAIDs cause renal and digestive issues like damaging the lining, causing bleeding. This in turn affects uptake of certain vitamins. It hampers the INF, which is the intrinsic factor, which then affects uptake of B12 in the intestines. Antacids also block uptake of certain nutrients, which in turn can hamper methylation. Methotrexate damages mitochondria, which in turn hampers methylation. So the effect isn't always a direct relationship between a certain drug and mast cell degranulation, but usually an indirect effect. If you're not methylating well, seeing that there's a lot of methylation in the liver, it can be difficult for many to take NSAIDs. Estrogen. Too much estrogen and not being able to detox it or metabolize it can cause a lot of damage in the body, to include increasing your chances of breast or uterine cancers. Sleep. As we've previously learned, sleep is critical in healthy methylation. Methylation can be impacted if you're not getting enough deep sleep, going to bed too late or getting up too late, and having irregular sleep patterns. Remember, methylation follows circadian rhythms, and you need 2 to 3 hours of sleep before midnight to optimize methylation cycles. If you don't get enough sleep, then you're going to wind up not generating enough methyl, and then you're going to be twice as tired the following day. This can continue to happen and even worsen until you fix your sleeping habits. Exercise. Exercise is critical in maintaining methylation. Exercise helps detox the body, regenerates mitochondria, lowers stress, etc. Not enough exercise or too much exercise, along with electrolyte deficiencies and dehydration, can all affect methylation. Niacin. Niacin, believe it or not, slows down methylation, so it can be very harmful if you're already an undermethylator. However, for those who are overmethylators, it can help you slow down the methylation, and we'll be talking more about this in a few minutes. Alcohol. Alcohol can damage methylation, especially if you have a pre-existing methylation issue to begin with. Methylation impacts liver function, and the liver is essential in metabolizing alcohol. Alcohol also lowers your methyl B12 levels, and methylation is dependent on those B12 vitamins. So not only does it lower B12, it further toxifies the liver and can further damage it, but it also weakens the cell wall integrity of mast cells and causes mast cell degranulation. There really are no upsides to alcohol if you're suffering from chronic illness, autoimmunity, or mast cell issues. You may be able to tolerate certain types of alcohol for now, but it will only hurt you further down the road as you get older. It will also increase age-related diseases appearing sooner in your life. Candida. This is one of those chicken or the egg scenarios. If poor methylation affects the liver, gallbladder, and pancreas, then it's not going to be able to clean the intestinal tract properly, hence infections or bacterial overgrowths. But if it gets out of hand, it too will cause methylation issues. If you have known inherited methylation issues, you can guarantee that poor methylation contributed to your candida. Candida will produce a neurotoxin, acetaldehyde. But don't assume if you're having neurological issues and gut issues that you have candida. This isn't always the case. There are lots of other issues that cause the neurological side and the gut issues as well. Diarrhea. Diarrhea can cause an electrolyte imbalance, dehydration, etc. So what's happening is that you are expelling all the vital nutrients, vitamins, enzymes extremely fast, and because it's a stress on the body, it's also burning through your methyl groups. Excess caffeine. Like diarrhea, you're expelling nutrients too fast. Instead of the vitamins, nutrients, and enzymes helping to heal you and provide methyl, you're expelling them before the body gets to even use them. Plus, many items that contain caffeine are doing more damage to guts and bodies because they are filled with chemicals. Mitochondrial damage. As we've discussed throughout the Cycle of Illness series, if enough damage happens to the mitochondria, then the body goes into self-preservation mode and starts making metabolic changes. One of the main metabolic changes it makes is to our methylation cycles. If your methylation becomes interrupted or you have a shortage of methyl groups, these processes in the body can become compromised and you can get very sick. Research, although in the early stages, has suggested impaired methylation is linked with autoimmune conditions. And ignoring methylation levels instead of fixing them will only hamper healing from any of these symptoms or conditions. Improving methylation is important for everyone, but it's crucial if you have an autoimmune condition, chronic illness, or mast cell problem. But remember, it also controls your mental health, how you handle stress, and your stress responses. This is where some of those personality traits come back in again. So it's very important to maintain healthy methylation levels. And don't forget, mast cells are the master switch to the entire immune system. It's one big flashing warning sign. That's why this cycle is so vital, and addressing all of it, including methylation, is so important to start digging out of the foxhole you're stuck in. There are two types of methylation. You can be an undermethylator or an overmethylator. And sometimes you can even wind up finding yourself being both. So let's take a look at what these are. With undermethylation, there tends to be high basophils, low zinc, definitely histamine issues, elevated serum copper, low homocysteine, high heavy metals in the body, and low levels of the neurotransmitters serotonin, dopamine, and norepinephrine. The symptoms below are the general rules of thumb, but don't write all these symptoms in stone because each individual's biochemistry is unique. It's just a general guideline that tends to fall in with undermethylation. And according to the Walsh Research Institute, nutritional support for treating underlying imbalances can be at least as effective for treating anxiety and depression as drugs, and without the side effects. Overmethylators tend to have low blood histamine, low basophil counts. They could be high in homocysteine, have low plasma zinc, elevated copper, and elevated levels of the neurotransmitters serotonin, dopamine, and epinephrine. Overmethylators tend to be hyperactive ADD or ADHD type personalities. Now you can have symptoms that fall under low methylation and some that fall under overmethylation. It is important to understand you are dominant in either over or under methylation, but the symptoms can change from one to the other due to the fact that there can be a tug of war taking place inside the body between over and under methylation. It just depends on what SNPs or genes you may have and how they are expressing themselves. Let's take a look at the different genes and SNPs or enzymes that affect methylation. All of these methylation genes play a big part in your ability to methylate properly. They are also a very important factor behind our moods and our personalities. Everyone's personality has a root in brain chemistry and other biochemical processes in the body, and these genes are some of the bigger ones that play into your personality and your methylation. Please pause this video to review this slide. We will be talking more about these when I show you where they fit into the methylation cycles, but I have put together slides listing all of these genes, SNPs, what they do, the symptoms, and the lab testing. The link to those slides will be in the description. The reason I did this was to make it much easier for you to go back and find your unique set of genes and SNPs, what they do, and the tests that may go with them. So let's take a look at the most important mean mother gene that turns our worlds upside down and causes havoc in our bodies, our moods, and our health. The MTHFR genes. These are the methylation master genes. If you have the MTHFR, it's going to disrupt the entire methylation processes and come with a host of other gene issues and possibly over 100 different SNPs. That's going to cause you some issues unless you know how to work with it. It's been theorized that this gene is one of the main reasons behind our ever-crowded hospitals and doctor visits. The MTHFR is going to affect your brain chemistry, your antioxidant production, like making glutathione, because remember, it's a vital component to detoxing your body. The MTHFR is also going to affect your energy production, detoxification, your genetic expression. It's going to increase your inflammation levels and interrupt so many crucial processes in the body. You're going to feel a very big difference between your good days and your bad days. The most common MTHFR mutations, or polymorphisms, found in humans are the Charlie 677 Tango and the Alpha 1298 Charlie. The 677 Tango is associated with reduced enzyme activity, elevated homocysteine levels, and altered distribution of folate. If it's heterozygous, which means it came from one parent, you'll have approximately 40% loss of function. If it's homogeneous, which means it came from both parents, you'll have approximately 70% loss of function, and this is going to affect your health greatly. With the 1298 Charlie, this mutation also impacts the MTHFR activity and homocysteine levels, but to a much lesser extent than the 677 Tango. With having one mutation, the heterozygous, you'll have about a 20% loss of function, whereas if you inherit it from both parents, the homogeneous, you have approximately 40% loss of function. Having this particular genetic mutation is a little bit easier to restore your body back to homeostasis, but you tend to have a lot more SNPs with it, and you'll have to address them all. If you have both the 677 Tango and the 1298 Charlie, you're going to have at least a 50% loss in function, and it will also depend on how well you take care of your health, what environment you live in, your diet, and lifestyle. When it comes to these genes, nutritional biochemistry is going to be absolutely essential for those with MTHFR. It is also very important to realize and keep a good mindset that you're not broken, even though I know it can seem extremely difficult at times. You need to remember that you are just different and need a specific lifestyle, diet, vitamins, minerals, and enzymes to keep your body healthy. Drugs can further alter your biochemistry, making it much more difficult to get your body back to homeostasis or health. These are some of the most common conditions linked to MTHFR. The condition that results is a direct link to which of the MTHFR genes you have and the associated genes, SNPs, you possess that talk to each other that are unique to you. And because genetic expression is directly linked to the condition your cells live in, your lifestyle, diet, nutrition, etc., it's up to you how these genes express themselves. So make sure you're supporting them properly to prevent these conditions. There are unique testing protocols to help you deal with your MTHFR mutations, so you can help your body return to homeostasis. It will pinpoint where all your deficiencies are and how you're burning through them. This is an excellent tool in helping you to heal. However, if you're going to the doctors and want insurance to pay for it, this part can be a little tricky. Certain tests like the Genova Ion Profile Test and the SpectraCell Comprehensive Micronutrient Panel may not be directly available to your particular clinic or doctor. You may have to look up what each test measures and individually test the items separately on the lab order sheet. Your doctor can do this for you. However, if you want the full test, you can go to the website located above, danpursermd.com, and order them yourself. They'll even send you the materials to draw your own labs if you are trained and know how. Otherwise, you can take the test and have a lab draw them for you. You just need the doctor's order to the lab to do it. You can still heal without these tests, but if you're having difficulty healing or have the combined 677 Tango and the 1298 Charlie, you and your doctor may need them in order to help you recover. There are different doctor-formulated protocols that can help you make a recovery, but everyone is going to be a little different. What works for one person isn't going to work for another. So we're going to focus on what you can do to improve your MTHFR methylation issues. Properly supporting the MTHFR genes will help you significantly. One helpful thing that almost everyone can do is soak and scrub, which will help your body to detox. What does this mean? You take a water-only bath, nothing in it, and then you just soak. Have you ever noticed that you get all pruny when you're in a pool, bath, or shower too long? Believe it or not, being in water can be very dehydrating. But that can be a good thing for us. Water can help draw out the toxins to the skin, and then you scrub them or wash them off. You absolutely do not want clay or salt or any other ingredient in the water. The clay can pull them out too fast and cause a terrible reaction, or you can react to the clay itself. The salt actually helps you to retain water, which in turn helps your body retain the toxins as well. And in order to help these genes out, we need those toxins to come out of the body, not getting stored in the body longer because of the salt. Just remember to drink plenty of fluids during and after your bath. These protocols here that are listed above are formulated by Drs. Lynch and Purser. Some folks are going to have to take this route in order to heal methylation, like those who have both MTHFRs. There are other steps such as detoxing baths, sleep, and other dietary and lifestyle changes that you'll need to make. Just a word of caution though, if you have damaged liver or methylation is far too low, the more supplements and drugs you have, the more they alter biochemistry and can toxify the liver. If your methylation has taken a hard hit or crashed, it's directly affected the liver as well. Taking too many of them or in too high of a dose can further harm your liver and therefore slow methylation even more. So if you choose this method, take it slowly, follow directions, and listen to your body. If you have MTHFR gene mutations, there are going to be foods that you will absolutely have to avoid. One such ingredient in foods is added folic acid and folate. Besides being bad for your overall health in general, many processed foods have added folic acid or folate, and these are man-made substitutes that you can easily get in leafy greens. Those with MTHFR have to avoid these added folates and folic acids because it will prevent their natural folate metabolism from working properly. And you don't want that because it will hamper and cause further issues with your methylation. You'll also notice a chart with foods that are bad for MTHFR. Even though these foods look like they're healthy, they have powerful substances in them that are powerful enzyme and metabolic inhibitors. These inhibitors can mean reduced methylation, reduced ATP, again that's your chemical that your mitochondria makes that helps give you energy, or possible immune responses. On top of that, you'll also make fewer amino acids and your body will not be able to make as much protein as it should. This will also lead to reduced glutathione, and that's your body's master antioxidant, and lower your immunity. If you already have an issue with homocysteine, some of these healthy foods will make it much, much worse. Let's look at green zucchini, which, believe it or not, is different from yellow zucchini. It has a powerful enzyme combo that can halt methylation in its tracks. So if you're wanting zucchini, grab the yellow ones and skip the green. Carrots can also slow down your methylation, and oranges have citric acid, vitamin C, which are very powerful haptens. If you're having issues with methylation and you're having issues with your mitochondria, you're going to have horrible reactions. Even though these healthy foods are important and have vital nutrients, phytosterols, minerals, and vitamins, they must be eaten very carefully and with full knowledge of what you can and cannot handle that day. So if you're already feeling a bit off, don't touch them. The more that you support and heal your methylation and mitochondria, you'll be surprised you might be able to tolerate more of these foods, but only very rarely. But keep in mind, no matter what, they're going to affect your methylation. How are we doing so far? I know it's a lot of information to take in, so right now is a good stopping point if you need to take a break and come back to it at a later time. So let's take a closer look at the methylation cycles. It'll give you a better understanding of just how important these cycles are, how they work, and how diet and lifestyle impact them. With this knowledge, you'll also be able to tell what cycles are hampered just by what you can and cannot eat, as well as your particular symptoms. This will also help give you a much better understanding of how to heal them. If you're just listening to the video, this may be where you want to start watching it instead. This is so that you can get a good grasp on the methylation cycles and how they work. A picture says 1,000 words. This will greatly help you understand what's happening in the body, the why, how to fix it, and where the different foods, symptoms, and genes fit into it. We're going to start by looking at the simplest version of the methylation pathways and slowly work deeper into it. This first one is the main methylation cycle, which is also called the Methionine Cycle. Then we have the Folate Cycle, followed by the BH4 Cycle, and the Urea Cycle. Think of these cycles like a bunch of gears that need to be constantly turning in order for you to metabolize and produce biochemicals that allow methylation to work efficiently. These gears are all incredibly dependent on one another and constantly talking to each other. If one of these gears isn't working properly, it isn't going to be able to turn the gear next to it. If these gears slow down, speed up, or even stop, it will hamper your methylation and affect your overall physical and mental health. When methylation is turned off or the gears become significantly hampered, toxins are going to build up in the body. It's unavoidable. Also, you won't be creating enough SAM-E, and without enough SAM-E, a number of important molecules cannot be efficiently produced, and these include glutathione, which is your body's master detoxifying molecule, coenzyme Q10, needed for mitochondria, melatonin, serotonin, a necessary neurotransmitter, nitric oxide, norepinephrine, and epinephrine, which help control your allergic reactions, L-carnitine, cysteine, and taurine, both of which are also necessary to keep methylation working. So many key functions will shut down. During the day when methylation runs out or slows and stops, it's quite noticeable. First may come the crushing fatigue, followed by itching for some, headaches, pain, far more sensitivity to foods, chemicals, etc., and the body kind of feels like it's coming to a grinding halt. Stop, do not pass go, do not get paid, go directly to bed kind of thing. For some, it's as simple as taking a nap, and for others, it's going to take much longer. During the night, it's also important to note that methylation already naturally slows because it's following your circadian rhythm. So if they're hampered on top of that, you're most likely going to feel it. Some of you may not notice this as much while sleeping and are able to sleep through it, but you may have a hangover type feeling in the morning, or you just have a plain hard time getting up. You can also awaken feeling absolutely miserable. You may wind up staying in bed for the rest of the day or until about midday. When this happens, drink lots of water during this time and try not to eat anything at all to give your body a chance to finish dealing with the toxins and filtering them out. Once it's done, you may notice energy come back and you start feeling a lot better. For those of you who are suffering at night and it is waking you up, most believe this is a histamine dump, when in reality it's the toxins and the histamines that are building up due to the slowed or halted methylation cycles. You're not drinking and you're not moving around, which helps detox them. So it may also trigger the adrenal glands, making it very difficult to sleep. To combat this, you're going to want to drink 20 to 40 ounces of water, and this will greatly help you. The water will flood the body and neutralize histamine because histamine is water soluble, and it also helps flush out the toxins, turning the adrenals back off. One can usually fall back asleep within 45 minutes to an hour. Yes, you'll have to get up more to use the restroom, I get it, but it's far better than the histamine and toxins building up and causing more damage to your body and to your methylation cycles. Medicine can't really help so much with this, and with slowed methylation, it'll have to try and metabolize it as well, which will be harder for it to do. So, as you can see, if your methylation gets too hampered or stops, you're going to feel a lot more symptoms. The resulting toxin and histamine load is going to cause more damage to the body and your methylation cycles, including bigger histamine buildups in the future, homocysteine buildup, which causes more inflammation and damage to your cells, mitochondria, organs, brain, and nerve tissues. It's also going to cause changes in your DNA expression and result in damage to your DNA. And lastly, it can also create genetic mutations. One good example of this is the c-KIT, the D816V mutation. If you take on too much damage in the body and are constantly under stress, it's going to create a mutation in the myeloid stem cell system. And you can see here that this encompasses your mast cells and the rest of your white blood cells. So this is going to have a definite impact on how your immune system works and not for the better. Your mitochondria also plays a vital role in keeping these gears turning. They produce important biochemicals that directly feed into the methylation cycles and are essential for proper metabolism and methylation. So how this works: the nutrients from the food you eat gets absorbed by your gut, goes to the cells, which also contain mitochondria, then to the methylation cycles to be methylated or metabolized, and then back to the cells. As we have talked about in previous videos, if you aren't eating the proper nutrients or have damaged mitochondria, this will greatly impact your methylation because it can't get the nutrients it needs. This in turn is going to affect your energy levels, mental, and physical health significantly. Okay, we're going to look at what each cycle does. Your methionine cycle is your meats and protein cycle.
Barbecue.
The folate cycle is your fruits and veggie cycle. To be more exact, it is your fruits and leafy greens. And what's so cool about this is that the leafy greens are already methylated. And you know what that means? It means it will help your methylation cycles. And I know what some are thinking, but I can't. I am not a rabbit. Aren't they cute? They're so cute. Okay. Back to all seriousness. I know most of us are worried about oxalates and salicylates because that's just part of our mast cell journey, and one we're going to have to deal with sooner or later. Because parts of our methylation cycle and our gut microbiome is a big key to this. But, good news, you can heal this so you can add them back into the diet. There's only a few exceptions, but the answer is all in the healing. So it's very important to get as much methylated folate from dark leafy greens as possible because it's the right type of folate for your folate cycle. Because it is methylated folate, it doesn't put any additional burden on your methyl groups and helps the folate cycle perform more efficiently. It's okay if you can't tolerate it yet. There are a few other options to choose from. I know this still doesn't help everyone, but do your best to try to get as much as possible from plant foods. You can get folate from meats and proteins, but it's not methylated and can put an additional burden on your folate cycle, which was meant to get it from methylated fruits and veggies. It's kind of like robbing Peter to pay Paul. It can function, but it isn't as efficient because it has to methylate this form of folate, putting a higher demand on your methyl groups, and this can further hamper your methylation cycles, especially with the MTHFR gene mutation. Too much meats and proteins can bog down the methionine cycle as well, Plus, it needs a well-functioning folate cycle to give it the necessary vitamins, minerals, and folates and methyl to work properly. If it's already hampered with something like the MAT gene, which helps break down your meats and proteins, it's going to place further burden on it, and it can affect your SAMe, your COMT gene, homocysteine, your moods, and it will affect your health as well.
It's too sad to walk.
So listen to your body. It's telling you what your methylation cycles can and cannot handle. Next, we have the BH4 cycle. Simply put, this cycle governs your neurotransmitters like serotonin and dopamine. This is also where one of the MTHFR mutations exist, and this can have a huge effect on your moods every day. And lastly, here we have the Urea Cycle. This cycle governs the waste that exits your body through the urine via the kidneys. This also helps for a speedy exit for all those harmful biochemicals that can harm our body. Next, we're going to go into further detail with each cycle and how it works. The main methylation cycle regulates the balance between methionine and cysteine, which is an essential protein amino acid, and it's needed for metabolizing protein. This cycle is also very important because methionine is an absolutely essential amino acid in humans. Methionine plays a critical role in the metabolism and health of many species, not just humans. It's needed for amino acids like cysteine and taurine, methylation, SAMe, and glutathione to function. So here in this illustration, you can see your sources of methionine come from the meats and proteins, as we've already discussed. Now you can see there's a MAT gene, and this gene dictates how it metabolizes it. This is where some folks could have trouble eating meat if they have a MAT gene mutation. There's a lot more going on in the background other than just histamine issues. CH3, that's your methyl group, is provided to the body through a universal donor known as SAMe. SAMe readily gives away its methyl group to other substances in the body, which enables the cardiovascular, neurological, reproductive, and detoxification systems to work properly. It uses SAMe to methylate with cysteine, which results in glutathione production, polyamines, which results in cell proliferation, which is how cells grow and divide to create more cells. And it also is used for proper methylation of DNA, RNA, and the protein itself. However, the system that produces the SAMe is completely reliant on one switch being turned on by a critical B vitamin, that's your B12, and 5-MTHF. This is from the folate cycle and is known as active folate or methylfolate. The folate cycle. This is the cycle that governs metabolizing your dietary folate. Those are your different veggies and fruits. The folate cycle turns it into products that help the methylation cycles. It is also an essential component to your main methylation cycle or methionine cycle working properly. Folate metabolism is extremely crucial for many biochemical processes. For example, mitochondrial protein translation. And this just basically means it's needed in order for your body to create ATP, which is the energy you feel, and also for the health of the cell. Methionine regeneration. Basically all this one is saying is it takes the harmful homocysteine, reconverts it back to methionine, where it goes through the whole cycle to be remethylated all over again. Purine and thymidine monophosphate biosynthesis. Purine synthesis, that basically just provides the necessary energy and cofactors to promote cell survival and proliferation. Thymidine monophosphate synthesis. This basically catalyzes a crucial step in DNA synthesis. Now, in order for the folate cycle to work properly, it depends greatly on that MTHFR enzyme. These biochemical processes in turn support critical cellular functions such as cell proliferation, mitochondrial respiration, and epigenetic regulation. This is where you can change how your genes are expressing themselves. So let's take a look at how this process works. It takes your dietary folates, which is called tetrahydrofolate, and those are your fruits and vegetables. Then it adds the MTHFR enzyme to it, which then creates the 5-MTHF, which is your CH3 methyl group. So as you can see, the folate cycle is crucial for helping to create your CH3 methyl groups, 3 hydrogens and 1 carbon, by metabolizing your fruits and vegetables. Now, not surprisingly, abnormal folate metabolism has been linked with a myriad of diseases, including the #1 cause for colon cancers. It's estimated that approximately 60% of people in the US have a genetic mutation that makes it challenging for their bodies to create enough 5-MTHF. If cycles aren't working properly, or you have critical vitamin deficiencies like B12, don't eat enough veggies, or have issues in the MTHFR, you won't be able to transfer the 5-MTHF and critical B12 vitamin to the methionine cycle, which in turn will make that cycle suffer as well. On the flip side, if you're getting enough folate and or are taking too much folate or creating too much methyl, then taking them can result in a buildup in the body and cause a folate trap, which means it'll make you very sick versus helping you because it can't be used and it's just building up in the body. So with that being said, many of us take methylated B vitamins known as methylcobalamin or hydroxyadeno B12, which is fine if you have the MTHFR gene mutation. But if you have excess B12 in lab reports, you do not want to take it. Just be extremely mindful when taking B vitamins and folate so you don't cause excess folate in the body. If it makes you sick, stop and cut the dosage in the future. Okay, we now know that the folate cycle needs to be working in order to help the methionine cycle completely work. So let's take a little bit further look into the methionine cycle now that we understand what we need from the folate cycle to finish the job in the methionine cycle. Okay, we'll take this slow. You know that the methionine cycle requires meat, and you get some of the nutrients from your mitochondria, and then you get some of them from your folate cycle, which the folate cycle activates your SAMe. It goes around until you get to homocysteine. When you get to homocysteine, it has a choice to make. It's either going to go around the circle again, which is the remethylation cycle #1, or it can take a shortcut, which is the arrow going through the middle, back up to the SAMe where it goes around again until you get to homocysteine. When it gets to homocysteine, it leaves that cycle and goes down, which is your transulfuration cycle. So the important thing to remember is once the cycle goes around to get to homocysteine, depending on the available nutrients it has available, it can take path 1, path 2, or down to the transulfuration. Now some of you may be asking, why are we going through this? Why am I taking this step by step? Yes, it is boring, but it will help you to understand what foods, sups, and medicines you can and cannot have. It'll also tell you where your symptoms are coming from so you can fix the problem. It'll also tell you what part of methylation is suffering from so you can prevent it from getting worse. You'll understand what your lab tests are all telling you, and most importantly, you'll be able to heal your body and which method you'll need to use to do it. So that, in a nutshell, is why we're going through this with a fine-tooth comb. Yes, it's boring, but it's definitely necessary. Okay, these are the 3 paths spelled out. In the methionine cycle, this is your meat cycle, the methyl that is actually created from your meat is activated by ATP. The ATP comes from the mitochondria, which is created by the dietary folate and some of the meats you have consumed. So, ATP activates the methyl, which makes methionine methyl. This activated methionine methyl is accepted by SAM, who adds adenosine to create SAMe. The SAMe gets methylated again and converts to SAH, which is S-adenosyl homocysteine. So it's a precursor to homocysteine, and then consequentially into homocysteine by the removal of adenosine. So the methionine cycle is primarily just this, the adding and subtracting of methyl to form new compounds like SAM, SAMe, SAH, and homocysteine. Now, when it gets to homocysteine, remember it can take one of three paths. Path 1, where it can go around the methionine cycle again, going back to the top. Path 2, where it can take the shortcut in the methionine cycle. Both of these options are called remethylation because it's repeating the methionine cycle over again. Or path 3, it can leave the methionine cycle and enter the transulfuration process. Once it takes the path of transulfuration, it cannot come back through the methionine cycle or be remethylated. If homocysteine takes remethylation path 1, it starts the cycle back over, but in order for it to be reconverted back to methionine, it needs vitamin B12 in order to transfer a methyl group from methylated folate called 5-MTHF to be added to homocysteine. And remember, it has to get this from your folate cycle. So if it takes remethylation pathway 1, it basically has to go through the entire process again of transferring the 5-MTHF, the B12, needing the mitochondrial ATP, and going through all the SAM, SAMe, SAH, all the way to homocysteine again. If homocysteine decides to take the remethylation path 2, it is a shortcut straight up through the middle of the cycle. It uses methyl from betaine, TMG, which is trimethylglycine, to be transferred to the homocysteine. This step actually takes place and goes through the liver to accomplish this. Betaine, or TMG, which means it has 3 methyl groups it can donate. So betaine can replace all the steps that was needed in pathway 1, and then you can see why it's a shortcut. But this pathway goes back up to SAM and starts the process from there. And this time betaine activates the SAM. This pathway, however, does require choline because this path takes place in the liver and the liver needs choline in order to methylate properly. And what biological pathway isn't complete without a but? This pathway will not work if you have the BHMT genetic mutation. It effectively closes this road. If you take the supplement betaine or TMG in order to give yourself more methyl and have the BHMT gene mutation, this is where you can cause you to have too many methyl. Remember, too much methyl is just as detrimental to your health as not enough methyl. So if you take it with this gene mutation on top of a possible MTHFR gene mutation, it is going to give you the worst kind of anxiety you have ever felt. You definitely are going to feel like you want to crawl out of your skin. So if you have to take TMG for any reason, and you get this side effect, GABA or drinking a lot of water can help calm it down. So this is a good indicator that you may have the BHMT genetic mutation and most likely one of the MTHFRs. Alright, last option and the third option, the transulfuration pathway. Once it enters the transulfuration pathway, it utilizes vitamin B6 to convert it to the amino acid cysteine. It's been estimated that 60% of homocysteine is metabolized in the transulfuration pathway, and this takes place in the liver or the liver cells. With glucocorticoids, it can increase that percentage. Glucocorticoids are a type of corticosteroid that are involved in the metabolism of carbohydrates, fats, proteins, and have anti-inflammatory properties. Now, if you have inherited methylation issues like the MTHFR, or overtoxification of the liver, or damage of the liver, as well as B6 deficiency, this can greatly hamper your transulfuration pathways in the liver, so it's important to be careful of what you're eating and how much. Once homocysteine has been converted to cysteine, it will then be converted either into taurine or GSH, which is a precursor to glutathione. And again, that's your body's master detoxifier. Cysteine also breaks down into ketobutyrate And basically that regulates mitochondrial respiration, and that's the transfer of nutrients back and forth, and then oxidation. So in conclusion to this section, you can see that the main methionine cycle is important for the synthesis of homocysteine into much less harmful products. The methionine cycle and the folate cycle are dependent on each other working properly, as well as the mitochondria functioning properly, feeding into these cycles. So you can start to see just how dependent upon each other these cycles are. If one is hampered, the others are hampered as well. The BH4 cycle. Basically put, the BH4 cycle helps make serotonin and dopamine, which are neurotransmitters. BH4 is a cofactor, which means it's needed in order to convert tryptophan into the neurotransmitter serotonin. It does the same thing. You need BH4 to take tyrosine and transform it into dopamine. So you very likely have already heard of serotonin. It plays an important role in regulating muscle movement and your mood. If it's not working properly, then you have issues of depression and even trouble with your muscles and movement. Dopamine is another neurotransmitter. Your body makes it, and your nervous system uses it to send messages between nerve cells. That's why it's sometimes called a chemical messenger. If there's any issues here with your dopamine pathway, there's a good chance you could be a bit clumsy, or you may feel like sometimes the signal didn't get to your arms or legs fast enough, or you could possibly feel kind of twitchy. Dopamine is also a feel-good chemical. So the BH4 cycle is basically just your neurotransmitters. And lastly, we have the Urea Cycle. In simple words, the Urea Cycle is a biochemical pathway that converts the ammonia present in the body to urea, or urine. This cycle helps to excrete two harmful gases, ammonia and carbon dioxide, from the body. You can see the mighty mitochondria plays a part specifically in the Krebs cycle to make this cycle work. But before we dive into the urea cycle, let's look at where the ammonia comes from first. Our bodies are mainly comprised of protein, and protein is required to perform a wide variety of functions. Enzymes, hormones, clotting factors, receptors, they're all proteins. And our body completely turns over approximately 1 to 2% of the protein in our body on a daily basis. This is mostly involving our muscles. So millions of proteins are broken down in our bodies every single day, and these proteins are broken down into amino acids. Amino acids are basically nitrogen-containing molecules. This nitrogen in the molecules is a big source of nitrogen waste in the body, which is also highly toxic to us. So this is the basic step-by-step process. We have proteins that are broken down into amino acids, which causes nitrogen waste. And we know this is toxic to us in many ways, especially for the brain. So we know that this gets transported to the liver. And remember, the liver filters the toxins from your blood 7 times an hour. So it's a highly efficient and resilient organ. Then, within the mitochondria in the liver and the cytoplasm of the liver cells is where the process takes place, converting the ammonia into urea. Because of this, it's yet another reason why mitochondrial health is crucial to your methylation cycles as well as the health of your liver. The mitochondria makes ATP, that's the fuel and energy you feel every day, and with mitochondria dysfunction and significant methylation issues, you can't make as much ATP either, and that means the urea cycle can't work converting the toxic free ammonia into urea. So if this cycle isn't working because you have liver damage, and remember the cells in the liver are going to be affected, which then affects your mitochondria, you're not going to be able to filter out ammonia or nitrogen. And this can build up in the blood and be extremely harmful to your body. And unfortunately, these two things cannot be flushed out with water. So the ammonia and the nitrogen can travel to your brain, and it can cause a lot of memory loss, behavioral changes, coma, seizures, or brain damage and neuroinflammation. So to keep this cycle working properly, you gotta take care of your liver and you gotta take care of your mitochondria. Are you starting to see how everything is tied together? So in this section, we learned what the Methionine Cycle, the Folate Cycle, the BH4 Cycle, and the Urea Cycle does. Next, we're going to take one step closer at this, and I promise it's the last time. We are going to look at where the genes fit into this. You'll learn how the genes talk to each other, what symptoms are associated with each, and you'll understand how it is affecting your methylation cycle, and a fix to each one of them. So everything we've learned so far is going to come together for you. I know this hasn't exactly been the most interesting topic and frankly sometimes quite boring, but you'll be able to see why it was so necessary to cover it all.
Phenomena. 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 Phenomena.
Alright, here is the methylation cycles with the added genes to it. Yeah, I know it looks like a confusing mess, but we're going to walk through it and explain it all. Alright, if you remember, the mitochondria plays a direct role in the main methylation cycles, the folate cycles, the urea cleanup cycle. Remember how I've been saying that the items in the cycle of illness all contribute to one another and are intimately tied together? Here's a prime example of this. The more mitochondrial damage that you get from inflammation and histamine is going to affect your methylation cycles, which in turn is going to affect your immune system and your genetic expression. The better you understand how the methylation cycles work, the easier it becomes to break this cycle.
And knowing is half the battle.
This diagram shows you where all the genes fit into the methylation cycles. There are some genes that are a part of methylation that don't fit directly into these cycles, but they contribute greatly to these cycles. Also, there are methylation detoxification genes, and depending on what company you go through, will dictate how thorough the gene list will be for yourself. But the genes listed here are basically the big ones, and this will get you started in the right direction. All the genes we're about to discuss in this part of the video will be made available shortly after the video comes out. Your genes are made up of DNA and RNA, so let's look and see real quick where they come from. DNA and RNA are in your cells and in your mitochondria. DNA comes from both parents, and your mitochondrial genes come only from your mom. While I'm telling you who you get what from, your gut microbiome also comes from your mom. So whatever her microbiome is will most likely be yours. I'm also going to be discussing what minerals and nutrients and supplements help support the individual genes, so do not go out and buy them all. If you're thinking about treating your gene mutations with more meds or supplements, think again. Doing so without understanding how the genes are interacting with each other, especially within the methylation cycles and mitochondrial damage, it could have a very harmful consequence. It's important to understand that, like drugs, supplements are just as or even more potent than drugs. This also means they can affect other aspects of the body, its systems or organs. It's very important to address healing these cycles with detoxing, diet, exercise, and something as simple as Qigong Tai Chi is extremely beneficial. And you also need lifestyle changes like getting enough sleep, reducing stress, etc. You must heal the biochemical processes, not the genes per se. We want to detox our genes, but we do not want to supplement the genes. With that being said, you may need to take a couple to help you get there. It's important to understand how these cycles work and where you're the weakest or have the greatest excesses in order to heal. But I must make this clear. Taking a supplement for everything will just further burden your liver, and you risk doing more harm than good when it comes to toxifying the liver, and it could also affect the kidneys, which essentially would burn them out. Even though you can't change the genes you were given, working with the enzymes they code for can help adjust your body and brain's biochemistry, and it can adjust the volume of how these genes are expressing themselves. Alright folks, let's do this. In the methionine cycle, and remember this is your meats and protein cycle, you have the BHMT and the AHCY gene. This part of the cycle is essential for the detoxification, managing homocysteine, DNA and RNA regulation and repair, and how it metabolizes fats and proteins. The BHMT gene. This is in that remethylation pathway 2, or that shortcut that we were talking about earlier. This gene encodes an enzyme that catalyzes the conversion of betaine and homocysteine. It changes it to dimethylglycine and then back to methionine to go back around the cycle again. This pathway is also involved in making glutathione. If you have this gene, you can have a lot of difficulties detoxifying. Taking TMG, or betaine, can help to make glutathione if your B12 and folate pathways are not functioning properly, but you need to use caution, especially if you have the COMT gene. If you use betaine and you get a terrible anxiety, that is generally indicative that you have the COMT gene, and it also generally means that you cannot use this pathway. So if you get the anxiety, you need to be checked for the COMT gene. You also need to evaluate your epinephrine, norepinephrine, and dopamine levels. Extra methyl groups from TMG can increase the levels of these neurotransmitters and lead to significant anxiety problems. If it happens, GABA can usually help tap that back down. So if you have homogeneous BHMT, meaning you got it from both parents, the COMT gene or TMG gives you anxiety, you may be able to benefit from a phospholipid complex. And if you still continue to experience anxiety, even with the phospholipid complex, it's important that you go get tested for Lyme's disease. It's also important that you get checked to make sure you don't have an antiphospholipid syndrome. With this gene, you'll also experience more gut infections. And remember, this pathway needs choline and it helps make taurine, which is important for your liver and gallbladder. You can experience difficulty in liver detoxification, and the homocysteine imbalances can cause many issues. Too much and you'll have a lot of inflammation. You're more likely to experience vascular diseases, B12 deficiencies, ADD and ADHD, and not make enough glutathione, which is your body's master detoxifier, if at all. So it's important for you to monitor your homocysteine levels and not to go below 5, because it's a risk for stroke and neuroimmune syndrome. This can happen with low homocysteine, also low in methionine, and possibly the SNP and CBS gene. AHCY gene. The AHCY gene provides instructions for producing the enzyme S-adenosyl homocysteine hydrolase. That's a mouthful, I know. Remember when we were talking about SAM being converted to SAM-E, being converted to SAH, and then being converted back to homocysteine? That S-adenosyl homocysteine hydrolase is the SAH. So the AHCY gene affects the process from SAH to homocysteine. If you have this gene, it activates the harmful homocysteine. It's also involved in regulating your SAM-E levels. It is crucial that the AHCY immediately converts your SAH to homocysteine and adenine in order to maintain optimal methylation. So if you have this gene, that's going to be very difficult to do. You may wind up activating the harmful homocysteine. So homocysteine is an amino acid that is involved in maintaining the methionine cycle. Elevated homocysteine levels are well-known risk factors for chronic disease, particularly cardiovascular, diabetes, and neurodegenerative disorders. Those with this SNP may have chemical sensitivities to perfumes, smoke, and strong odors. It's the only enzyme known to convert SAH to homocysteine, which is extremely important for methylation. you're going to have higher levels of systemic inflammation, and it's linked to cancers. Signs of this mutation can result in Wilson's disease, liver abnormalities, hepatitis, back pain, a lot of it, nerve pain, schizophrenia, decreases muscle tone, meaning that they can get really hard, and more generalized pain, possible excess copper, and glutathione deficiencies. People with this gene may need to supplement with SAM-E. And those of you with this gene, you really got to be careful and watch what you eat and watch your inflammation because it will kick your butt. So if you're having a really hard time with this gene, these are the tests that your doctor can order that can help you out. Moving on, the CBS gene. This gene is responsible for the homocysteine transulfuration process. The CBS gene provides instructions for making an enzyme called cystathione beta synthase. This enzyme acts in a chemical pathway and is responsible for using vitamin B6 to convert homocysteine and serine to cystathione. The CBS enzyme could work too fast, which results in overmethylation. This also creates rapid conversion to taurine. And taurine is important for your methylation cycles, your liver, and your gallbladder. It also helps with your salicylate sensitivities. So you can see it goes from homocysteine to cystathione, and then offshoot to cysteine, and then glutathione. Well, this gene can turn that pathway off. Individuals with this SNP generally have issues with processing sulfur-based foods and supplements. This may cause issues because sulfur is necessary for controlling blood pressure. Blood pressure medication usually contains sulfur. This is what makes them effective. Taking all sulfur out of your diet can cause high blood pressure and complication. It can also further deplete your glutathione levels because glutathione is dependent on sulfur. So if you develop glutathione deficiency, it's important to try high and low sulfur diets and see how you feel. You may be able to tolerate it some days and you might not be able to tolerate it other days. That's okay, that's normal. If you feel horrible on high sulfur, you most likely have issues in the transulfuration pathway. You're going to want to test your ammonia levels and your molybdenum levels. If your molybdenum is low and your ammonia is high, there's a problem in the transulfuration path in processing sulfur. Okay, this only works if you're not estrogen dominant. You may be able to take yucca, butyrate, or charcoal to break down ammonia and supplement with molybdenum until the molybdenum levels goes back up to break down sulfur in the body while keeping some of your sulfur in your diet. If your ammonia and molybdenum levels are good, just stay off of sulfur foods for a few days to relieve your sulfur burden. If you have multiple CBS SNPs, you're going to want to monitor your B6 levels because these SNPs make it difficult to maintain them. Overuse of antibiotics can hijack and cut off the transulfuration pathway, leading to sulfur sensitivity as well as leaky gut and high oxalate levels. Oxalates are bad juju, so you want to heal your leaky gut and use low oxalate diet. GMOs can actually block your transulfuration and CBS pathway. So if your ammonia and molybdenum levels are fine and you're having issues with sulfur foods, the GMOs are actually blocking the transulfuration pathway. Those with CBS will produce more sulfur end products in the methylation cycles, which can make you more sensitive to sulfur. This is why folks may react to things like cruciferous veggies, garlic, and other supplements. This will affect your ammonia detox, and it can affect certain enzymes that have negative effects on blood sugar, metabolism, red blood cell formation, blood vessel stability, leading to easy bruising, bleeding and broken blood vessels, along with vascular imbalances. This can also deplete the BH4 cycle. Can also deplete SAM-E, which will raise histamine levels and lower your energy levels. CBS can combine with the MAO B and COMT and will have higher anxiety and stress levels. Those who possess this gene may experience brain fog, headaches, blood sugar issues, possible increases in viral infections, unless you have the COMT gene. It's like an annoying superhero that fights against viruses. So if you're one of those folks that never get the cold or the flu, but have a lot of health issues, that's because of this guy. So at least it's good for something. And we'll be talking about the COMT gene later on in the video. And you could also experience anxiety and insomnia from higher cortisol levels. It can cause low B12 because it passes through the urine too quickly. It can overload your detox pathways, cause food and chemical sensitivities, cause dairy intolerance, chronic infections, chronic pain, depression and mood issues, leaky gut, fatigue, increased cortisol, ammonia buildup, which leads to neurological issues, heavy metal toxicity, anxiety, alcohol intolerance, sulfur intolerance, and this is your MCAS and MCAD gene. Plus, if you combine the CBS gene with the SUX gene, so if you have both of them, you're going to have a much harder time tolerating quercetin. If it's compounded with any of the MTHFR genes, you'll most likely not be able to tolerate quercetin at all, and it'll wind up causing more harm than good in many of us. So if you have the CBS gene, you may need to support it with NAC. You're going to want to skip B6 supplements because the B6 will speed up your CBS pathway, and what happens is you're going to start peeing out more of those vitamin nutrients much faster. You're also going to want to make sure your zinc is good and your molybdenum is good. Okay, so when it comes to B6, especially those of you who have B6 deficiencies, which I know a lot of you out there do, if you have the CBS, and whether or not you have the SUX gene with it or not, the B6 deficiency is telling you that there's another problem in a different section of these methylation cycles. And in order to address your B6 problem, we need to heal a different section within the methylation cycles. And we will get to that. And I hear you when you guys are sending me your messages, but Donna K, I do not have enough B6. I have to have B6. I gotta take it. I get it. I hear you. I promise you I hear you. But if you continue to take B6 with that CBS gene and you're really hampered, you can wind up putting yourself in a negative feedback loop. In order to fix your B6 deficiency problem, we have to heal a totally different section of your methylation cycles. So this is why I say taking necessary vitamins and minerals to heal each and every single gene can wind up causing more harm than good in the long run, because all these genes are talking to each other. And I know big B6 is a big one for a lot of folks. So I wanted to address that here. The SUX gene. This gene is part of the detoxification process for your body. It detoxes sulfur and sulfites. It converts sulfite to sulfate and requires molybdenum to function. If this pathway is hampered, it can impair brain function. Your body, however, does require a large amount of sulfur in order to keep it running and especially detoxing properly. It helps with blood flow, joints, gut lining repair, the elimination of hormones and neurotransmitters, and it helps with creating glutathione, which is again your body's master detoxifier. The sulfur comes primarily from your protein, cruciferous vegetables, and foods rich in cysteine. There is a lot of folks that cannot tolerate sulfur well, and it is suspected the microbiome and an ill-functioning detoxification pathway are to blame. If sulfite levels rise in the body, it can cause a lot of problems like asthma, severe neurometabolic disorders, neurodegeneration, seizures, mental retardation, dislocation of the ocular lenses in your eyes, muscle stiffness, and can even cause death in infants. Now this gene talks with the CBS gene and with the NOS gene. So if you have CBS gene and the NOS gene, it's going to make the SUX gene much worse. And because of this, the combination of the three genes together, it's going to make taking quercetin almost impossible. Not saying that there isn't any exceptions out there, but I'm just letting you know that this is a good reason why many of you cannot take quercetin. So if you're having a lot of problems with sulfur and you're having a big issue with this gene, especially if it's coupled with the CBS and the NOS, you are going to have to avoid sulfite-containing foods. And that includes wine, that's a huge one, dried fruits, processed meats, and other foods containing sodium bisulfite and other sulfites. Avoid high protein diets because this gene can be made worse with too much protein. You're also going to want to avoid high sulfur supplements. One of those examples is something a lot of folks take, like liposomal glutathione. Yes, glutathione is a master detoxifier, but it requires sulfur in order to work. So the supplement that you take is pretty much all sulfur. You're also going to need to avoid MSM. Oh Lord, please don't make me say that. I'm already tongue-tied. Or NAC, the N-acetylcysteine. Because remember, cysteine is a good source of sulfur. Now, I know in the CBS gene, we said that NAC was a helpful tool for keeping it functioning. We also discussed how CBS talks to the SUOX. So here's the deal with this. You can take NAC as long as you're getting enough molybdenum and it doesn't run out while you have more sulfite to detox. And if you don't know all of these intricate rules, you can really wind up making these cycles worse because of all the cross-talking the genes do. So it's not always best to take supplements to heal. Sometimes you just need to straight up and detox and do a hard reset with a long fast. And I'm going to tell you right now, I'm one of those people, so I feel you on this one. But this is why taking the supplement route can do a lot more harm than good. So if you are doing the protein diet, you're taking NAC, or you're taking glutathione to get your body to detox, you better make sure that you're getting enough molybdenum, or you're just going to wind up going in circles and make yourself sicker. Titrate molybdenum, gosh, I can't talk today. Titrate molybdenum up or down based on how you're feeling. Remember, we need to keep our body in perpetual balance, so you don't want too much molybdenum and you don't want not enough molybdenum either. Most will also not be able to tolerate quercetin, especially if you've got the CBS and the NOS gene with it. So the SUOX gene needs molybdenum in order for it to function properly, and if it's not, it's going to impair your brain function. So you can take melatonin to help protect your brain. Now, technically, glutathione protects your brain as well, but this will only work for you if your body is making it versus taking another supplement. So if you're eating too much protein or getting too much foods, drinks, etc. with sulfur or sulfites in it, it can overwhelm this gene. So if you overwhelm your SUOX, you'll run out of molybdenum. So people on a low sulfur diet may feel better initially, but they can cause a sulfur deficiency, and your body needs that sulfur in order to run. So going on a low sulfur diet for too long can actually wind up causing a sulfur deficiency, which can further hamper your detoxification processes and create a feedback loop. And it's going to affect your mitochondria and the rest of your methylation cycles, because it's going to hamper a bunch of other functions. And because you're hampering more functions, it's going to wind up kicking your methylation cycles further out of balance. The ACE gene. The ACE gene regulates blood pressure and balances the fluids and salts in the body. It also regulates potassium, magnesium, and sodium. So those with this gene SNPs will have an increased risk of hypertension. Now the ACE, the main culprit in this, but the ADD1 and the AGT are also contributing to this. Its main job is to convert the hormone angiotensin 1 to the active vasoconstrictor angiotensin 2. So here's what happens. Your liver makes the hormone angiotensinogen, okay? Your kidneys, if there's a drop in blood pressure or a drop in fluid volume, renin will release from the kidney to the angiotensinogen. Renin acts on angiotensinogen to form angiotensin 1. From angiotensin 1 is where the ACE gene is going to come into play. The ACE gene is going to release the ACE enzyme from the lungs, and this ACE enzyme is going to act on angiotensin 1 to form angiotensin 2. Now the angiotensin 2 is going to do two things. Angiotensin 2 is also going to directly affect your blood vessels, stimulating vasoconstriction, which is narrowing of your blood vessels. It's also going to affect your adrenal gland and stimulate the release of aldosterone. Aldosterone acts on the kidneys to stimulate reabsorption of salt and water. So with the ACE mutation, it's going to affect the formation of angiotensin II, which is absolutely necessary in helping us regulate our blood pressure and fluid volume. But like everything else, too much is not a good thing. You need to make sure you're drinking water and avoiding your triggers in order to maintain homeostasis and preventing from making too much. This will also affect your ability to neutralize histamines and flush it out naturally, as well as some of the other toxins that get passed out through the urine. Now, if you can't do this, some of these toxins are going to build up in the body, which can help damage your body and further knock your methylation out of whack. And the other thing you need to understand is if this system isn't working properly, it is royally going to mess with your cardiovascular system. And all of this is going to affect how you feel on a daily basis and the severity of your symptoms. So why is this important for you to know? So the ACE, the ADD1, and the AGT SNPs affect the renin and angiotensin system in the body, with the ACE gene being the main culprit. And it can be tripped by a drop in blood pressure, which your allergens can trigger, or if you become dehydrated. Now, for some of us, if you're not drinking enough fluids, because Americans are notoriously dehydrated because they're drinking everything but water. And if you're drinking caffeine, it's flushing the water out of your system. For others, your triggers are going to be the main culprit behind this. And if your heart rate is dropping any more than 10 beats per minute after you eat something, that is a clear sign that that food is a trigger to you. So dehydration and triggers can trip this system and give you chronic hypertension. Now, some folks have a great deal of difficulty with this. And if your legs are looking like water balloons and you have a lot of inflammation and water retention, this is part of the system that's causing that problem. And through experience, I've noticed a lot of folks are still drinking soda with this issue. If you're drinking soda, you need to stop because the sodas will make this whole thing worse. So if you're running into this problem, you really need to look at what you're eating and drinking. It's also telling you you've taken on enough cell damage and your methylation and detox pathways are taking a hard hit. Another main symptom that you may experience, a lot of folks out there are having a hard time balancing their electrolytes in their body. So, based on your unique genetic disposition and methylation, this can become an issue. If you are one of these folks, fasting to allow the body to let out excess fluid retention can be handy. If you do not have a lot of fluid retention, drinking water can help you and help calm this down. However, you have to address your triggers in order to shut down this whole process that's causing this problem to begin with. The thing you need to understand is inflammation can also starve your kidneys of fluids and lead to damage further down the road. You can control what you eat and drink to help improve the way that this system operates. Hey, D here. I'm in final editing, and the point I'm trying to make that I've rewritten multiple times is that your triggers and dehydration with the ACE gene can cause you to make too much angiotensin II, which means you make too much aldosterone, which means you're going to make too much adrenaline, you're going to have anxiety problems, it's going to cause hypertension, and affect salt and fluid levels in your body. And angiotensin 1 or 2 are a form of hormone, and these are sending messages to all those organs that we were just talking about. So anyone with this gene mutation, actually all 3 of these, is going to be at higher risk of heart attack, stroke, kidney failure, hypokalemia, that's your potassium levels, inflammation, and possible lung damage. There are a few things that can definitely trigger this gene and make it worse, and that's fluoride, ciprofloxacin, and levaquin. So fluoroquinolones can definitely make this a lot worse. So what's important here is to remember that all this can be dealt with through natural options. Your doctor can test for intercellular sodium, potassium, and magnesium levels. These are important to find out if you're fully hypertensive, and measure your kidney function with the GFR. But by adjusting diet and having healthy living habits, much of this can be solved that way. Just one side note to add here, whose name I shall not mention, out of fear of angering the social media gods. If you contract this, and you have this genetic mutation and enzyme problems, this can result in much more serious hospitalizations. Also, contracting that, it is going to affect your methylation in a big way and cause mitochondrial damage. So just be aware that if you have a lot of these mutations, it's going to affect a lot of the things we've been talking about in the entire cycle of illness as well. Just one last thing on this slide when it comes to the ACE genetic mutation and the enzyme. This is going to up your cortisol levels. So how we've been talking about, it can affect your adrenals. So this can be a very big trigger for too much adrenaline and cortisol in the body. On top of this, if you have the COMT gene as well, these two are going to feed into each other. And the COMT deals with your norepinephrine levels. So if you have both of these together, it is really going to drive your adrenals through the roof and your cortisol levels. So this is going to cause a whole lot of anxiety and a whole lot of too much adrenaline in the body. It can get your body stuck in fight or flight. So if you have these, like I said, natural diet and exercise can help bring these levels down. But under these circumstances, you cannot have caffeine or any kind of stimulant. Otherwise, you're going to trigger both of these at the same time, and it can cause a heart attack, a stroke, or a kidney failure. If not right away, it's going to come down the line if you keep triggering both of these at the same time. It's going to put too much strain on those organs. It can also burn out your adrenals and cause adrenal fatigue. Now, in the inflammation video, I explained that Chinese licorice root can help heal adrenal fatigue. But none of that will work unless you address your diet, your lifestyle, and healing these methylation cycles. And part of that is healing your mitochondria, which feeds these methylation cycles. So you have to take care of your methylation. And now, onto the genes in the folate cycle. As we have discussed previously, the folate cycle is your fruits and veggies. This is where folic acid gets converted into ormethylfolate. And that is your 5-MTHF, which your methionine cycle needs in order to work properly. We're going to start with the MTR and the MTRR gene of the folate cycle. Okay, so we've already learned that B12 comes from your meats and proteins, all right? So in the methionine cycle, or the main methylation cycle, you'll have B12 being used and also oxidizing while in this cycle. The MTRR pulls out that oxidized B12, recycles it into usable B12. The MTRR hands over that now usable B12 to the MTR. And then the MTR takes it and it combines it with the 5-MTHF. So it effectively methylates your B12, then sends it back to the methionine cycle so that whole cycle can work properly. That's pretty much the job of those two genes. But as always, we're going to take a slightly closer look at it. So these two genes are working together to recycle the oxidized B12 into usable B12, add a methyl group, and send it back to the methionine cycle. The MTRR needs SAM, B2, and B3 to work properly. The MTR needs zinc. I cannot stress this next part enough. You must support the MTR and the MTRR with those vitamins and nutrients needed in order for it to function. If you don't, you're not going to be able to tolerate the methylfolate. So if you don't have enough B12 to start with, and you have the MTR, MTRR, which means you can't recycle B12, you're going to run out of B12 quickly. When this happens, you can't tolerate methylfolate because we need enough B12 to use the methyl portion of that folate to send over to the methionine cycle. That is actually called the folate trap. And remember, you need proper folate metabolism to help your mitochondrial proliferation, to help your RNA, and to help your cellular respiration. And mitochondrial proliferation is creating more mitochondria, which is a good thing. those with these genetic mutations can experience a deficiency in either folate or B12, and it can produce megaloblastic anemias. This is due to the defective DNA synthesis and can be reversed with large dose folate. For some of you who have the double MTR, MTRR, and got it from both parents, could have low homocysteine. When you get tested, make sure it's never below 5. You want it ideally above 13. But if your MTR, MTRR pathways are not working, you're going to need methionine, SAM-E, or lithium to help transport the B12 over. So those of you with mutations in these genes, you're at a higher risk for cardiovascular diseases, metabolic and neurological conditions, and certain cancers. There are other symptoms that you can wind up with these gene mutations, the big one being homocysteine imbalances. Just keep in mind when you're dealing with some of these symptoms, it's also in conjunction with the other genes. All of this information will be available in the slides. So with these gene mutations, you may need extra methionine, SAM-E, lithium if your pathway isn't working at all to carry the B12, adequate amounts of B12, and zinc. And remember, if you have megaloblastic anemia and you have these genes, you may need large dose folate. Just make sure you have enough B12 in your system to handle it. But whatever you do, do not take NADP and NADPH with the MTR, MTRR, SHMT, or the MTHFR 677 Tango. This will further mess up your folate metabolism. Okay, on to the next gene. The VDR. The VDR is responsible for your vitamin D uptake. Now, one thing I want to mention about the VDR, seeing that we just got done talking about the MTR and the MTRR, if your vitamin D is too low, low vitamin D correlates with low B12 and folate uptake. So if you're struggling with your B12 and your folates, make sure you take a look at your vitamin D levels. Those with this gene mutation will need extra vitamin D3 and plenty of sunshine. You're going to need to test your vitamin D levels periodically. Even if you don't have this gene mutation, if you live in a northern hemisphere where you experience winter or you have long hours indoors working, your vitamin D levels will decline. And this is because you're not getting enough sunshine. Sunshine is actually essential for helping to maintain your vitamin D levels and helping you to uptake vitamin D. Vitamin D's mechanisms of actions are antimicrobial, anti-cancer, and anti-inflammatory. It is responsible for regulating gene expression, DNA methylation, cell proliferation and differentiation, immune response, cytokine regulation, blood sugar regulation, including pancreatic function like digestive enzymes, insulin resistance, and type 1 diabetes. It also helps with your phosphate levels, and calcium absorption, and neurotransmitter formation of dopamine. Believe it or not, vitamin D is absolutely essential for your body in order to make dopamine. And this is your happy hormones. So if you're suffering from SAD or depression, get your vitamin D levels checked. Vitamin D deficiency also leads to dysregulation of the dopamine and serotonin neurotransmission, which is going to affect your BH4 cycle. Vitamin D also affects your methionine cycle, and it basically, if you have the BHMT mutation, it can actually help make that pathway work. It's not a perfect fix, but it helps it. As we said earlier, low vitamin D correlates with low B12 and folate uptake. So the thing I need to impress upon here is deficiency in vitamin D is going to hamper uptake of B12, which is also going to hamper your ability to uptake folate, which means then that can't go over to your methionine cycle. So it's going to mess up your methionine cycle. Clearly your folate cycle isn't working properly, and because of that, it also messes with your neurotransmitters, which means it's going to mess up the BH4 cycle as well. So just vitamin D deficiency alone can completely knock your entire methylation cycles out of whack. So if you remember nothing else about the VDR gene, it has to do with your vitamin D uptake And any deficiency has the power to create a huge snowball effect and mess up each one of the cycles within methylation. And this one is actually the easiest one to fix. Taking vitamin D with K, if you can have K, getting plenty of sunshine, and using a happy light in the winter if you're indoors all the time or you live in a northern climate. If you suffer from seasonal effectiveness disorder, that's usually a sign your vitamin D is too low and you might have the VDR mutation. So some of the symptoms you're going to experience with VDR deficiency is severe muscle weakness. And this can result in being bedridden due to the fact that your muscles just can't function. It also affects your brain. It'll give you depression or seasonal effectiveness disorder, like we mentioned earlier, neuroinflammation, which is spine pain and inflammation, and brain inflammation. You can wind up with neuropsychological diseases such as Alzheimer's, Parkinson's, MS, dementia, mood disorders, schizophrenia, and cognitive dysfunction. It will affect your circulatory system as well. It increased cardiovascular disease, hypertension, heart failure, heart disease, and stroke. It'll also affect your respiratory system, such as upper respiratory tract infections, tuberculosis, lung disease like COPD, decreased forced expiratory volume, that's when you blow through the tube and they measure how much force you can blow out, asthma, and wheezing. It'll also affect your pancreas, which is your insulin resistance, diabetes type 1, your digestive enzymes, and it also affects bones, secondary hyperparathyroidism, and bone loss. Can lead to serious illnesses and diseases and cancer. Those with MTHFR, MTR, and VDR have a much higher risk for thyroid cancers. I want to add one more thing here that's not part of this slide. When we're suffering from chronic illness, we tend to have troubles with mood, with our personality outbursts, etc. And methylation cycles dictate so much of our personalities, our moods, how we respond to stress, and neurological issues, along with emotional issues, that a lot of people wind up self-medicating. And believe it or not, vitamin D can be an effective treatment approach for drug abuse and addiction because vitamin D supports that dopamine we were talking about earlier. And addictions help us to have temporary normal moments or normal moods. It boosts our dopamine levels. So if you're finding yourself struggling with self-medicating all the time to help improve your mood, it is a very good indication that your vitamin D levels are too low. And if you are suffering from addiction problems and substance abuse, to help you get through the day, start taking a lot more vitamin D because it can actually help people recover from addiction issues. Okay, VDR, TAC, and BSM. I added this section because I get so many questions from all of you, so I put it in the slides and I will put it in the video. So if you have the VDR, TAC, and the BSM, this is definitely going to negatively influence your DNA expression in the methylation cycles. Now we're going to take a look at what TAC and BSM and FOC actually are. If you have VDR TAC, you're most likely going to find yourself with much lower vitamin D levels than someone that doesn't have it. You're going to make less dopamine, which is going to affect your mood. And with this, you're going to have a lot more depression problems. You will also need and will be able to tolerate dopamine precursors and methyl donors. Now, if you have the VDR TAC and a COMT gene mutation, it is going to change a little bit how this process works and how you feel. This doesn't apply to the VDR BSM or the VDR FOC, just the VDR TAC. Alright, you're going to see that I have a chart right here on the top right hand corner. It's got the COMT and the VDR TAC. The plus plus means you got the COMT from both parents. The negative negative means you have normal pathways, and the plus negative means that you got that particular gene from one parent and not the other. What's important about this here is that the COMT and the VDR TAC, depending on what your combination is, which is listed right here, kind of explains a little bit how it changes certain pathways inside of your methylation cycles. I'm not going to go into it today in great detail, but if you have any questions, it's on this slide, and you know where to find me. If you have the VDR-BSM, this specifically means the vitamin D that's in your liver and how your liver is able to use the vitamin D to help you to detox. If you have the VDR-FOC, this is a functional polymorphism that leads to different translations that leads to 3 amino acids becoming longer and less effective protein, and it affects your mitochondrial DNA, which is your mRNA. So basically what this means is with the VDR-FOC, your vitamin D metabolism pathways still technically work. They just work a little bit differently. And unfortunately, it also means that it's going to be less effective and also mess a little bit with your genetic expression within your mitochondrial DNA, your mRNA. This could lead to cardiometabolic issues. It will affect blood sugar. It will also affect your pancreatic function. This does not, however, affect dopamine metabolism, but you will need vitamin K, a low-carb diet, and supplementation with chromium. Okay, for those of you that have the VDR, the COMT, and the MAO, I cannot begin to express how important it is not to have caffeine. It is going to royally mess up your moods, your methylation, and your health. And I cannot even begin to tell you just how bad the kidney stuff can get if you have this combo and you're drinking a lot of caffeine. Please stay away from the caffeine, especially if you have high blood pressure on top of everything. And you can get away without caffeine once you start fixing your cell health and getting the proper nutrients into it, fixing your methylation, and making sure your vitamin D levels are high. That will naturally help you not need caffeine. So make sure you're eating foods rich in natural vitamin D and also getting plenty of sunlight. I'm not going to go into detail on this slide. We'll save it for the future. But this basically just outlines the vitamin D pathways from when you get it from sunlight versus when you get it from your food. You'll also see in here there's a CYP. Those are genes, and basically if you have that gene, that's an extra hamper that you're having and where those genes are located. But they do affect your vitamin D metabolism pathways. Next in the folate cycle, we're going to take a look at the 677 tango. Now, we've already discussed it in depth in multiple sections of this video already, so I'm just going to do a quick recap on it. As you already know, the MTHFR is a critical component to your methylation cycles that keeps it all running smoothly. The 677, however, if you have this genetic mutation, it's going to hamper how this cycle works because the 677 flips on folate. Okay, what does this mean to you? The fruits and vegetables that you eat is called your dietary folates, which is called the THF tetrahydrofolate. So the fruits and vegetables you are eating are tetrahydrofolate. Then the MTHFR 677 tango adds an enzyme to it, which creates your 5-MTHF. And as we've discussed, the 5-MTHF, along with that B12, goes over to the methionine cycle in order to create SAMe. And if that 5-MTHF does not go over to the methionine cycle and you cannot make SAMe, that cycle won't work either. So you can see having just this one gene mutation, the 677 tango, can throw a major wrench in these two cycles working. Hey, it's me again. So, still in final edit. My computer is rebuking me because my video is too long, so I have to do it this way right now. But my point here is, so with the 677 tango, it flips on folate, right? Which means you can't metabolize your fruits and vegetables normally and make 5-MTHF. Which means the folate is going to start to build up in your body and you are definitely going to feel it. You're going to feel it as pain, just general overall pain. You're going to feel joint pain. You're going to feel possibly muscle pain. You're going to get headaches and migraines, and it can wind up leading to cancers. I do know somewhere in this video, I do talk about fibromyalgia. For those of you who have that diagnosis, doctors generally tend not to go looking for the root cause. That is something the Mayo Clinic happened to tell me, and it's true. So you want to try not to get that overall catch-all diagnosis, because that's all it is. And then they don't look for the root cause. So if you have these problems, look at your methylation cycles and your detox pathways, because this is where it's coming from. Next, we're going to be looking at the SHMT of the folate cycle. SHMT is an enzyme which is absolutely critical for your folate cycle working. The SHMT generally tends to be just sluggish in slowing down the folate cycles unless you're deficient in B6 and iron. If you are deficient in B6 and iron, with the SHMT, it can completely halt your folate cycle. This can and will affect how the mitochondria sends the nutrients, and in which form, to the methylation cycles. In this case, the molecular chain tends to be longer and harder to break down. So what this means is when you eat food, your mitochondria metabolizes some of your nutrients, and then it's supposed to send it off to your methylation cycles. Well, because you have this genetic mutation, it doesn't process those nutrients correctly, so when it sends the nutrients over to your methylation cycles, they're not in the right form. And this means that they're going to be harder to break down for you to be able to use. The SHMT enzyme works in a bidirectional way. It turns serine into glycine, glycine aiding in the transulfuration detox pathways to make glutathione for DNA synthesis. The other direction it takes is turning THF into 5,10-methylene tetrahydrofolate. It uses serine as a methyl donor for this conversion to act as a substrate of MTHFR. What that means is it needs this 5,10-MTHF for MTHFR to work properly. With this gene enzyme mutation, your risks for cancer are going to be much higher because the buildup of folic acid and folate are very damaging to the body and a main reason behind cancer. Big main one being colon cancer. It can cause other cancers as it builds up in the body and cells. SHMT is a vitamin B6 and iron-dependent enzyme. This gives metabolic priority of the nucleotide synthesis, that's your DNA, over SAM synthesis. So what does this mean? Nucleotide synthesis is a metabolically demanding process essential for cell division and genetic expression. So if you don't have enough B6 and iron, it's going to prioritize your cell division and genetic expression instead of making SAM. And remember, we need SAM to make the main methylation cycle, or the methionine cycle, work properly and to help you detox and to help you with your moods. So without SAM, this is going to affect your MTHFR, your MTHFD, your COMT, your MAO A, detoxing, and glutathione creation. This will also result in higher homocysteine levels, and this can actually drain your cycles of important nutrients. Like we just said, this gene shifts the emphasis from the methylation cycle to new DNA synthesis for making cells. It's the I can't say it. Pyridoxal phosphate. Got it. B6 and iron-dependent enzyme. This plays an important role in cellular 1-carbon pathways. I'm not going to get into detail with that. It'll just confuse you. But it has to do with folate, methylation, and metabolism. Those with this gene will also have an increased risk of inflammation in the gut. Those who also get bacterial infections may not recover as well as others who do not have issues with this gene, especially if it's combined with the MAO A and the MTHFR SNPs. You may also be low in serotonin and folate availability for the methylation cycles. Because it can affect MAO A and MTHFR, it may lead to needing more folinic acid before taking 5-MTHF. Plus, folinic acid may get the MAO A and MTHFR pathways working again. This will all just depend on your unique set of genes affecting your methylation cycles and how they all talk to one another. So this is the more detailed process that takes place inside of the folate cycle that starts with your dietary folate and metabolizes or methylates the folates that you eat into 5-MTHF. It shows where all these genes come into play inside of your folate cycle. I also added it so you know where the MTHFD, which many of you have asked me about, fits into this entire process. Understanding the process can help you and your doctors fix your folate cycle. Now this may not seem like it, but this is a simplified version of what we're going to be talking about. So you have your fruits and vegetables that you eat every day. You absorb the nutrients and they go off into your mitochondria. Now inside your mitochondria, there's a metabolic process that takes place to convert your folates and your folic acid into active folate, which is your THF. And this is why it is so important to keep your mitochondria healthy. From there, it goes to the SHMT. And remember, this is where it branches off and makes glycine and serine as well. Then the MTHFD gets involved, followed by the MTHFR 677 tango, until alas, you wind up with the final product of 5-MTHF. So this is basically the path that your fruits and veggies take via the mitochondria and through the folate cycle in order to make 5-MTHF. So the whole purpose of the SHMT is to turn your dietary folates and folic acid you eat into THF, tetrahydrofolate, which then gets turned into 5-MTHF. In order for it to do this, it's going to take a couple of steps. Step 1. It uses the DHFR enzyme gene, which is dihydrofolate reductase, to start converting the folic acid and folates and turns them into DHF, which is dihydrofolate, using the NADPH. It takes the hydroxy, that's the H from the DAPH, and turns it into NADP+. Now it takes the DHF and uses the NADPH again, stealing once again the hydrogen atom to turn it back into DHFR again. So it's a constant borrowing of chemicals to convert the folate into THF. We now have the THF that we have to convert. And that's where the SHMT comes in. So THF is converted into 5,10-methylene tetrahydrofolate, which is also known as 5,10-MTHF, and it uses the SHMT to make this happen. Notice how it says after the 5,10-methylene tetrahydrofolate, CH2-THF, and remember, CH3 is a full methyl group. And what's happening is when you start converting the THF, it is beginning to methylate it. And it's using serine to do it because serine is acting as a methyl donor to help convert THF into 5,10-MTHF. Serine as a methyl donor is needed to help THF to be turned into CH2-THF because the MTHFR gene absolutely needs CH2-THF in order to function. The SHMT is going to be constantly regulating CH2-THF to be available for MTHFR. So you can see if you have the SHMT mutation how this can hamper this process. After serine donates its methyl, it winds up getting turned into glycine. Glycine will aid in the transulfuration process, which are your detox pathways that are coming down out of your methionine cycle, and to make glutathione, our body's master detoxifier. Glycine will also be used for DNA synthesis. THF will also utilize the gene and its enzymes MTHFD. MTHFD's main job is to help with the folate metabolism. So if you have this in conjunction with the SHMT and the MTHFR 677 tango, it's going to be very difficult for you to metabolize folates. It's not impossible, but it is extremely difficult. This conversion is going to be super sluggish. So if you're eating too many folates and it's faster than this cycle can handle, you're going to wind up causing a lot of problems for yourself. Another issue you'll run into if these cycles aren't working properly is that you can royally drain some of the nutrients like B6, iron, and B12, phosphates, and have too much folate building up in the body. So it's very important to keep these levels in check. They're not broken, just very, very slow, especially if you have all of them. So if you think about it, the more genetic mutations you have in the folate cycle, the slower that cycle is. Hey, it's me again, still doing edits, and my computer will not let me change what I want to change. So we're getting it this way. If you've made it this far, say hi, Piper, in the comments. It helps the algorithm and it helps get the word out to other people looking for the work. And I know you made it this far. On top of that, if you're worried about this being very complicated, don't worry. We will be going through this and you'll be seeing my lovely face on a regular basis explaining all this in tiny, small chunks. But this is my master textbook on the subject so that I can remember it when my brain is foggy. But we will be going through all of this for folks who do struggle with science and with foggy brains. All right, but the point I wanted to make here was that if you are low on vitamin D, this will also hamper this entire process. So like we said earlier, in vitamin D, this can shut down this whole process if you don't have enough. The other point I wanted to make is, if you remember earlier in the video, we told you that leafy greens were already methylated. So you're going to want to eat your proteins with dark leafy greens. You're also going to completely avoid breads, starches, all of that crap that's processed. You have to avoid it all because it's only going to overburden your folate cycles. So you are going to stick with dark leafy greens and then slowly, as your folate cycle heals, add in other vegetables. That's the only thing you're going to be able to do until you get that thing working properly. Listen to me being all tense and bossy. I just speak passionately, okay? I'm just passionate. But no, in all honesty, you have to avoid all the stuff in the grocery aisles with the breads, cakes, cookies. All of that stuff has to go because it's all going to just crash this for you even harder. You're only going to want dark leafy greens, and you're going to want them with every single meal. I don't care if you drink them, but you want your salads with your lunches and your dinners with a protein. And you're going to slowly add in other vegetables. You start feeling achy, stiff, sore, and headaches, cut back because the folates are getting too high in your system. Booyah! Alright, I'm just entertaining myself at this point. Alright, back to our originally scheduled video. So if you're wanting to be on a vegan or vegetarian diet with these mutations and or a significantly compromised and sluggish folate cycle, the answer is simple. You can't. You're going to need the meat, the methionine, and the B12. Depending on how much your folate cycle is hampered, it's going to chew through your B12 as well. So you're going to need meat to replenish. You still need veggies because you need folate in order to make the 5-MTHF, and you need the 5-MTHF to move the B12 over to the Methionine Cycle. So you can keep detox pathways, DNA synthesis, amongst others, working. So you'll have to stick to a well-balanced diet. That means meat and leafy greens. Cutting out all the vegetables long-term will not help you either. You want to balance the cycles, not shortchange them and hamper them further. The only time cutting out veggies completely is necessary is when you have a buildup of folate in your body. You've got to give it time to clear out. Because remember, the cycle's not broken. It's extremely sluggish. Too much folic acid and folate in the body is extremely damaging to the body. It can damage your kidneys, cause pernicious anemia, and cancers. Avoid processed foods and grains enriched with folic acid. These will build up in the body faster and are more damaging if your folate cycle is extremely sluggish and you're taking in far more than your body can metabolize. So if you're eating the standard American diet, then you are taking in a lot more folates than you realize. All of these processed foods like breads, cereals, rice, juices, snacks, chips, basically all the junk food is usually enriched or fortified. These alone can knock your entire methylation cycles out of whack because they are calorie rich and nutrient deficient, but yet fortified and enriched with more folate. Besides being bad for your health, if you have folate cycle impairments, these foods are going to affect you more by overburdening it and driving your folic acid levels up, as well as cause vicious cycles that can be difficult to get out of. If you have significant folate cycle issues, you can't cheat even a little. I know, it sucks, but we are just wired differently. So we have to follow the rules our bodies, i.e. our methylation cycles, dictate. To make sure that you're able to continue eating folates, you need enough B12 to move it over to the methionine cycle. So if you're not getting enough B12 and your body doesn't have enough B12, the folates are also going to build up in your body, and it's not going to be able to move it over to your methylation cycle. Okay, we're going to talk about 5-MTHF, the supplement. We're going to talk about it because lots of folks take it, and also I get a lot of questions on whether or not people should take it. If you have folate cycle impairments, or you have been eating predominantly a standard Western diet, you need to get your folate and folic acid red blood cell levels checked. This is kind of important because if you take 5-MTHF and you have significant folate excess in your body, it's really going to hurt you. One of the big symptoms is a lot of pain, as well as migraines. If you feel worse after taking 5-MTHF, there are two things you have to look at. For some folks, the folate itself could be the problem, and it could be due to the fact that you have a folate excess in the body, or you have a B12 deficiency, because remember, you need that B12 in order to take in the folate and use it. For others, the extra methyl is what can get you, especially if you're taking a methyl B12 as well, because you already have enough methyl. Okay, the MTR gene mutation and the 5-MTHF. If your MTR is not working, taking added methylfolate will cause issues because it can't move it out of the folate cycle and into the methionine cycle to be used, causing harmful buildup once again in the body. So if you have the MTR, just use caution if you're taking it. You might have to titrate up or titrate down. You might not need it every day. You might only need it once every 3 days. It just depends on how your cycles are working. Just be aware that if you have the MTR, it could cause some symptoms. So just listen to your body and what it's telling you. If you have the MTHFD and the MTHFR 677 Tango, whether or not you can take the 5-MTHF supplement is generally going to depend on whether or not you got both genes and how many mutations to each that you got. So if you got it from one parent versus two is going to make a difference. The general rule is the more hampered it is, the more likely you're going to need the 5-MTHF. There are always exceptions to every rule, so just listen to your body. But what you'll need to do is eat plenty of leafy greens every day, avoid carbs, and only eat fruit and vegetables as tolerated. So if you're getting too many, you're going to start feeling worse. So make sure you adjust how much you're eating. Just make sure you are eating some leafy greens, because remember, they're already methylated. If you have the SHMT, you generally need the 5-MTHF, but just remember to keep in mind all the rules on this slide that we've already talked about. If you have the SHMT plus the COMT and the VDR, you generally will not be able to handle carbs at all. If you can, it will be extremely sparingly. So if you eat them, make sure they are healthy and they are definitely not enriched or fortified. You are definitely going to want to stay away from dairy, gluten, and like I said, carbs. If you eat these items with these gene mutations and your methylation is very sluggish, you will get what we call the mastomenies, or as I affectionately call it, the Hulk. Because Hulk angry, Hulk smash! And I'm pretty sure a lot of us have felt that way a lot when our methylation is way off and we eat those particular foods. So I wanted to include that so that you knew where some of this anger comes from and irritability. So if you have one or more of these gene mutations, it can really affect your folate cycle. And this is why some folks feel so much better on the meat-only diet, because first of all, it allows time for the body to detox the folate excesses in the body. It also helps heal any leaky gut issues due to the collagens that are found in meat, and those collagens help heal that leaky gut. So if you go to the carnivore diet, just keep in mind it's not recommended for long term. A balanced diet is best. So you want to make sure you're getting your meat and you're getting your leafy greens. Those are the two most important things for you to be getting. So if you're wondering whether or not you need to be a vegan or a carnivore, it is going to completely depend on your methionine cycle and folate cycle and those mutations. A well-balanced diet, though, is always the best diet. And now for the BH4 cycle. Okay, everyone, hold on to your hats. You're about to find out why you do the things you do, why you can and cannot sleep, why you feel the feelings that you feel, including that runaway train of negativity and irritation. You know what I'm talking about if you get it. Unless you don't, and then you don't know what I'm talking about. But if you do, yeah, you know what I'm talking about. This cycle dictates a lot of your personality, your moods, your mental health, your stress responses, parts of detoxing, your neurotransmitters, some of the symptoms you get, and your ability to sleep. So let's take a look at the BH4 cycle, what it is, and what it does. BH4, otherwise known as tetrahydrobiopterin. It is a vital cofactor for numerous functions in the body. And this includes motor function, cognitive function, emotional and mental health, as well as stress response. Now, the stress response usually appears as either freezing, like when the stressor is introduced to you, and your brain just freezes. You can't think of what to do next. Your brain just goes blank. On the flip side of this, the other response that you can have is people that overreact to even the smallest stressors. In my line of work, we used to call that pinging, but they basically just fly off the handle whenever there's a stress introduced to them. Also, it's kind of like the fight or flight response becomes extremely trigger happy. BH4 is also very important for your cardiovascular health. BH4 is also important for detoxing. And if you don't have enough BH4, you won't be able to clean out the toxic waste out of your cells and out of your body. BH4 is also needed for your ammonia cleanup cycle. This will help detox your excess ammonia levels inside of your body. If your BH4 cycle isn't working properly or you don't have enough available BH4, ammonia will build up in the blood, and this is also extremely damaging to your brain. Ammonia is also a byproduct of protein metabolism. High amounts of meats can cause high ammonia in folks, especially with homogeneous MTHFR 1298 Charlie. High protein diet will also deplete your BH4 cycle. This is going to be extremely important to know if you're considering a carnivore diet for your healing path. Because BH4 is so important for protecting your heart, brain, and mitochondria, as well as detoxing, many with the MTHFR 1298 Charlie will not be able to tolerate this route. And that is because of the excess ammonia that is going to build up in your body because you're already having troubles detoxing it out. This will be especially true if you have homogeneous MTHFR 1298, and that means you got 2 copies, one from each parent. This process will also be more difficult if you also possess the NOS gene mutation. But BH4 is responsible for more than just detoxing ammonia. Let's keep going. BH4 also makes lipids for cell communication and immune function. It's also essential for sending signals to the network of nerves in the brain and in the gut. So this is going to influence your gut motility, which is your gastroparesis, the secretions going on inside of it, your nutrient delivery, and even your gut microbiome. We've already previously talked about how methylation impacts your digestive system. Well, this is the specific part of methylation that these issues fall under. It is the main part of the BH4 cycle. Another aspect to your gut and brain connection is how it affects your emotions, because this also affects your neurotransmitters, stress, anxiety, mood, and behavior. We've all met someone who gets hangry, or someone with food addictions like sweets or caffeine, etc., etc. It is this gut-brain connection in conjunction with how your BH4 cycle is working that's causing all of this. Proper levels of BH4 also helps with gastroparesis, diabetes, and insulin resistance. So if you are suffering from gastroparesis, barring any other extenuating circumstances, healing your BH4 cycle as a whole is going to take care of this and resolve your gut paresis. And this can be done. As a side note, it is the serotonin specifically in the BH4 cycle that is responsible for your gut motility. And you need enough BH4 to make serotonin. And don't forget, when you're in fight or flight, it also shuts down digestion. So if you are under extreme amounts of stress, it will also shut down digestion. BH4 and the BH4 cycle is absolutely essential for mitochondrial function. It is used in the oxidative phosphorylation process, which feeds it into the methionine and the folate cycle. This also helps give us the energy that we feel every day. It's part of cellular respiration. BH4 also aids the mitochondria in the Krebs or citric acid cycle, which is also part of cellular respiration. In this case, it is helping the body to detox and aiding in the ammonia cleanup cycle. BH4 helps make a beneficial biochemical called nitric oxide. Nitric oxide is a very powerful vasoprotector. It also helps blood pressure regulation and protects the heart and brain from toxins. And as we showed you earlier, it's also extremely important for mitochondrial function in the Krebs cycle, which helps your body to detox. The BH4 cycle also makes and helps regulate important neurotransmitters. These neurotransmitters are serotonin and dopamine. Now, as you can see, serotonin and dopamine play a big role from what happens here on out. Serotonin gets broken down primarily into AHCY. Please don't make me say that word. But it's an acid that is a waste product from the breakdown of serotonin, which is excreted in the urine. It also gets broken down and formed into melatonin. So, serotonin is also known as 5-hydroxytryptamine, which is also 5-HT. It is a monoamine neurotransmitter. It also acts as a hormone. As a neurotransmitter, serotonin carries messages between the nerve cells in your brain, your central nervous system, and throughout your body. And those are all the nerves in your hands and feet and everywhere else. The most important thing I want you to remember is this affects your nerves, both in your brain and the rest of your body. So if you're suffering from neurological issues, this is part of the equation, okay? So we said serotonin breaks down into HIAA and melatonin. HIAA, or 5-hydroxyindoleacetic acid. Let's try that again. 5-hydroxyindoleacetic acid. Whew, I probably still said it wrong. Knowing what it does is more important than if I can pronounce it. But it is the main metabolite of serotonin. In chemical analysis of urine samples, 5-HIAA is used to determine serotonin levels in the body. If you want to get a good night's sleep, you need proper metabolism of serotonin. And stable sleep every night is important for making methyl and keeping your methylation cycles stable and functioning properly. Melatonin. Melatonin is a hormone that your brain produces in response to darkness. It helps with the timing of your circadian rhythms, which is your 24-hour clock, and with sleep. Being exposed to light at night can block melatonin production. This is a reason why you're supposed to avoid blue light, those are your TVs, cell phones, computers, at night. Because the blue light actually tells your body to wake up instead of producing melatonin. And methylation cycles are dependent on circadian rhythms working properly in order to make methyl. So this whole subject right here is about getting a good night's sleep so you can make enough methyl, and you need the proper levels of serotonin to do this. Now, I was originally going to talk about this later on in the video in a different section, but I think this is the best place for it. So serotonin works in both the brain and in the gut. When it's working in the brain, it is acting as an inhibitory neurotransmitter that regulates mood, your fears, your anxieties, your feelings of relaxation, mental focus, learning ability, and clarity of thought. However, when it is working in the gut, it is acting as a hormonal messenger that is regulating satiety, food cravings, digestion, nutrient absorption, and peristalsis. Surprisingly, 90% of serotonin is actually produced in your intestines. So this is another reason why it is so important to take care of your gut health. As we said, it helps you with sleep, it helps with nausea, wound healing, bone health, blood clots, because platelets store serotonin. So when they're wounded, serotonin is released to help stop the bleeding. Low libido equals low serotonin. And digestion, low serotonin equals gastroparesis, like we were talking about earlier. It enhances absorption of nutrients, stimulates muscular contractions of intestines to move food, and it helps curb cravings and uncontrolled eating, which is similar to the hormone ghrelin and peptide YY. We also know that serotonin also breaks down into melatonin, and this helps you to have stable sleep throughout the night. If you don't have enough serotonin, you're going to experience a myriad of symptoms. These include anxiousness, mental obsessions where you just can't let something go, compulsiveness, depressed mood, sleep cycle disturbances, as we were talking about earlier. You'll have a lot of sweet and starchy food cravings, as well as an increased appetite, low libido, irritability, digestive health issues like we were talking about. You will have joylessness. You will not be able to find your joy. You're going to just feel blah. And you're going to find yourself getting overwhelmed extremely easily. Now, there's a number of reasons why you might not have enough serotonin. One being you don't have enough tryptophan to turn into serotonin, or you don't have enough BH4 to turn that tryptophan into serotonin. Other reasons you may have low serotonin is due to prolonged stress. And you'll understand when we talk about the COMT, but what's happening is the stress is making you chew through your BH4 so you can't make serotonin. Medications can cause low serotonin. Certain antihistamines actually mess with your serotonin levels. Some street drugs, like weed, will royally mess with your serotonin levels as well. Lack of sunlight due to the diminished amount of vitamin D you're absorbing from the sunlight will also have an effect. Hormone fluctuations, deficiencies, and imbalances will. Poor diet. For example, if you're not getting enough tryptophan or enough nutrients to support the BH4 cycle, which then in turn turns tryptophan into serotonin, will also affect your serotonin levels. A lack of exercise will also have an impact because exercise helps the body to detox and releases other hormones and endorphins, and this in turn will have an effect on your serotonin levels. Caffeine. Caffeine will make you chew through your vitamins, nutrients, methyl, and your BH4, which will then in turn affect your serotonin levels. Smoking is a stress on the body and has the same type of effect. High cortisol levels is also a high stress on the body, which winds up chewing through the vitamins, minerals, and nutrients your body needs to support BH4 functions, which then in turn depletes your BH4, which then in turn affects your serotonin levels. Methylation issues. Obviously, if you have methylation issues in the BH4 cycle, you're already going to have troubles with making sure you're making enough serotonin. Also, low blood sugar is also going to have effect on your serotonin levels. Interesting fact, 80 to 90% of people actually believe that low serotonin causes depression. However, it is more about the serotonin imbalance brought on by diet, lifestyle, sun exposure, your methylation impairments, the buildup of toxins, and the buildup of byproducts due to poor methylation that ultimately winds up causing depression. It's not just centralized around serotonin. It's a whole metabolic process that revolves around your methylation and everything that goes into supporting your methylation. Hey, it's me and Piper again. We have something else to tell you during our final editing. I wanted to address this because some of you, including myself, get what I call the ugly, inconsolable crying.
It's too sad to walk. It's too sad and fun to walk.
I am talking about that inconsolable crying where you are just a pile of mush on the floor. And I'm going to tell you because this is the section of your methylation that just crashed. It can happen if 1, you ate too much protein and it crashed your BH4. 2, you've been having too much sugar and caffeine and it crashed your BH4 or the nutrients. You burned through them all in your methyl, which keeps your BH4 running strong. So this can happen. You just got to cry it out, and then the following day, make sure you eat properly. One of the other meds that can cause this is clonazepam and certain other drugs that can cause this, and puberty and, the midlife one. Menopause. I was having a brain fart. Sorry. So menopause and puberty can make this a whole lot worse because puberty does have quite a bit of a strain on the body, and plus we have estrogen, which, yeah. But if you get the ugly crying, you're going to want to avoid meat for a couple days because your methionine cycle is overburdened and it's gunking up certain parts of your methylation cycle. Most of the time, that's all you need to do is just avoid meat for a couple days. But if it continues to happen, you need to look at your meds, you need to look at your vitamin D, you need to look at your gut health and see what's causing it. Hormones are not the only reason this happens. And the last thing you need to look at is your stress levels, because stress will make your methylation gears come to a grinding halt. And if stress is the reason behind this, you're going to have a really hard time recuperating and stop crying. And you're going to need to make sure you're in bed at 8, 9 o'clock at night and sleeping till 5 o'clock in the morning, because you also need sleep to help fix the BH4 cycle. So if you do get the ugly crying, this is just a sign that your methylation has crashed and your body needs time to get rid of the excesses, and you also need to address the deficiencies and make sure you're getting enough sleep and reduce your stress through meditation or exercise. That will be a great deal of help for you. Unfortunately, this is common for those of us with the MTHFR 1298 should the BH4 cycle crash, but you do not have to have an MTHFR genetic mutation for this to happen, and it's for the same reasons. So, how do you help support natural serotonin balance? 1, you need to be thinking positive. Research shows that the link between serotonin and mood may be a two-way street. Mindfulness can influence mood independent of serotonin levels. Light exposure. Research shows a positive correlation between hours of natural sunlight per day and serotonin levels. Soak up in the sun for a positive boost in mood. Exercise. Exercise is one of the best ways to increase serotonin. Studies show activity increased plasma tryptophan levels and increased serotonin metabolism. And a diet rich in vitamins, minerals, and nutrients that support serotonin metabolism is the best step to support healthy serotonin levels. Now remember, caffeine in eating foods that cause immune responses is going to wind up causing stress to the body, which then forces your body to chew through all the vitamins, minerals, and your BH4, thus shrinking your ability to make serotonin. As you can see, all of these different factors are so very closely tied together and have a huge impact over your daily mood and your health. All right, on to the next neurotransmitter, dopamine. Now, dopamine breaks down in one of two ways, and this is highly dependent on your vitamin D levels and iron levels as to which direction it's going to go. If you have a vitamin D deficiency, dopamine will be broken down into norepinephrine and epinephrine, both which are adrenal hormones. This metabolism is taking place in the adrenals and in the brain. The body is getting flooded with adrenaline. The symptoms are going to come out like ADD, ADHD. You're constantly going to be on the go. You won't be able to sleep, and you might not be able to think straight because you have so much adrenaline running through your body. And this can wind up resulting in your body getting stuck in fight or flight. You'll also notice that people talk really fast when they're having this issue. If you get stuck in fight or flight and have this issue for too long, it's going to wind up having a negative effect on you because you're stuck in fight or flight. Your body is burning through your nutrients, your vitamins, your minerals. It is depleting your BH4 and it is messing up your overall methylation cycles. So it's very important to make sure you have enough vitamin D in your body. If you are having these symptoms, you need more vitamin D. Now, this is where the MAO B and COMT come in. In a perfect world, if your MAO B and your COMT gene are working perfectly, it should be able to clean up and break down the norepi and epinephrine, those adrenal hormones, and turn it into VMA. This is just a waste acid that winds up getting excreted through the urine. But if you have the MAO-B mutations, this is where you're starting to run into the bipolar symptoms. If you have the COMT mutation with all that adrenaline running through your system, it cannot get rid of all those adrenaline out of your system fast enough. And this is where you run into what some people call the masto-meanies. I personally like to call it the Hulk gene. Because, ooh, you are so mad, and you might be temporarily very strong, and your tongue is mightier than the sword, and it is just taking out whoever is in your path because you are on a total and complete warpath. Yeah, I don't know anything about that one. I plead the fifth. Another symptom that is a dead giveaway is it'll feel like a runaway freight train inside of your chest with a lot of pressure that you feel like you just can't get it out. And it is so not a comfortable feeling. And this will go on until you deplete your BH4, your dopamine, and your adrenal hormones. And when that happens, you crash hard. But if you are experiencing these symptoms, vitamin D, my friends, vitamin D helps like you would not believe. You absolutely cannot have caffeine with this, or gluten, or dairy, because it will make it oh so much worse. And you will not be sleeping anytime soon. Kinda like me right now. I can neither confirm or deny that this happens to me. Now, if you have enough vitamin D and iron, dopamine will be broken down and via the MAO-B and COMT into homovinylate acid. That's the HVA. And this also gets excreted through your urine. That's what happens in a perfect world. Now, we both know if you have the MAO-B and the COMT gene mutations, even though you have enough vitamin D and iron, can cause extra symptoms. But we'll get to that in a few minutes. Let me finish dopamine first before we talk about the MAO-B and the COMT specific. So, dopamine is a neurotransmitter, and it acts on the areas of the brain to give you feelings of pleasure, satisfaction, and motivation. Dopamine also has a role to play in controlling memory, mood, sleep, learning, concentration, movement, and other body functions. So as we said, it breaks down into HVA and VMA via the MAO-B and COMT. So HVA is homovinylate, and it is a primary metabolite of dopamine. So traditionally, low levels of homovinylate when doing testing was a good indicator of low dopamine. However, it's also a good indicator of not enough BH4 to convert the dopamine into the HVA. Now, traditionally, when you had low dopamine, it was because you weren't getting enough tyrosine. However, if you possess the MTHFR 1298, it's going to mess with your SAMe levels, so you need to make sure you have enough SAMe, magnesium, FAD, and NAD, which are also needed to metabolize dopamine. So you want to be making sure that you're getting enough tyrosine in order to make dopamine, but you also want to make sure you're also supporting your BH4 cycles so that you can convert the dopamine so your body can use it. The other acid that is created is VMA, which is the vanillimandulic acid. It is one of the breakdown products or metabolites of epinephrine, adrenaline, and norepinephrine. This is produced in the liver. It is excreted in the urine. It can also be used as an indirect measure of epinephrine and norepinephrine levels. So, dopamine is a neurotransmitter, like we said, and it's made in the brain, and it does act as a chemical messenger, communicating messages between your nerve cells in your brain and your brain to the rest of your body. Dopamine also does act as a hormone. Dopamine, epinephrine, and norepinephrine are the main catecholamines, which can cause mast cell degranulation. These are made by the adrenal glands and the hypothalamus within the brain. Now, dopamine is involved in helping us feel pleasure as part of the brain's reward system. Different items can trigger a dopamine release or a dopamine rush, such as sex, shopping, OCD cleaning for some of us, playing video games, abundance of screen time, smelling cookies in the oven, food addictions like sugar and junk food, etc. Now, the role of dopamine in the body as a neurotransmitter is involved in movement, memory, pleasurable reward and motivation is a big one here, behavior and cognition, attention, sleep and arousal, mood, learning, and lactation. As a hormone, depression is released in the bloodstream, and it plays a small role in the fight or flight response. It increases sodium and urine removal from the body, reduces insulin production in the pancreas, and slows gastrointestinal content movement and protects the gut. It reduces lymphocyte activity in your immune system and causes blood vessels to relax. A low dose is a vasodilator, and a high dose of dopamine is a vasoconstrictor. So, if you have the right amount of dopamine in your system, you're going to be happy, motivated, alert, and focused. If you have low dopamine, you're definitely going to be tired. You're going to be unmotivated. You're not going to be very happy. You will have some memory loss. You'll definitely have some mood swings. You'll have sleeping problems, which usually means you're sleeping way too much. You're going to have concentration problems, a low sex drive, trouble controlling your emotions. You'll be all over the map. And you'll wind up having mental, physical, and neurodegenerative health conditions, including some like restless leg syndrome. You can also get a little bit twitchy. And these are involuntary movements that can be severe or very mild. And this is generally a very good indication, if suddenly you get this, that your methylation cycles are overloaded and are crashing. Now, generally what you're going to have to do is detox, but you're also going to have to take a look at what you're doing and what you're eating. So if you're eating a lot of junk food, you're going to have to cut that all out because it's overloading your system. You're also going to have to look at if you're having too much caffeine, sugar, etc., because all of this is going to play a huge impact on this. You can also have a very high dopamine level, and you'll wind up feeling euphoric, energized, and a high sex drive. The negative side, though, of having too much dopamine is you could wind up having a hard time sleeping. You could wind up having very poor impulse control, being more aggressive anxiety, and a higher stress response. There are diseases associated with low dopamine. Some of those are attention deficit hyperactivity disorder, or ADHD. And those with ADHD usually have a gene that make it difficult for neurons to respond to dopamine. It's called the DRD2 gene. So you can experience symptoms with your dopamine gets too low, and it'll kind of act like Parkinson's disease, where you really have a hard time with your motor function, and things like restless leg syndrome. There are diseases associated with high dopamine, and that is mania, obesity, and addiction. Now, schizophrenia is a disease that's associated with dopamine. Basically, what's happening is certain parts of your brain have too much dopamine, and other parts of the brain do not have enough. So the symptoms where there's too much in certain areas of the brain can result in delusions and hallucinations. The other flip of the coin is if you're not having enough dopamine in another part of your brain, you will lack motivation. Now, you can boost dopamine naturally by hugging, touch, massage, listening to music, laughter, and my personal favorite, petting my pets, exercise, sports, sleep, nature, forest bathing. Okay, I guess that means like grounding, walking outside barefoot through the woods. Acupuncture, chiropractic, yoga, meditation, definitely sunlight. You can do cold water immersions. You can take tyrosine, high-dose omega-3 fish oils, protein-rich breakfasts, avocados, almonds, olives, turmeric, rosemary, oregano, green tea, L-theanine, different seafoods, pasture-raised organic meats and eggs, organic foods such as kale, spinach, bananas, broccoli, apples, beets, berries, and cherries. You also will need a healthy microbiome. You'll also need to make sure you get enough zinc, folate, B6, vitamin D, and magnesium. So if you're finding you have really low dopamine levels, it may be due to the fact that you have insufficient BH4, iron, or tyrosine. It can also be seen when adrenal function is really low. And if you remember from the inflammation video, you can help support your adrenal glands with Chinese licorice root. Okay, so originally I was going to leave this slide out, but then I realized there's something important I should address here. Mast cells are the master switch to the entire immune system, and we learned that in an earlier video, remember? Mast cells and the nervous system are tightly linked together. So, the epi-norepi are responsible for our fight or flight, correct? Food, activities, health symptoms like inflammation are all stresses to the body. This can kick off that fight or flight response. Now, mast cells, when they degranulate around the nerves, can also trigger the fight or flight response because they cause neuroinflammation, and that is yet another stress to the body. So what's going to happen is this is going to make your nervous system touchier and touchier and more sensitive until you have a hyperactive nervous system. Because of this, it's going to make your mast cells more sensitive, and it's going to completely mess with your BH4 cycles. This will further make your moods more erratic and sensitive, especially if you have COMT. This can create a negative feedback loop between you, your nervous system, your BH4, and your immune system. This is one of the many reasons why I tell people detoxing is one of the best things you can do, because you also have to reset your nervous system so that it can quiet back down. And you can't do any of this until you take out every single trigger. And you got to get all the toxins out of your body, and that is why I'm constantly preaching you need to detox, 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 because you got to reset the immune system, reset your nervous system, and reset your methylation cycles, and heal your mitochondria and gut. We've already pretty much covered everything else on this slide, but if you want to read it, go ahead and pause the video. But this slide will also be in the genes and SNPs and methylation slides as well. So the BH4 cycle in BH4 is helping your cells, nerves, and immune system to talk with each other and with a host of different systems in your body. It is regulating and maintaining levels and all the functions in your body that require BH4 in order to keep you healthy. So you can see how important the BH4 truly is to managing your health. So this cycle is going to play a huge part in your mental and physical health and well-being. BH4 deficiency actually is recognized as a severe metabolic disorder. Now, this is usually caught shortly after birth if you do have it. It comes with serious health issues, such as impaired intellectual development, loss of muscle control, neurological and cardiovascular issues. Now, if your methylation cycles get far enough off, you can experience these same symptoms. However, the people that are born with it, they're going to be receiving enzymes for life unless they can fix their methylation and activate those genes to produce and recycle the BH4 for themselves. However, you can cause these same symptoms with poor diet, chronic stress, poor sleep, and lifestyle habits, as well as too much caffeine. So fix your diet, your lifestyle, and you can minimize or get rid of these symptoms within the BH4 cycle. So like we've been talking about, depletion of the BH4 can cause symptoms of ADD, ADHD, bipolar, depression, aggression, insomnia, neurodegeneration, anxiety, heart racing, palpitations, neurological issues, and memory issues. Now, we talked about earlier in the video how important BH4 is for the ammonia cleanup cycle, right? Well, high amounts of meat and protein can cause high ammonia in folks with homogeneous 1298. So if you have this or too much ammonia buildup, it is going to deplete your BH4 levels. Now, the MTHFR 1298 Charlie, it is completely dependent on your BH4 cycle working properly. So if your BH4 cycle isn't working, neither will your MTHFR 1298. BH4 structurally resembles folate, or it's called molecular mimicry. This may not make sense right now, but you'll see the importance of this later on. Folate, that 5-MTHF we've been talking about throughout this video, is actually really important for your BH4 cycle to work. And what it's doing is it's recycling BH2 back into BH4. And again, we'll be getting into that shortly. Okay, we're going to take a closer look at the BH4 cycle just like we did for the other cycles. First, we're going to take a look at what genes fall under the BH4 cycle. There's the MTHFR 1298 Charlie, the DHPR, the MAO A, the MAO B and the COMT, and the VDR. Alright, this is the same diagram, but this one shows all the pathways that will help you to understand the BH4 cycle. But don't worry, I'm going to explain it in detail. BH4 is a cofactor, which means it's an enzyme to make this whole entire cycle to work, okay? You have your tryptophan being converted into serotonin. You have your tyrosine being turned into dopamine. You have the MTHFR 1298 Charlie, which is extremely dependent on having enough BH4. If you have the MTHFR 1298 Charlie, that means it flips on SAM. What does that mean? It means it's going to affect your ability to make SAMe. We've already learned how important SAMe is to your methionine cycle, but it also helps your BH4 cycle and affects your COMT gene. You need enough SAM in order to support the MAOB and COMT genes. If you don't have enough, these genes aren't going to quite work properly either. Okay, here's a little visualization of how SAMe impacts the BH4 cycle. If you have a SAMe deficiency for whatever reason, and or you have the MTHFR 1298 Charlie, this is going to cause issues with your entire BH4 cycle. This will have a huge impact on how you feel and your moods. If your BH4 cycle isn't working properly and you're not making enough BH4, the MTHFR is not going to work properly and you're going to have a harder time creating SAMe, which means it'll continue to get lower and lower and lower. It becomes a vicious negative feedback loop. So you can see how intricately these genes, cycles, and enzymes are working together. If your BH4 cycle gets really far off, it is going to affect the rest of your methylation cycles, and you will feel it. All right, next gene in the BH4 cycle is the DHPR. The DHPR, which is dihydrobutyrin, also known as BH2, and that gene converts BH2 back into BH4. So the DHPR is an L-type calcium channel complex. It plays an essential role in many areas: muscle contraction and secretion, integration of the synaptic input in neurons, and synaptic transmission. It has an important role in the BH4 cycle, and it's important for processes of the neurotransmitters. It is essential for the regeneration of BH4. It salvages unstable biohydrobutyrin, that's that BH2, and it converts it back to BH4. It does help with the synthesis of tyrosine, tryptophan, DOPA, and noradrenaline. So it greatly helps with the processes of breaking down with the BH4 to create serotonin, dopamine, and nitric oxide. It also helps folate stay in its active form. Also, its connection between DPHR and aluminum. It binds with aluminum. DHPR activity was inversely related to serum aluminum concentration, which can lead to Alzheimer's and dementia. The thing I want you to remember about the DHPR is that 1, it affects your ability to recycle BH2 back into BH4, and 2, it affects your muscles. So if you constantly have tight, hurting, locked muscles for no apparent reason, this gene can cause that. It has to do with the calcium channels in your body. So a deficiency in the DHPR, which is usually rare, this can be caused by the mutations in a particular gene called the QDPR gene, but it can also be caused by too high aluminum levels, trouble maintaining folate in its active form, which also affects methionine in the folate cycle, muscle tension, neurotransmitter issues, neurological issues, impaired BH4 renewal, that's that recycling process we were talking about, and it can cause hyperphenylaninemia. High levels of the amino acid phenylalanine in blood builds up blood and tissues. BH4 is needed to prevent this, and it's linked to the PAH and PKU. Too much phenylalanine builds up in the system causes deficiency in the neurotransmitters serotonin and dopamine. Folate in the cerebrospinal fluid are also decreased, and this causes a psychomotor delay, low muscle tone, seizures, abnormal movements, too much salivation, and swallowing difficulties. Now, the DHPR will affect all cycles in methylation. If you want to check and see if you have it, you can get blood serum aluminum levels, the QDPR gene mutation, and PAH-PKU is a good sign of that. This also requires a doctor's care. So those are the genes within the BH4 cycle. Next, we're going to look at the genes that the BH4 directly supports through its pathways. First, we're going to look at the MAO, and it's comprised of the MAO A as in alpha and the MAO B as in Bravo. The MAO, which is a monoamine oxidase, is a widely distributed mitochondrial enzyme. It is highly expressed in the gastrointestinal, the liver, and the neuronal tissues. This enzyme oxidizes a variety of monoamines. It also has the role in metabolizing released neurotransmitters, that's your serotonin and your dopamine, and detoxification of neuroactive and vasoactive amines. Neuroactive refers to your nervous system and its nerves, and vasoactive refers to your cardiovascular system. Amino acids help form amines, which are organic compounds that are formed via decarboxylation or by aldehydes and ketones. The important thing I want you to know about this is that they're connected to ammonia, because we all know how damaging ammonia is to the body, specifically the brain and the nervous system, particularly the motor function and neurological symptoms. So like we said, the MAO is a monoamine oxidizer, and that is found mainly in the gut, liver, and intestines, and it breaks down these amines. Now in most people, amines are going to be broken down and cause no problems. However, if your enzymes aren't functioning properly, like you have the MAO mutation, amines can build up in the body, which can cause allergic symptoms or intolerances for some folks. Now this gene, the MAO, it breaks down neurotransmitters epinephrine, norepinephrine, and serotonin, which is the 5-HT, and dopamine through oxidation. These individual neurotransmitters are also called catecholamines. The body releases catecholamines in response to emotional or physical stress. Catecholamines are responsible for the body's fight or flight response. Dopamine, adrenaline, and noradrenaline are all catecholamines. Why is this important to know? Because there are catecholamine foods like cheese, caffeine, and allergen foods for you. This will increase your neurotransmitters epinephrine, dopamine, and adrenaline levels, which ramps up your fight or flight or your stress response. While these rapid responses may be necessary for survival, sustained elevation of circulating catecholamines for prolonged periods of time can also produce pathological conditions, such as cardiac hypertrophy and heart failure, hypertension. It can do damage to the organs, the brain, digestion, for example, it can shut it down. The kidneys, it can shut down renal function and starve the kidneys. And post-traumatic stress disorder, anxiety, irritation, etc. There are many others. So the MAO is responsible for breaking down all of these catecholamines so that they don't build up in your body. So symptoms of catecholamine excess, or it's also called pseudopheochromocytoma, can actually be clinically indistinguishable from actual pheochromocytoma. Patients usually present with paroxysmal or episodic hypertension and have a negative evaluation for pheochromocytoma. So if you have a lot of adrenaline running through your system and it's just like you got a freight train in your chest that just won't quit, chances are you're not breaking down your catecholamines efficiently. MAO is essentially a regulator of your brain function and your neuropsychology. Mutations in the gene, the MAO, can directly affect the levels of neurotransmitters, which can lead to various behavior-associated disorders. Now, the MAO is more common in men, which is X-linked inheritance pattern. Low levels of the enzyme MAO will result in slower breakdown of the neurotransmitters, and those folks tend to be worriers. Higher levels of the enzyme tend to lead to a faster breakdown, and those folks tend to be warriors, which means they're generally aggressive. So those with MAO are going to have an increased risk for aggression, ADHD, expressions of anger, depressive and bipolar disorder, or all of them together. So those of you with this gene, getting enough sunshine, and I cannot stress this enough, is going to be extremely important for you. MAO A versus MAO B. The MAO A, which happens to be more involved with depression, this gene is responsible for the production of an enzyme, MAO A. MAO A is highly expressed in the cells of the brain and in the heart. It is primarily involved in the metabolism of tyramine. It oxidizes serotonin and norepinephrine. Those of you with leaky gut are especially high risk of low serotonin if you have MAO A. Taking 5-HTP, which is a necessary component to serotonin, can help you. Foods high in tryptophan, like pumpkin seeds, chicken, or turkey, can also help increase serotonin. And that is only applicable for those of you who have the fast MAO-A. We'll get into that in a minute. The MAO-B, which happens to be more involved with neurodegenerative diseases like Parkinson's, the MAO-B gene is responsible for the production of an enzyme, MAO-B. It is primarily involved in the oxidizing of phenylethylamine, which is PEA, a stimulant to the central nervous system. Phenylethylamine is a precursor to the catecholamines. Too much of this in the system can be hazardous to your health. MAO-A and MAO-B can both oxidize dopamine. When MAO is not working properly, it is proposed that byproducts of the MAO or buildup of catecholamines can be neurotoxic. Symptoms of a slow MAO A and B, those are your warrior folks. They're easily stressed, easily panicked, easily startled, easily made anxious, hard to calm down after they have stress. They love their wine, cheese, and chocolate, but they will feel terrible afterwards. They'll have more migraines and headaches, have difficulty to get to sleep, but once they are asleep, it's easy to stay asleep. They're short-fused, can overreact and become aggressive, but feel bad about it later. You can't control it. The psychopathic personality traits are observed in patients who have frequently consumed more fast foods. Those who rarely ate vegetables and more junk food had verbal deficits in early adulthood. Now, symptoms of the fast MAO A and B, those are your worriers, they like carbohydrates, and they like lots of them, and it seems like they're on a constant carbohydrate roller coaster. Not eating enough carbs makes them feel depressed. Your body crashes after you eat carbs, and then you want more carbs. Other diets make you feel more depressed. You may gain weight because you're in a vicious cycle. You're more prone to depression and lack desire. You tend to love chocolate because it tends to boost your mood. Smoking, alcohol, or drug addiction is more common. Carbs increase your mood, but it kills focus and attention. You'll have feelings of overstimulation, and you'll want to keep an eye out on your serotonin levels. Now, there are serotonin imbalances associated with the MAO. If you have high MAO-A levels, you may wind up having low serotonin levels. With this comes intense aggression. There is an anxiety disorder and a social anxiety disorder associated with this. You may have cravings for carbohydrates. You may suffer from constipation. Serotonin is required in order for proper gut health motility. It activates the smooth muscle activity within the gut, and we talked about this earlier. Depression, especially during the winter months. Tendencies to act impulsively. Sleep disorders, low pain tolerance, and there is a low level of self-esteem in the individual. Obsessive compulsive traits or tendencies are also more common. Higher likelihood of panic disorders and post-traumatic stress disorder. Dream recall is poor due to the numerous factors. And phobias associated with social situations is also more common. If you have a low MAO-A level, that means your serotonin levels are generally going to be a little bit higher. You will still exhibit aggressive behavior, have some antisocial behavior, confusion, extreme agitation, GI issues including nausea, and muscle twitches. All right, the fast MAO-A or B, the worrier gene. We're going to talk about how to balance your fast MAO-A or B gene. Now, keep in mind, it's key that you also make sure your BH4 cycle is working properly. So, you're going to want to balance your B vitamins and get all the Bs and not too much riboflavin. Riboflavin, which is B2, will actually make the MAO-A enzyme even faster. Complex carbs and protein. Instead of the starch and sugar roller coaster, the most important thing you can do to get 3 regular meals that are high in complex carbs and protein for stable blood sugars and neurotransmitters. Complex carbs, which include whole grains and lots of fiber, digest slowly, and so they keep a steady stream of serotonin coming rather than peaks and valleys that quick carbs produce. You need to remove your stressors. Stress is not your friend with an MAO imbalance. Life has lots of stressors, but a lot of them are self-imposed. Let go of the food sensitivities, the blood sugar ups and downs, the toxic friends, and any extra jobs or tasks that you've picked up that you don't need to be there. Do a stress edit on your life. Boost your glutathione. Glutathione helps decrease inflammation and reduce some of the negative side effects of burning through neurotransmitters too quickly. Eliminate food sensitivities. Eating foods that your body is sensitive to raises your inflammation, which in turn drives your body to make more stress hormones and pushes the peaks and valleys, your neurotransmitter levels, even higher. Meditate. Meditation is one of the most effective non-drug methods of balancing neurotransmitters with any kind of gene SNPs. Even something as simple as 3 minutes of mindfulness meditation daily can have huge results over time. Watch your warning signs. With a fast MAO, you know when you're not keeping the right dietary balance, when you're waking up in the middle of the night hungry, or when your emotions are pushing you to the pantry for that sweet treat. If these are warning signs, make sure your next meal has plenty of complex carbs, leafy greens, a moderate amount of protein, and good fats to help feed your neurotransmitters. Boost your tryptophan intake. Tryptophan is the precursor to serotonin and melatonin, and the tryptophan that crosses into your brain most easily is found in the complex carb-heavy foods. Keep snacks with a good balance of complex carbs and protein at hand to stabilize blood sugars or give you a steady flow of tryptophan. Think yogurt, oatmeal, nuts and seeds, or some turkey slices rolled in iceberg lettuce. Those with leaky gut are especially high risk of low serotonin if you have this SNP. Taking 5-HTP, a necessary component to serotonin, could help. Foods high in tryptophan, like pumpkin seeds, chicken, or turkey, can help increase your serotonin. And again, you must get plenty of sunshine. Be sure you stay away from catecholamine foods, caffeine, allergens, and sugars, as this can make it worse, especially if you have the calm tea on top of it. Now, catecholamine foods are your dairy, your chocolate, gluten. Those are big catecholamine foods. Balancing your slow MAO A or B gene, and this again tends to be the warrior gene. Now keep in mind, between the slow and the fast MAO, they can also do a tug of war back and forth. So you need to always kind of keep that in the back of your mind. One of the key factors with a slow MAO A or B is helping your psychology and physiology to calm down. Here are some steps you can take. Riboflavin. Make sure you're getting enough riboflavin or vitamin B2. MAO A needs this vitamin as a cofactor. Blood sugars. You have to stabilize your blood sugars with 3 regular, higher protein meals per day with no sugary drinks or snacks in between. Again, remove your stressors. Your stress is not your friend here. You have to let go. Let go of those toxic friends, those extra duties at work that aren't going anywhere, and the projects you think you should do but don't want to. Simplify your life. Again, boost your glutathione. Glutathione, again, decreases your inflammation and reduces some of the hydrogen peroxide caused by the high stress hormones. Eliminate food sensitivities. Getting foods that your body is sensitive to raises your inflammation, which in turn boosts those stress hormones. So the goal with a slow MAO-AB is to keep the stress hormones under control. Again, you need to meditate. Meditation is one of the most effective non-drug methods of balancing neurotransmitters with any kind of the SNPs. Even something as 3 minutes of mindfulness meditation daily can have huge results over time. Step away from your anger triggers. Because of the tendency to explode into anger or irritability, if you encounter a situation that causes anger, instead of fully engaging and boosting your neurotransmitters even more, step away. Take a brisk walk for a few minutes, do some jumping jacks in your office, or even just take a few minutes to look at a painting you love or listen to a song that makes you happy. Once you've used this technique a few times, you'll figure out what works for you. Reduce your tryptophan intake. Tryptophan is the precursor to serotonin and is mostly found in protein-heavy foods. Often, people with a slow MAO-A will crave carbs, but eating too many carbs is like dousing the angry fire with gasoline. It isn't the best idea. Make sure your meals are protein-heavy, leafy greens, and carb-light. If your serotonin is low due to meds, diet, or methylation impairments, 5-HTP may be the benefit for some, but monitor it closely. And again, make sure you get plenty of sun. Those with the MAO are going to be affected so much more in the winter months. As far as knowing whether or not you have the MAO A or the MAO B, the best thing that you can do is get a genetic profile done, especially when you're running into methylation issues, because you want to get as many of the genes and know how many you have to maximize your ability to heal. For MAO A testing, what you can do is you can have a urinary organic acids test. That is the 5-HIA. If it's high, that means you're burning through serotonin way too quickly. If it's low, that means your body isn't breaking down serotonin efficiently, or there's not enough tryptophan or vitamin B6 to make serotonin. Vitamin B6 levels tends to be a deficiency. The ability to make serotonin is greatly reduced, affecting the MAO A. This deficiency will show high levels of xanthuronate and kynurenate in urine tests. Vitamin B2 levels tends to be a deficiency. Your ability to support MAO A is reduced and can cause the MAO A to slow even further. This deficiency will show higher levels of adipate, subarate, and ethylmalonate in urine tests. Tryptophan levels. If it's high, that means you're consuming way too many carbs, or you are unable to turn tryptophan into serotonin, which directly means you need to work on your BH4 cycle and your methylation. This is generally caused by a slow MAO A. Now, stress, inflammation, and infection will cause low levels of 5-HIA, B2, B6, and cause your tryptophan levels to be off. When it comes to MAO-B testing, I could not find specific medical guidelines for testing other than with major specialty clinics, and not all of these are going to be available to you. The diagnosis can also be obtained via functional medicine methods and also through those gene reports. The genes and SNP slides, along with the methylation video, can be an excellent source to figure out if you have impairments in this part of methylation just based on symptoms. Now, if you don't have a gene report and you're trying to figure out if you have the MAO A or B, for this MAO B, if you have the COMT gene, the thing I need you to understand is that the COMT and the MAO B are identical. So it'd be really hard to tell the difference between the two. If you have both the MAO-B and the COMT, your moods are going to be a lot more volatile and you'll have a lot more mood swings. You can also do the urinary organic acids test. You want to check your vitamin D levels. I cannot tell you how important this one is when it comes to your MAO A and B and your COMT. These work together, and vitamin D is vitally important because, like we discussed, it lowers those stress hormones, and that is what you need to do. You can also get a Mito expanded panel, dopamine metabolism deficiency panel, neurotransmitter metabolism deficiency panel, an MAOAB single gene for genetics testing, a clinical genome, and nuclear mito NGS panel. Again, those are all specialty clinics. I need you to understand, though, that you can balance your MAO-A's and B's without specialty testing. You can do it yourself and heal it. As you can see here, like we were just talking about, the MAO-B and COMT work together. So if you have both, you're going to be a lot more turbulent and a lot more moody and a lot more aggressive, especially if you have both. So it can be difficult to tell the difference between the MAO-B and the COMT without that gene report. We're going to go on and talk about the COMT. COMT gene. It is also a warrior and worrier gene. And just to point out that this gene can play a tug of war with your methylation and between the warrior and worrier side. They can flip-flop back and forth. But you predominantly tend to lean toward one side or the other. Now the SNPs in the COMT gene affect its activity, resulting in that warrior or warrior trait. The A genotype is the worrier, and that one has a 75% reduction in activity. The G genotype tends to be the warrior, and of course you can have the AG genotype, which is a mixture of the both. This enzyme deactivates neurotransmitters like dopamine, epinephrine, and norepinephrine by adding a methyl group to it. It affects your estrogen levels and your detoxification. which includes your estrogen, your ammonia, and your homocysteine. With the COMT, there is an increased chance of breast cancer by 700%, and it's because the COMT in conjunction with those higher estrogen levels. And I'm going to tell you right here, right now, if you drink caffeine as well, caffeine also raises your estrogen levels up to approximately 80%. So if you are drinking caffeine and you have the COMT, you need to cut back because your estrogen levels are going to be really high. And with methylation issues, you're already going to have a hard enough time with your estrogen levels being where they're supposed to be. So there's the fast COMT and the slow COMT. The fast COMT, which is the warrior side of this gene, which I affectionately call it the Hulk gene. Individuals having 2 copies within the G allele have a higher COMT enzyme, resulting in lower dopamine levels in the brain. You'll have higher epinephrine and norepinephrine levels, which means you're going to have a higher stress on organs and a higher risk for heart attack or stroke. You generally can have a higher pain tolerance, greater capacity to deal with stress at the expense of cognitive performance, and a sensitivity to caffeine. Those of you with the slow COMT, or the worrier, the COMT enzyme formed by the A allele has up to 75% reduction in activity with the homogeneous COMT, which means you have both copies as well. You have increased dopamine levels in the brain, you have a very low pain threshold, and increased sensitivity to stress, earning them the name worriers. These individuals tend to show improved memory and attention to detail, but with greater risk for Parkinson's disease. Now, again, like I said, you can flip-flop back and forth, and depending on your gut health and a few other factors, you'll generally tend to lean to one side or the other, but you can waffle back and forth. Symptoms are going to vary a little bit between person to person. Now, this will depend on other methylation genes as well as your RNA, DNA, and how they interact, your diet, your lifestyle, or stress levels. It's also going to depend on the amount of caffeine you consume. So, like I said before, you can raise estrogen levels by 80%, resulting in estrogen dominance. And as I've learned in previous videos, estrogen dominance is not good for you. It can cause an estrogen imbalance, which can result in further fatigue, thyroid issues, anxiety, bipolar depression, hormone imbalances, low libido, infertility, brain fog, increased food allergies, early menopause, breast tenderness, neurological disorders, increased risk of cancers, and dopamine imbalances. You can also wind up getting things like tremors, mental and physical fatigue, addiction tendencies, poor detoxification, and sulfur sensitivity, especially when it is paired with the CBS gene. And I put on here also as well as the SUOX gene. And that means you'll generally be sensitive to things like cruciferous vegetables, onions, garlic, etc., because those are high sulfur. And the SUOX gene, as you remember earlier in this video, affects your ability to tolerate sulfur, and you need enough molybdenum to deal with it. As we said before, this gene breaks down those neurotransmitters epinephrine, norepinephrine, and dopamine by adding a methyl group. It also breaks down drugs for hypertension, asthma, and Parkinson's disease. Those of you with the COMT, especially the double COMT, you will greatly benefit from adenosyl B12 or hydroxyl B12. And the reason behind this is because if you have the COMT, you're not breaking down your epinephrine nor epinephrines properly, so your adrenals are feeling like they're constantly surging through your body, like your body is stuck in fight or flight. Now, when you take regular B12, it can help add to that burden. It can also add to the burden if you are making too much methyl at the time. So if you are making too much methyl or you have the double COMT, you're going to want to take the adenosyl or hydroxyl B12. When you go to buy it, it's generally together. This will also help if you suffer from a lot of nerve pain and if you suffer from a demyelinating disease like MS, because it helps rebuild the sheath around your nerves. And with mast cell problems, the sheath around your nerves takes a beating. If you take hydroxyl B12 and you feel flu-like symptoms, you need to be tested for cyanide toxicity from the cyanobelamine B12. It means that the hydroxyl B12 is chelating your cyanide out of your body. Slow down the amount you are taking. If you take adenoZ B12 and you feel electricity down your arms and legs, that means it's actually repairing the myelin sheaths. Adeno B12 is capable of nerve repair. Niacin can help break down neurotransmitters, and the fact that it does work could also possibly mean you have a niacin deficiency. Those with the CBS gene will produce more sulfur end products in the methylation cycle, and like I said, you need enough molybdenum to help with the sulfur. They will also react more to cruciferous vegetables, garlic, onion, and supplements, because a lot of them have sulfur in it. The COMT can also deplete your BH4, which then in turn affects your entire BH4 cycle. The MTHFR 1298, for example, cannot work if BH4 is depleted, and this shuts down that whole cycle like I was saying. When your MTHFR is low, it lowers the activity of the COMT gene, so it makes it even harder for it to work. The toxins and neurotransmitters can build up and you're unable to detox them. When the COMT is too fast, it also chews through your BH4, and caffeine makes this worse. And then the MTHFR can't work, and you chew through essentially all your vitamins, minerals, and enzymes. And this all creates a negative feedback loop. Toxins will build, and you will feel absolutely horrible. The COMT can also deplete SAMe, and it can make your homocysteine levels higher. Those with COMT will also have issues with opiate receptors that can also be stimulated by dairy and gluten. This can lead to anxiety with opiates, caffeine, dairy, and gluten. Individuals with COMT are actually harder to put under for anesthesia due to the epi, norepi, and dopamine levels. And this is primarily due to the fact that you have more adrenaline hormones running through your body. So it's harder to put you under anesthesia when your body's all ramped up. The other point to make is those of you who are really sensitive to medications, what can happen is if your body is calm and you receive the anesthesia, it can trigger that fight or flight response, and the COMT can be responsible for this. And so what happens is you get those meds to put you under, and then all of a sudden your body ramps up instead of getting put under like it's supposed to be. And this winds up resulting in them having to give you even more to bring you and put you under. The COMT can also affect certain enzymes like the G6-PDH, and the G6-PDH has to do with glucose. It will mess with blood sugar, metabolism, red blood cell formation, and blood vessel stability. And this will lead to easy bruising, bleeding, and broken blood vessels along with vascular imbalances. Now I put these in here for those of you who have a total and complete gene report for yourselves. The individuals with the G allele in the RS6269 may have low dopamine and epinephrine levels, and the individuals with the A allele in the RS6269 will have higher levels of these transmitters. 61P199P is associated with low dopamine, norepi, and epi. SNPs in the H62H and the Victor 15 mic can cause anxiety in individuals with high epi, norepi, and dopamine, especially when they are given methyl B12 or methylfolate, since these transmitters are not being broken down. So again, if you have a full genetic makeup for yourself, this information can wind up being helpful to you. The COMT also talks extensively with the MTHFR, the CBS, and that one controls your cysteine levels and is also what dictates your mast cell issues, and the G6-PDH, which is your glucose. It also affects personality and mood further if you have the MAO A on top of it. It affects your Methionine Cycle, and that's the part of the Transulfuration, the part that branches down off of it, and your BH4 cycle. Those with the COMT, especially a double COMT, you're going to want to avoid caffeine. You're also going to want to avoid catechol-raising foods, and that's like your chocolate, your dairy, your gluten, etc. You do not want to nap, because if you're napping, you're not detoxing those neurotransmitters. You want to minimize or eliminate gluten and dairy intake because this raises your catechols. And if needing anesthesia, notify them you have this gene and what that means. The supplements you can take with this one are the adenosine B12 or hydroxyl B12. Now the niacin, NAD, and D-ribose will help make the MTHFR enzyme. Now there are some steps you can take in order to help your COMT gene. You're going to want your B vitamins. Since the COMT is involved in methylation, foods rich in B vitamins like oats, bananas, fish, and I know it says soy here, but most of it is GMO, so avoid it. Beans, peanuts can help support its activity. Phytonutrient intake. COMT is responsible for processing certain phytonutrients. It's key to avoid overconsumption of phytonutrients so as not to tire out a slow COMT. Stress management. COMT gene changes can lower the body's ability to move stress hormones, so it is important to adapt a stress reduction habits and practice self-care. Exercising, and this one is kind of important. Exercise increases catechol levels, which can be difficult to process with a slow COMT gene. Thus, according to your COMT type, you may want to avoid overdoing strenuous exercise, and a lot of people will need yoga, tai chi, or qigong instead. Estrogen. Excess estrogen slows down COMT gene even further, so another point is to not drink caffeine, which raises your estrogen up by 80%. It can be helpful to avoid overconsumption of estrogen boosters like dairy, flax seeds, and sesame seeds as well. Mealtime can also be extremely important for those who have this gene. Starving can lead to the production of catechols, resulting in the overwhelming of a slow COMT gene. However, if you have this, you might want to eat earlier, kind of like the early bird kind of deal, like if you can eat between 3 and 5 p.m. So that way your body has enough time to work out everything before it's time to go to bed. Caffeine. Swapping out caffeine is essential. I know it says you could swap out coffee for green tea on here, but honestly, if you have the double COMT, just avoid it altogether because it will make things worse. It will chew through your entire BH4 cycle and you'll be depleted before your morning is even over. The COMT and the VDR gene. Now I put this slide in here for folks who know exactly what parts they have in their COMT and their VDR gene. But like we discussed earlier, vitamin D is essential for the COMT to work properly. But you can pause this and read through all this because it has the different ways that your body will respond based on what types of genes you have together. This can also be found in the gene and SNP slides. COMT testing. You'll want to test your estrogen levels via the urinary Dutch test, urinary neurotransmitter test, or the urinary organic acids test. If the HVA, that's that homovinylic acid, is low, it could be a sign of low dopamine production or slower breakdown. You want to check your tyrosine levels. Measure your intracellular RBC, that's your red blood cells, magnesium levels. Magnesium and taurine go together. Screen for endocrine disrupting chemicals like glyphosate, DDT, and phthalates, and measure your BH4. The VDR, and I cannot tell you how important the VDR gene, and that is your vitamin D levels. Most people are chronically deficient in vitamin D, especially if you live anywhere where there's winter. Those with this gene are going to need extra vitamin D3 and plenty of sunshine. You're also going to constantly monitor your vitamin D levels, especially in the springtime and in the winter time. You're also going to want to make sure that you're taking anywhere from 5,000 to 15,000 IUs per day. That shouldn't be a permanent thing. However, anything over 15,000 does not help you. Keep your vitamin D levels above 100 nanogram per milliliter or 250 nanomoles per liter. Vitamin D is antimicrobial. It is anti-cancer and anti-inflammatory. It is responsible for regulating gene expression, DNA methylation, cell proliferation and differentiation, immune response, cytokine regulation, blood sugar regulation, pancreatic function like your digestive enzymes, insulin resistance, and type 1 diabetes, phosphate levels, calcium levels and calcium absorption. It's also responsible for regulating neurotransmitter formation of dopamine, which could also affect depression and seasonal affectiveness disorder, and it can also have some impact to your serotonin. Vitamin D deficiency has been linked to the dysregulation of dopamine and serotonin neurotransmission. Dopamine helps fight against microbes and metals. Vitamin D also helps the methionine cycle via the BHMT. Low vitamin D correlates with low B12 and folate uptake. VDR could provide an alternate route for brain folate uptake. Vitamin D increases CD4+, T cell DNA methylation, and reverses autoimmune degenerative diseases and demyelination diseases. Many will have issues with the COMT MAO with VDR mutations, and that will result in aggressiveness, stress response outbursts, argumentative personality, and bipolar. Proper vitamin D levels will help with mood and energy. With this, you're going to need vitamin D, and for a lot of folks, you're going to need K. However, you cannot have vitamin K if you have a heart transplant or if you're on certain types of blood thinners, so make sure you work with your doctor. Calcium. Do not take the calcium, though, unless you're below normal. You'll need magnesium, you may need zinc, chromium, a low-carb diet, and absolutely positively no GMOs. You don't want GMOs anyway because they damage tissue in the body, and we discussed that in the inflammation video. Those with a vitamin D deficiency, it's going to affect you in a myriad of ways. There'll be severe muscle weakness, which can result in being bedridden due to the fact that your muscles just can't function. It affects your brain, such as depression and seasonal affectiveness disorder, neuroinflammation, like spine pain inflammation and brain inflammation, neuropsychological diseases such as Alzheimer's, Parkinson's, MS, dementia, mood disorders, schizophrenia, and cognitive dysfunction. It affects the circulatory system. You'll have an increased risk of cardiovascular diseases, hypertension, heart failure, ischemic heart disease, and stroke. It can also affect your respiratory system, such as upper respiratory tract infections, tuberculosis, lung disease, such as chronic obstructive pulmonary disease, or COPD, decreased force of expiratory volume. That's that one where you blow in the tube and they try to see how much air you can blow through it. Asthma and wheezing. It can affect the pancreas and result in insulin resistance, type 1 diabetes, and digestive enzymes, which means you're not getting enough into your stomach to digest your food. Vitamin D deficiency can also affect your bones, which can result in secondary hyperparathyroidism and bone loss, such as osteoporosis, easy fractures, mineralization defects, which may lead to osteomalacia, muscle weakness causing falls and fractures, can lead to serious illnesses, diseases, and cancer. The MTHFR plus the MDR plus the VDR has a higher risk of thyroid cancers. A low vitamin D also correlates with low B12 and folate uptake. VDR mutations. Now, these can be made worse with the CBS mutation, the NOS mutation, and the COMT gene mutation. Now, we showed you earlier that the VDR pathway shoots directly over to dopamine big time. So you remember how we were talking about how important vitamin D is to help balance those epinephrines and the norepinephrines building up in your system? Well, vitamin D helps fight all that, and all of that congregates around the MAO B and the COMT as well. The VDR mutations has two subsets. It's the TAC and the BSM. The VDR TAC and the VDR BSM polymorphisms may adversely influence DNA expression during the methylation cycle. Those with this gene will definitely feel seasonal affectiveness disorders a lot more. These VDR genetic variants may also affect depression because of the way they mediate the production of the neurotransmitter dopamine. Vitamin D also has many functions. It's an issue because 90% of patients have low or low normal vitamin D levels. So vitamin D is critical for us. And unfortunately, many folks with these gene mutations are also going to suffer from the MAO and the COMT gene. This is where the aggressiveness, stress response, and argumentative personality and bipolar-like symptoms are going to appear. If you have the mutations in these genes, the VDR, COMT, and the MAO-B, and symptoms have gotten much worse, and or you were supplementing just fine with regular methyl B12 or B12 before, and then you had to switch to adenosyl hydroxyl B12, that is telling you you need to detox because these pathways are getting overburdened and are not working correctly. You gotta detox. And one other thing to mention, you know that scourge that's been plaguing mankind the last couple years, and its preventative measures. If you don't have enough vitamin D, it's going to hit you much harder. Because remember, vitamin D regulates cytokines. It prevents a cytokine storm and can affect your mitochondrial RNA and helps regulate the cardiovascular system and supports the lungs. They also have profound effect on the heart, brain, kidneys, and liver. It's all connected. Now, the VDR TAC, you'll be lower in vitamin D levels, you'll make less dopamine, you'll need and will tolerate dopamine precursor substances and methyl donors much easier. The VDR-BSM, that is part of the liver detox. Now, for the VDR-FOLK, functional polymorphisms that lead to different translations that leads to 3 amino acids becoming longer and less effective protein, and it affects your mitochondrial DNA. It'll affect your cardiometabolics, affect your blood sugar, and it will also affect your pancreatic function. However, the VDR-FOLK does not affect dopamine metabolism. With the VDR-FOLK, you will need vitamin K. And again, do not use it on blood thinners without a doctor's support. You'll need a low-carb diet, and you'll most likely need to supplement with chromium. The VDR mutations has been clinically observed that the body may have trouble tolerating methyl donors with COMT and VDR TAC+. A double negative VDR TAC individuals may already have higher levels of dopamine. Many use SAM-E and other methyl groups to degrade dopamine. Those with normal vitamin D receptors make plenty of dopamine. They tend not to tolerate extra methyl groups or dopamine precursor substances. And the caffeine, again, will adversely affect the VDR, the COMT, and the MAOs. Now, if you know you have COMT, and you know you have VDR or any of the other variations of the COMT VDR, you're going to want to look at this chart because you're going to want to take a look at your genetic readout and to figure out how many copies of the COMT you have, how many copies you have of the VDR. Because this right here, this chart, is going to tell you exactly what to do with that combination of those particular genes. All right, we're going to look at this chart and I'm going to break it down a little bit for you. So, if you have the double COMT, which means you received a mutation from both parents, so you have 2 copies. But you do not have the VDR TAC mutation. You got the negative. That means you did not receive any copies of the mutation. You're going to have the highest dopamine levels. You're going to have better tolerance to toxins and microbes. You're going to have a low need or tolerance for dopamine precursors and methyl donors. Plus, you're going to have the greatest susceptibility to mood swings. The gray part underneath is just a translation of what's in this paragraph. So basically, if you have the double COMT and you don't have the VDR TAC, you're generally going to need unmethylated vitamins for methylation. And of course, there's always exceptions to the rule, which I have provided. If you have the MTR, MTRR, this will increase your need for methyl B12. However, it is better to start with adenosyl hydroxy B12 to avoid ODing with methyl groups. Now again, this is provided you have enough free methyl to create methyl hydroxy B12 to begin with. We do not want to have dopamine precursors like quercetin and Purines, and a diet high in tyrosine. You want to avoid that with this combo. You would also be more susceptible to iodine and lithium depletion as they detoxify. So you're going to need to monitor and supplement accordingly. If you have a negative COMT mutation, but you have a double VDR mutation, which means you have 2 copies, one from each parent, you're going to have the lowest dopamine levels. You're going to have a poor tolerance to toxins and microbes. You're going to have a need and tolerate dopamine precursors and methyl donors. And remember, dopamine precursors are like tyrosine. You're also going to have the lowest susceptibility to mood swings. With the negative COMT and the double VDR, you will generally need methylated vitamins and supplements. Methyl B12, melatonin, turmeric, and theanine. You can also use MSM and SAMe, but only if you do not possess the CBS mutation. The TMG betaine is also a methyl donor, but only if you do not possess the BHMT mutation. Instead, to support BHMT, you will want to use phosphatidylserine and DMAE. You will need methyl B12 with the MTHFR. You will need dopamine precursors like quercetin, ginkgo biloba, Mucuna Purines, which is actually an herb. It's an herb, and a diet high in tyrosine. Instead of using GABA for excitotoxicity, you're going to want to use, the actual supplement's name is called Zen, and I did look it up. That does exist, and it's basically just GABA with threonine. If you have 1 copy of the COMT and no copies of the VDR, it's going to behave like this first one, and that's where you need unmethylated vitamins for methylation, etc. If you have 1 copy of the COMT and 2 copies of the VDR, it's going to behave like the second group right here, which means you'll generally need methylated vitamins and supplements. And if you have both the VDR and the COMT, you have both sets of those mutations, vitamin D is going to be your friend, and then follow the rest of the rules on this chart. Even though medicine and medical journals don't fully understand the methylation cycles and vitamin D metabolism pathways yet, however, the two are very much intricately tied. It is my opinion that the lower the methylation, the more difficulty it will be to metabolize vitamin D. With lower methylation, more pathways are sluggish, which could result in buildup of toxic byproducts and negative feedback loops, especially if you have the CYP genes, TAC and BSM. And the CYP genes are part of the detox genes of methylation. The relationship is clear as to how methylation cycles affect the vitamin D pathways. If methylation is hampered, so is the liver, because methylation occurs in the liver, pancreas, and the gallbladder, but this will have a trickle-down effect to the kidneys. If folate metabolism is hampered and B12 deficiencies, which you can't uptake without vitamin D, would adversely affect the brain, the neurotransmitters, and blood vessels. Everything is tied together. It is such intricate detail. So your vitamin D metabolism and the vitamin D that you absorb, it either comes from your food and supplements or it comes from the sun, and both are very much equally important. So the vitamin D that you get from food is metabolized, and it needs those genes and enzymes from the kidneys and the liver, and those are your CYP genes that you'll see up above. Another reason why it's important to take care of the liver and kidneys, and another argument for detoxing the body and fixing these processes. When they get overburdened, they will not work properly. Vitamin D from the sun is taken in and transferred straight to the brain, the nervous system, and to the neurotransmitters for support. So if you're having problems with neurological issues, you need more sun as well. If you have the CYP2 Romeo 1 or the CYP2 for alpha 1, and the VDR can cause negative feedback loops involving vitamin D homeostasis. Now, all these CYPs, you should be able to see them on your methylation detox report. But what's important for you to understand is that these particular CYP genes that are listed throughout this slide all have to do with vitamin D. So we just got done talking about the different genes within the BH4 cycle and the genes that the BH4 cycle supports. So the BH4 cycle can be affected by too much protein, a lack of 5-MTHF, a lack of SAMe, the COMT and VDR gene mutations together, the DHPR, the CBS, the SUX, also the MTHF 1298 and or the 677 tango. The 1298, like we said, affects proper metabolism and methylation of SAMe, and the 677 affects the metabolism or methylation of folates, turning them into 5-MTHF. This is something you have to address if you have the MTHFR 1298 gene and the 677 tango, which affects your folate metabolism into THF and 5-MTHF, causing issues with nitric oxide, superoxides, and peroxynitrate. These affect the BH4 cycles like we discussed earlier, or just making sure you're getting enough leafy greens to generate your MTHF. So even if you have the 677 and you can't handle vegetables, at least get your leafy greens in somehow. This cycle also affects your neurotransmitters like histamine, dopamine, and serotonin, which will affect your moods and your stress responses. It'll cause aggressiveness and argumentative, emotional stress response outbursts. This one is extremely noticeable. ADD, ADHD, bipolar, depression, significant anxiety, or panic attacks. Because this cycle tends to come with the COMT gene, as well as a whole host of other mutations, up to 200 different SNPs, the constant onslaught of adrenaline, the epi and that norepi we're talking about, will cause nerve pain and inflammation, brain issues, muscle issues, especially if you have the DHFR impairment with it, and it can cause stripping of the myelin sheathing on nerves, which usually results in things like MS. This is also associated with ammonia buildup in the body, especially if you have the CBS and possibly the SUX. Now I know we just got done talking about the COMT and the VDR and how they act together. But if you do have them, you'll generally get sick less frequently with colds and flus due to the fact that you have a higher norepi levels and your immune system is cranked up pretty high, which is actually kind of hard on your organs like your kidney, brain, heart, etc. But you'll be far more sensitive to other things like foods, meds, supplements, allergies, and other triggers. Okay, we have talked about the genes in the BH4 cycle and all of the genes that the BH4 cycle supports. So let's take a look at how these cycles work. Remember our little friend 5-MTHF that we learned in the folate cycle? Well, guess what? It gets used in the BH4 cycle as well. Your 5-MTHF gets moved to the BH4 cycle via the MTHFR 677 tango. Step 2. The BH4 then converts the tryptophan, tyrosine, and arginine into serotonin, dopamine, and nitric oxide. It uses BH4 to do this, and that process turns the BH4 into BH2. So this step is basically taking biochemicals and turning it into usable neurotransmitters and nitric oxide. It is using the BH4 in order to do that. And when it uses the BH4, it winds up leaving you with BH2. And the next step, which is step 3, is all about taking that BH2 and recycling it back into BH4 so that it can start the process all over again. Let's take a look. Once you have the leftover BH2, it uses the 5-MTHF, folic acid, and SAMe to turn it back into BH4. Note, if you have the MTHFR 1298 Charlie, you must make sure you have enough SAMe to make this process work. Because remember, the MTHFR 1298 affects your SAMe production. Also, if you have the 677 tango, it can also prevent the availability of the 5-MTHF moving from the folate cycle over into the BH4 cycle, making it that much more difficult for you to recycle your BH2 back into BH4. And this is very important for you to understand, because this cycle is what's dominantly controlling your neurotransmitters and your moods. So it's going to have a huge effect on your physical well-being and your moods. It is also going to affect your ability to detox the toxins out of your body. And these particular toxins are going to attack the brain, your nervous system, your heart, your liver, as well as your soft tissues, your organs, your cells, and your mitochondria. So the BH4 cycle is actually extremely critical to your health and your overall well-being. And remember, you got to be eating your leafy greens and getting sources of folate to make your 5-MTHF. So if you're not getting enough fruits and vegetables in your diet, you're also not going to be able to make this recycle of the BH2 into BH4. So this little cycle goes around and around. BH4 gets used to make tyrosine into dopamine, tryptophan into serotonin, and arginine into nitric oxide, which then leaves you with BH2. Then 5-MTHF, folic acid, and SAM-E turn it and recycle it back into BH4. So this little cycle just keeps going. So what happens if it doesn't work? Well, we're going to find out about that in a minute. But I do need to tell you that inflammation and oxidative stress are going to chew through your BH4 levels, and it's going to create XPH2, dihydroxanthopterin. Without getting into the long, drawn-out scientific explanation, XPH2 is unstable and easily oxidized. If you make too much XPH2, it can completely mess with your BH4 metabolism and the cycle. This affects your cell homeostasis, which means it affects your cells and mitochondria, causing damage to them. And this can be linked to neurological conditions. This will also come out in urine with those of you who have phenylketonuria and lethal hyperphenylalaninemia, otherwise known as PKU. To spare my brain from flipping out trying to say these words, for all future videos, we'll be calling it PKU and nothing else. I just gotta entertain myself, I guess. Alright, back to work. So in a nutshell, it's very important that you reduce your inflammation, your oxidative stress, so that it doesn't chew through all your BH4. If your BH4 gets chewed through, then you're not going to be able to make serotonin, dopamine, and nitric oxide, which is going to have a lot of effects on your mood and your health. So this is pretty much how the main part of the cycle works. But you know me, we're going to take a closer look at it. I want you to think of BH4 as like money. BH4, for every biochemical reaction that's taking place in the BH4 cycle, it'll cost you a certain number of BH4 to make that process work. So just like the mitochondria makes ATP, which is the energy your body feels, certain biochemical reactions inside the body requires so much energy, so it requires a certain amount of ATP. The BH4 works the same way. So think of BH4 kind of like money, and every action you want to happen in the cycle is going to cost you a certain amount of BH4. So if you can remember as BH4 like money, then you're going to understand 1, how you run out of it faster, and 2, when you do run out and you don't have enough, it causes harmful side effects. So when BH4 is used as a cofactor, BH4 converts to BH2. So like I said before, you use BH4 to turn phenylalanine into tyrosine, then you use more BH4 to turn tyrosine into dopamine, more BH4 to turn tryptophan into serotonin, and more BH4 to turn arginine into nitric oxide. Now that's a lot of BH4 just right here, and we still have to use BH4 for other functions. So as you know, what we have left over is BH2, but BH2 can be used as well. BH2 and BH4 can also function as a cofactor for various NOS enzymes. So BH2 can be recycled back into BH4 via the DHPR, okay? Now, if your BH2 levels are high, then THF, that's your folate levels, will appear to be reduced. You'll have elevated BH2, which will turn into superoxides. That's bad. If BH4 is oxidized, it also turns into superoxides. Again, that's bad. So superoxides cause like a form of rust inside of the body. So it would damage different systems and organs as well. Okay, so what does this oxidized stuff mean? We said that superoxides are bad, but what does it mean to you exactly? Let's use a car as an analogy. A car and your body are both a complex piece of machinery, and oxygen is constantly trying to kill both. On the car, this shows up as rust, and as your car rusts, it starts looking its age and starts degrading the different parts in the car. There are symptoms that pop up as the parts are wearing out, like the engine, the axles, the mufflers, etc. It still works, but the symptoms worsen till the part either breaks or just falls off the car completely. Well, basically the same thing is happening to your body, except hopefully nothing's falling off of you. Superoxides to your body is equivalent to oxygen rusting the metal on the car. It causes damage to your cells and organs, and if you don't fix it, the parts break or result in cancer, neurological issues, etc. And while it's doing damage, you're going to feel this as pain in your joints, pain in your muscles, and you're just generally not going to feel well. And this is because it's much harder for your body to break down superoxides or detox superoxides out of your body. It's kind of like a supervillain, constantly creating chaos in your body, super powerful, and not easily defeated. So that's essentially what oxides and superoxides do to you. It's all oxidative stress to the body. So how do we make them, and how do they relate to this cycle? So BH2 and BH4 can both couple with NOS. If NOS is coupled with BH4, it converts arginine to nitric oxide. If NOS couples to BH2, then it promotes superoxides and hydrogen peroxides. All right, I need to take a short pause right here. Now, the BH4 cycle is by far the hardest to explain because all the methylation cycles impact the BH4 cycle. And the BH4 cycle feeds the rest of the methylation cycles to include directly impacting the mitochondria. So it skips around a lot, and we've already seen how the folate cycle also feeds into the BH4 cycle. So I'm doing my absolute best to make this as easy to understand as possible. We've been talking about how the BH4 can convert arginine into nitric oxide so far, like it does for the neurotransmitters. But with nitric oxide, there's a few additional things happening. In order for this process to work, we have to look at the urea cycle at the exact same time. So we're going to start bleeding into the urea cycle here. These two cycles definitely go hand in hand, because if we're going to take arginine and turn it into nitric oxide, we need the NOS gene to make that happen. And for all of you out there who have a lot of knowledge about this, it is the NOS2 and the NOS3 specifically. But for our purposes, we're just going to refer to it as the NOS. In order to turn arginine into nitric oxide, we need the NOS gene working right. But one of the three things can happen here. It's either going to work perfectly, we may be short on BH4, or the NOS mutation, or it gets coupled with BH2. When it works properly, arginine will be turned into nitric oxide via the NOS gene. Nitric oxide being a powerful vasoprotective molecule that protects the cardiovascular system and the brain. And this is a good thing. Now, if the NOS isn't working properly, either via a NOS mutation or a BH4 deficiency, you're not exactly going to make nitric oxide. Instead, you're going to make superoxides and peroxynitrate. These are harmful free radicals. Now, the superoxides can further damage your nitric oxide levels in your body, which is bad. Believe it or not, vitamin C can actually help neutralize superoxides, provided that you can tolerate it. The peroxynitrate will degrade BH4, and this can give you a deficiency in BH4, and this will become a terrible vicious cycle, and one you definitely want to avoid. Now, the third thing that can happen, remember how we said BH4 or BH2 could bind to NOS? If BH2 binds to NOS, then it can make superoxides and hydrogen peroxide. Superoxides, as we said, can further damage nitric oxide, which we need vitamin C to help neutralize it. But superoxides and hydrogen peroxide is a metabolic poison that can cause severe bioenergetic dysfunction and cellular damage. It can cause a collapse of redox homeostasis, organ failure, microvascular dysfunction, and septic shock. Now, redox is an oxidation of the molecules like these. And as we talked about in previous videos, hydrogen water could be helpful, but not if you're not making enough BH4. So it's just another, redox is just another oxidative process in the body, which is completely different from the oxides that we're talking about here. But if you're making superoxides and hydrogen peroxide, you're going to cause a redox imbalance, and that's going to wreak havoc on your body. Now, you can see here where I have this superoxides, peroxynitrate, superoxide, and hydrogen peroxide. These pathways right here, this will cause inflammation, damage to the mitochondria, the brain, and your cardiovascular system. So it's really important that you're making nitric oxide and you're giving your body the correct BH4 and the nutrients that it needs to work properly. And for those of you wondering what redox is an oxidation reduction process or reaction that involves the transfer of electrons between chemical species like atoms, ions, molecules involved in the reaction. These happen all around us. In our bodies, though, it's happening in our cells and in our mitochondria. It involves cellular respiration and how the oxidation and reduction process takes place inside of those cells, the way the electrons gets transferred over. And if you don't have enough BH4, your body has one trick up its sleeve to help you out here. Remember how I said 5-MTHF and BH4 has molecular mimicry? Well, here is a part of the BH4 cycle where folate becomes indispensable to it. Because they have molecular mimicry, they can bind to each other's receptors. Think of it as a redundancy to help you maintain your health in case you're low on one biochemical or another. This can actually come in very helpful, especially when it comes to helping you keep your brain healthy. So as you can see here, the 5-MTHF in the BH4 cycle helps to neutralize the peroxynitrate, which is a damaging free radical. It also helps spare BH4 because of the molecular mimicry. So 5-MTHF helps NOS get converted into arginine. So the main takeaway I need you to get here is that if you don't have enough BH4, your body can use 5-MTHF to substitute the BH4. And to be perfectly honest, your brain actually needs 5-MTHF. So it kind of is a redundancy, but it's also a necessity. So whatever you do, if you eat no other fruits and vegetables, at least make sure you're getting your leafy greens. The 5-MTHF also comes in extremely helpful if you cannot recycle your BH2 back into BH4, whether it's due to other genetic mutations like the DHPR, or if your MTHFR 1298 is flipping on SAM, so you're not making enough SAM, so you're not able to convert that BH2 back into BH4, and also if you don't have enough folic acid. So the 5-MTHF helps with that. By using 5-MTHF to bind with NOS, it helps leave enough BH4 to convert phenylalanine to tyrosine, tyrosine to dopamine, and tryptophan into serotonin. So, the NOS binds with 5-MTHF, and then it gets converted into arginine. It's from here that this biochemical reaction can be helpful or harmful based on available enzymes and nutrients. Now, we've already gone over this chart. All I wanted to do here was illustrate that if you didn't have enough BH4 or you weren't recycling it properly due to genetic mutations like the DHPR or the QPDR, or you had deficiencies in SAM-E, which could be due to the MTHFR 1298, or folic acid, the 5-MTHF can step in and help you convert arginine into nitric oxide via the NOS. However, it cannot help you converting your neurotransmitters. Only the BH4 can do that. The 5-MTHF only works with the NOS and nitric oxide. So we said NOS coupled with BH2 will promote superoxides and hydrogen peroxide, which is bad for our health. To avoid making superoxides, BH2 gets recycled back to BH4 via the QPDR, the DHFR, and the DHPR. Now, the QPDR sits between the folate cycle and the BH4 cycle. The DHFR, that gene is within the folate cycle, and the DHPR, that's the gene that's inside the BH4 cycle. DHPR, the gene DHPR, salvages unstable dihydrobiopterin, that's actually BH2, and it converts it back to BH4. Okay, so to clarify on this, we have DHPR, the gene, and that is inside of your BH4 cycle. That's where this red arrow is, and it's recycling your BH2 back into BH4. On the chart on the right, that is the recycle process of the BH4 converting everything into your tyrosine, dopamine, serotonin, nitric oxide, and then you have your BH2, which is then being recycled using the 5-MTHF, folic acid, and SAMe back into BH4. Now, the interesting thing about this is the DHPR is a gene, but its BH2 is called dihydrobiopterin, which is also DHPR. So DHPR is the gene, but it's also BH2, two separate things, okay? So the DHPR that's salvaging the unstable dihydrobiopterin, that's your BH2, is the gene that we're talking about right here. Now you have your DHFR, and remember this is in the folate cycle. So an easy way to remember is the PR is the biopterin, and the P being in the BH4 cycle, and the F being part of the folate cycle. So like we just said, the DHFR is in the folate cycle. Now, we've covered this process in the folate cycle quite in depth in the section of the video in folates. But what is important here for you to know is that the DHFR in the folate cycle is helping you to recycle that harmful BH2 back into BH4. The QPDR, this is the enzyme that is also used for recycling BH2 back into BH4. And the BH2 levels are only high if the QPDR, which is a gene, isn't working correctly. But the cool thing about this is that the DHFR can be used as a fill-in replacement if the QPDR isn't working properly. Now, keep in mind, this is all regarding how the BH4, BH2 is coupling with the NOS. All of this falls under the NOS in order to prevent you from making superoxides and hydrogen peroxides and peroxynitrates. Now, I can make an entire video just on this process alone, which regards the NOS and the BH2, BH4 recycling process and the harmful oxides. I was originally going to leave this out of the video, but I wanted to put at least this much in the video for some of our more science-savvy folks. However, these genes and enzymes that work with the NOS, if this process here isn't working or you're missing some of these enzymes, you would know it. It's generally caught early in life and would require medical care. However, if your methylation cycles get far enough off, you can cause these issues as well. And if that's the case, then it can be healed. Supplementation of MTHF alone or with BH4 may prove beneficial for those who have low BH4. Supplementation of BH4 may increase BH2, but so far no evidence of harmful effects have been noted, or that it would help the folate cycle. Increasing 5-MTHF can increase BH4 by preventing oxidation to the BH2. And supplementing BH4 with NOS enzymes further prevents its degradation. Alright, so you know how we said that BH4 was like money. Certain biochemical reactions require a certain amount of BH4. So the NOS is converting arginine and turning it into nitric oxide. This is going to have to take 2 BH4s to have a healthy metabolism of arginine. Now just keep in mind, this is how it works in a perfect world, free of arginine issues and free of NOS issues. Now if you don't have enough BH4, say only 1 BH4, it's going to result into peroxynitrate. And if you don't have any BH4, you're going to wind up with superoxides. This is all predicated on the fact that NOS and arginine, etc., are all working properly. If this happens, you're going to result in inflammation, damage to mitochondria, which is the Krebs and citric acid cycle, and your mitochondria also needs that nitric oxide to stay healthy. It'll damage your brain with neuronal damage and microglial activation. And microglial activation is the resident immune cells of the central nervous system, which normally responds to neuronal damage and removal of the damaged cells. This can lead to neuronal loss over time and brain diseases. And remember, this is all taking place inside and is part of the urea cycle. As you can see here, this is the representation of a microglial activation. You can see the inflammation builds with each stage of microglial activation. Here you can kind of have an image of what it looks like on the left-hand side to have microglia, and then on the right-hand side to have disease microglia. You'll see there's a huge difference between the health in the two and the neuronal damage, and the senile plaque builds, the large fibrils, small fibrils, and oligomers. The only thing I'm trying to illustrate here is you can tell the difference between the healthy ones and the diseased ones. That's all I'm trying to show you. When you have neuronal damage in activated microglials, and over a long period of time to where it becomes diseased, you wind up coming down with things like Alzheimer's disease, Parkinson's disease, frontal temporal dementia, as well as many other brain-related diseases. But it's important that you have enough BH4 to convert your NOS into nitric oxide so that you can prevent these types of diseases from happening. This is all taking place and is part of the urea cycle. Now, there are some other genes that play into this, and we will talk about it, but it's part of the urea cycle. Now, even though that this part of it is taking place in the urea cycle, none of this works without BH4. That BH4 is integral for you to be able to take arginine and turn it into nitric oxide via the NOS, so that you can prevent from making peroxynitrates and superoxides. And that's the whole point of this. The BH4 cycle bleeds into the urea cycle, and the urea cycle is not going to work properly without that BH4. How do you boost your BH4? The absolute best way, hands down, to boost your BH4 is by balancing your methylation and a balanced diet to manage your BH4 levels. A small portion of protein, a complex whole food starch, and a hefty leafy greens. Do not eat too much protein because, as we have said earlier, too much protein depletes your BH4. You want to stay away from caffeine, white sugars too, because it will chew through your nutrients, vitamins, and minerals that support your methylation, especially if you have the COMT gene, because if you mix caffeine with the COMT, you're going to chew through all your vitamins, minerals, nutrients, enzymes a whole lot faster, and it's going to throw your methylation cycles further out of balance. Pteridine 4. This helps with BH4. However, it's extremely difficult to find, and I don't recommend it unless you have a significant inherited BH4 deficiency issue. You'll need 2 forms of folate. Folinic acid and L5-MTHF can also help you with your BH4. But if you're eating your leafy greens, you really shouldn't need it. Royal jelly is actually also known for its natural occurring BH4. SAM-E does help with BH4, but remember, depending on your methylation status, whether you're an over-methylator or an under-methylator, this can be helpful or harmful for some folks. Microdose lithium. This is also known to help increase BH4. But again, keep in mind, you don't have to take supplements to fix your BH4. You can do this with detoxing the pathways, healing, and proper diet and lifestyle. That's all you really need. By taking more and more supplements, you're not doing yourself any favors when the best medicine is the food itself. And like we were saying, the BH4 cycle, and I know we've talked about this extensively, this is where your ADD, ADHD, bipolar, depression, aggression, insomnia issues, your gut motility, neurodegeneration, anxiety, heart racing palpitations, your POTS, your neurological issues, your memory issues, buildup of the harmful phenylalanine in your system, the PKU, all of that falls under the BH4 cycle. We have finally made it to the Urea Cycle, otherwise known as the ammonia cleanup cycle, the last cycle within methylation. I bet you're happy about that. I know I am. Let's take a brief look and see what we've learned so far about the Urea Cycle. In simple words, the Urea Cycle is a biochemical pathway that converts ammonia present in the body to urea or urine. The cycle helps to excrete two harmful gases, ammonia and carbon dioxide, from the body. You can see the mighty mitochondria plays a part specifically in the Krebs cycle to make this cycle work. But before we dive into this cycle, let's look at where ammonia comes from first. Our bodies are comprised of protein, and protein is required to perform a wide variety of functions. Enzymes, hormones, clotting factors, receptors, they're all proteins. And our body completely turns over approximately 1 to 2% of the protein in our body on a daily basis. This is mostly involving our muscles, so millions of proteins are broken down in the body every single day. And these proteins are broken down into amino acids. Amino acids are basically nitrogen-containing molecules. This nitrogen in the molecules is a big source of nitrogen waste in the body, which is also highly toxic to us. So this is the basic step-by-step process. We have proteins, which are broken down into amino acids, which causes nitrogen waste. And we know this is toxic to us in many ways, especially for the brain. So we know that this gets transported to the liver, and remember, the liver filters the toxins from your blood 7 times an hour, so it's a highly efficient and resilient organ. Then, within the mitochondria, which is in the liver, and the cytoplasm of the liver cells, is where the process takes place, converting the ammonia into urea. And because of this, it's another reason why mitochondrial health is crucial to your methylation cycles, as well as the health of your liver. The mitochondria makes ATP, and that's the fuel and energy you feel every day. And with mitochondria dysfunction and significant methylation issues, you can't make as much ATP either. And that means the urea cycle can't work converting the toxic free ammonia into urea. So if this cycle isn't working because you have liver damage, and remember, the cells in the liver are going to be affected, which then affects your mitochondria in the liver. You're not going to be able to filter out ammonia or nitrogen, and this can build up in the blood and be extremely harmful to your body. And unfortunately, these two things cannot be flushed out with water. So the ammonia and nitrogen can travel to your brain, and you can cause a lot of memory loss, behavioral changes, coma, seizures, brain damage, and neuroinflammation. So to keep this cycle working properly, you've got to take care of your liver, and you've got to take care of your mitochondria. But you know me, after this long of a video, we're going to take a closer look at it, and we're going to look much more detail into how this cycle works. Just keep in mind, we've already covered NOS and how it makes the peroxynitrates into superoxides, etc. when we were in the BH4 cycle, because you needed the BH4 to make the NOS work. So we're not going to get so much into that detail. We're just going to get into how the mitochondria and how the genes and the cycle itself works. The urea cycle is often referred to as the ammonia cleanup cycle or the ammonia detox cycle. Urea is actually nitrogen containing waste substance that the kidneys clear from the blood and excrete through the urine. It uses enzymes that rid the body of nitrogen produced during amino acid metabolism. And as remember we were saying, that comes from protein. The body is mainly comprised of proteins. Those are your enzymes, hormones, clotting factors, receptors, your skeleton, as well as certain cell amino acids. So that's where all your protein comes from. Your body turns over approximately 1 to 2% of protein in your body per day, as we discussed earlier. Now, urine is made up of water, urea, inorganic salts, creatinine, ammonia, and pigmented products. In humans and mammals, almost 80% of nitrogen excreted is in the form of urea. It's produced through a series of reactions that occur in the cytosol and the mitochondrial matrix of the liver cells. These reactions are called the Krebs-Folate cycle. Arginine, which is in your urea cycle, is important. It is a precursor for creatine, which is essential energy in metabolism of muscle, nerves, and testes. And you need this arginine in order to make them work properly. This cycle also excretes two harmful gases, ammonia and carbon dioxide, from the body. It converts ammonia into a urea, as we've been talking about, and amino acids and keto acids wind up being recycled. The urea cycle is primarily carried out by the liver and to a much lesser extent the kidneys. And basically the kidneys' function in all this is just to pass out the urine. This cycle is irreversible and it does require 4-ATP, and that's the energy your body feels every day that your mitochondria makes for you. Only the liver has all the enzymes needed to generate urea from ammonia. So if your liver isn't healthy, this ammonia cleanup cycle is not going to work properly. So that means you're going to have more harmful toxins building up in your system and a harder time getting rid of them. So let's take a look at the genes inside of the urea cycle. We have the NOS, which we've talked extensively about, the OTC, the GST, the SOD, and the GAD, or the GAD. The NOS gene, or more specifically, the NOS2 and the NOS3, a specific set of NOS genes within the NOS family. These genes are involved in ammonia detoxification in the urea cycle. They can have elevated ammonia and cholesterol levels if they're not working properly. The NOSes are a family of enzymes catalyzing the production of nitric oxide from arginine. It's also an important cellular signaling molecule. It is involved in angiogenesis, which is the formation of new blood vessels in your body. It also helps modulate vascular tone, insulin secretion, airway tone, and peristalsis. And what that means is the muscle contractions that moves food down a tube, like your esophagus and intestinal tract. Now, the common symptoms that you may get with the NOS2 and the NOS3 is you tend to have cold hands and cold feet. Older family members have heart issues. You could have blood pressure above 120/80, heal slowly after an injury or surgery. You may be a type 2 diabetic, but you don't have to be. Or you could be postmenopausal, but necessarily don't have to be. Recommendations for those with this gene is to cautiously alternate ALA, carnitine, and fish oil, but you must monitor your ammonia levels. When it comes to NOS testing, short of getting a full genetic profile done on yourself, that's how you're going to know if you have this gene or not. However, if you find out that you do, or you suspect that you might, you will need to monitor your homocysteine levels and make sure they're around 7. You need to keep lipid peroxides low, your LPA in a normal range, as well as your AHCY, and that's an anti-inflammatory type of cholesterol. Check for bacterial, viral, and mold infections. You're also going to want to look at your blood amino acids, which are your arginine, orthonine, and your citrulline. Your ADMA, your homocysteine, your lipid peroxidation. Evaluate your fasting insulin and your serum nitrate and nitrite levels. And you're also going to want to complete a comprehensive digestive stool analysis. That is the CDSA, and it checks for all of these things that are here listed. Next on the list, we have the GAD gene. This makes glutamate, or glutamate decarboxylase. It is used in the brain and in the urea cycle. In the urea cycle, glutamate is the one amino acid that undergoes oxidative deamination to liberate free ammonia in the synthesis of urea. So the only thing that this is saying is that glutamate is important for your body to get rid of ammonia so that you can urinate it out. Once the free ammonia is formed in the peripheral tissues, it must be transferred to the liver for the conversion to urea. And glutamate is a key regulatory enzyme that is needed in the urea cycle. Now, glutamate is also important in the brain. It promotes relaxation and helps reduce anxiety. An impaired GAD is usually indicative of anxiety disorders. And it's involved in the formation of gamma aminobutyric acid, or GABA. Some of you may take GABA when your nervous system is ramped up too high and you're really anxious, and it tends to calm you down. It is also the central inhibitory neurotransmitter of the nervous system. Antibodies to the GAD may impair GABA formation or its inhibitory function. Those with GAD impairments may have more anxiety, panic attacks, and excited nervous system. The glutamate also changes how the body uses copper. This gene also encodes for several forms of glutamic acid decarboxylates. And basically what I want you to know about that is it's identified as a major autoantigen in insulin-dependent diabetes. It catalyzes the conversion of glutamic acid into GABA with pancreatic B cells. Autoantibodies against GAD are found in patients with type 1 diabetes mellitus, stiff person syndrome, and epilepsy. The GAD titer is usually considerably higher in patients with neurological dysfunction. GAD reactivity in central nervous system disorders has traditionally been detected by immunohistochemical staining of the GABA neuron-rich regions in the brain. The ELISA, that's a type of test, methods using recombinant GAD protein as the immobilized antigen are available, and commercially available radioimmunoassays. Now, that's a lot to try to read without stumbling on my words, and it's also a lot to try to understand. So it basically just means that you're not going to be able to make GABA. You could wind up with diabetes mellitus. That also means that your B cells in your pancreas aren't working properly, stiff person syndrome, epilepsy, and there are antibodies that can be found with people with those type of conditions. And obviously this is going to require a doctor's care. And it also is going to be a lot higher levels for anyone who is suffering from neurological dysfunction. That's basically what this is all saying. So, symptoms of GAD impairment. You're going to have anxiety issues, mood stability issues, type 1 diabetes mellitus, like we said, stiff person syndrome, Parkinson's, epileptic encephalopathy. Goodness gracious, I can't talk anymore. And the nutrition is going to be selenium, zinc to improve how the body uses copper and produces GABA. Now, depending on your gene variant, there can be too much or too little GABA in the brain. Proper regulation by the body from nutritional support is what's going to help with this. So your food is going to be your best combat against all of this. And you'll see here off to the right, I have a little chart where it just says GAD is linked to serotonin and dopamine and the neurotransmitters and neurological dysfunction, as well as the liver to separate the ammonia so that you can urinate it out. That's the most important thing I want you to know from these two slides. The OTC gene. This gene is involved in the urea cycle, obviously. The OTC gene provides the instructions for making the enzyme orthonine transcarbamylase. I am really trying really hard with my words because all of these are making my tongue tied. This enzyme participates in the urea cycle, a series of reactions that occurs in the liver cells, and we'll get into this in a few minutes. The specific role of the orthonine transcarbamylase enzyme is to control the reaction in which two compounds, carbomonophosphate and orthonine, form a new compound called citrulline. OTC is one of the 6 enzymes that play a role in the breakdown and removal of nitrogen in the body. Now, the urea cycle processes excess nitrogen, right? And it's generated when protein is used by the body into a compound called urea that is excreted by the kidneys, as we have said. Excreting the excess nitrogen prevents it from accumulating in the form of ammonia, which is toxic, especially to your nervous system. Now, orthonine transcarbamylase deficiency, OTCD, is an X-linked genetic disorder that prevents the breakdown and excretion of ammonia. This allows ammonia to rise to toxic levels and affects the central nervous system. The organ most involved in the processing of ammonia is the liver. Now, symptoms of urea cycle disorder in adults. About 85% of adult female carriers of the defective OTC gene show absolutely no symptoms. However, the rest of the carriers present with symptoms such as headache, protein intolerance, vomiting, confusion, behavioral issues, lack of concentration, and mild hyperammonemia, basically too much ammonia in the body. Forgive me for not being able to say that word. You have to take care of your liver. Those with the OTC deficiency would require liver transplant and would cause hyperammonemic episodes. Now I'm going to show you a short video, and it's going to tell you what happens when your OTC gene isn't working properly and you're not making orthonine transcarbamylase.
Symptoms. So in an ornithine transcarbamylase deficiency, there are a few things that you need to know. The first is that this is an X-linked recessive disease. So ornithine transcarbamylase deficiency is the only X-linked recessive disease that can occur due to an enzyme deficiency in the urea cycle. The other, perhaps higher yield thing to know is what's happening to each of the names that you see on this slide. You need to know how these things change. Do they go up or do they go down? So because it's an ornithine transcarbamylase deficiency, obviously the enzyme ornithine transcarbamylase goes down. When this happens, you have citrulline as the product of what ornithine transcarbamylase usually forms is obviously going to go down. But carbamoyl phosphate will go up because ornithine transcarbamylase can no longer convert the carbamoyl phosphate into the citrulline. Again, this leads to a buildup of our reactants and a decrease in our products. Now, when this happens, the body looks at all of the accumulating carbamoyl phosphate and says, this is abnormal. We need to do something about this. So it attempts to convert the carbamoyl phosphate into orotic acid. Therefore, you have a buildup of orotic acid. And when this happens, ammonia gets trapped inside the body. Because think about it, if you can't form citrulline, you can't proceed through the urea cycle, and you can't ultimately form urea to excrete the ammonia. So the ammonia builds up. Now this is a perfect segue because it'll allow us to talk about what happens when ammonia builds up in the body. After all, why do we even need to urinate it out in the form of urea? Can't we just keep ammonia in the body? Well, the answer is an overwhelming no. Hyperammonemia, or too much ammonia in the body, is extremely toxic and can ultimately lead to death if left untreated. And while there are a number of symptoms that you should be familiar with, the two highest yield are what we're about to talk about now. The first is asterixis, also sometimes referred to as negative myoclonus. To test this, you would ask your patient to put their hands up at a 90-degree angle with the forearm, as you see in this picture. You would then ask them to hold that position with both arms doing this at the same time for approximately 60 seconds. If there's too much ammonia in the body, you'll observe negative myoclonus or asterixis. All of a sudden, they'll have a flapping tremor of their hands while they're trying to hold it at this 90-degree angle. If you see that, that is positive asterixis, and that tells you that there is a toxic level of ammonia in the body. Now, in real life, this could be due to a few things. Notably, it's usually due to liver failure. Again, the urea cycle takes place in the liver. So if the liver is shot, or the person drinks too much alcohol, or the person has hepatitis and develops cirrhosis, and they can't carry out the normal cellular functions in the liver, then instead of going through the urea cycle, ammonia will just build up and you'll observe the clinical symptoms of hyperammonemia, namely asterixis. The other classic symptom is cerebral edema. So you have this toxic accumulating level of ammonia in the body, and ultimately it'll go to the brain and cause an osmotic shift in the brain, causing cerebral edema. Now, what happens when the brain swells? Well, you get certain symptoms, and those symptoms are slurred speech, ataxia, altered mental status, where the person can become delirious, confused, not know their name, not know where they are, do things that they wouldn't otherwise normally do, blurred vision, and vomiting. So as you can see, as these levels accumulate and build up more, they're extremely toxic and can lead to death if left untreated. So with that said, how do we treat too much ammonia in the body? Protein or amino acid catabolism leads to the buildup of ammonia. Ammonia in the liver is converted to urea. It goes through the urea cycle, and ultimately urea goes to the kidney where it's eliminated. So we've got a couple options when it comes to decreasing the level of ammonia in the body if you have some type of enzymatic deficiency leading to a toxic accumulation. The first option is to simply decrease the dietary protein intake. After all, if you don't have any protein to break down into ammonia, then you won't have toxic levels of ammonia accumulating in the body. So people who have some type of enzymatic deficiency are usually counseled by their physician very early in life to decrease their intake of protein, is to actually decrease the level of ammonia itself. If we knock out that ammonia, then the ammonia will not have to be converted to urea and eliminated because there simply will be less ammonia in the body. Now, how do we do that? There are two medications that are used. One is called lactulose, and the other is an antibiotic called rifaximin. Lactulose works by increasing the excretion of ammonia through the GI tract. So this will be in the form of diarrhea. Very often, people will have bowel movements where they're literally pooping out excess levels of ammonia. Rifaximin is an antibiotic that kills bacteria in the colon. And how does that work? Well, those bacteria usually produce ammonia. So if you destroy the bacteria in the colon, then less ammonia will be formed by those bacteria, which makes it easier to get ammonia levels down and out of the body. Those are the two main options when it comes to decreasing toxic levels of ammonia.
Now, the other thing I wanted to show you is in the Methionine Cycle. Remember, we talked about the Transulfuration process. And remember, this process makes glutathione, which helps detox the body. Now, you'll also see that the CBS gene is here. Now, the CBS gene, if you remember from a previous slide that I've posted on my site, the CBS gene is your mast cell activation disorder gene. That is the true telling of whether or not you have actual mast cell activation disorder. The CBS gene is behind that. Now, if you have the CBS mutation and it's not working properly, you're going to have higher levels of cysteine. If you remember from the CBS slide, taking NAC is usually not a good idea for us because it adds more cysteine to your system, which causes more reactions for mast cell patients. But it also means we're going to possibly have higher ammonia levels. Now, we know that ammonia attacks the brain, and NAC can actually preserve mitochondrial indices of functionality in the brain in hyperaminic mice. But most of us won't be able to tolerate NAC. The other thing you need to understand is taking acetaminophen is a bad idea and can further hurt your liver, especially during these times, slowing down methylation even slower, especially if you have these mutations and make excess ammonia. You may experience some of these symptoms we've been talking about. You've heard me say many times over, fast, 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 water diet, etc. This is part of the reason why we have to clear out these pathways and reset them. But in this instance, we have to drop our ammonia levels. This is not something you want to mess with. Fasting will raise your ammonia levels, but it's only temporary. In the long run, it will do you a lot of good. But just like homocysteine issues, exercise temporarily raises it, but after a week or so of constant exercise for a week, it will drop your overall homocysteine levels. The same thing happens here. So if you're having a bunch of neurosymptoms and your head and spine feel inflamed and your vision tanks, slurred speech, confusion, drop those ammonia levels. Do not add more protein to your body. But as always, each individual is a little bit different, so make the best choice for you. But I wanted to make sure that you understood this. If your methylation and your methylation is in the liver and you have mitochondrial damage, this will affect the urea cycle and your ability to detox that ammonia. You need to be aware of this. Even if it's not at a dangerous level, I can assure you it is still extremely uncomfortable. The good news is that if you heal your methylation, your liver, and your mitochondrial damage, you can heal this issue as well. Moving on to the GST gene. GST and the GSX. This is that gene that makes you sensitive to the things that you smell. Your antioxidant and free radical handling genes. It also controls your glutathione levels. It can cause headaches in seconds of smelling something like chemicals and make you sick. You tend to be a clean freak because you have to be. You develop gray hair early in age. It can also result in neurological disorders like tics, tremors, seizures, or problems with gait. And it can cause chronic conditions like asthma, IBD, autoimmune, diabetes, eczema, and psoriasis. Now you're probably wondering, what in Great Dane does this have anything to do with the urea cycle? So those smells that you smell, the chemicals that you smell, it is causing peroxynitrates. And if you have BHFR problems, it's going to make this problem worse. So those peroxynitrates are going to wind up causing neuronal damage and microglial activation, like we talked about earlier, and cause you a host of neurological symptoms. Now, this particular gene deals more with the BH4 and the NOS, and not so much the actual conversion in the urea cycle. And just keep in mind, this also damages your mitochondria, which hurts your methylation further. The SOD gene. This gene makes an antioxidant called superoxide dismutase, or SOD, which is responsible for neutralizing oxygen-free radicals. It's also necessary for healthy liver function, which you need for the urea cycle. The SOD enzyme requires manganese to function properly, and individuals with this gene will have an increased need for manganese. Now, GMOs, that's your soy, corn, canola oil, factory farmed meats, genetically modified grains, etc., all have something called glyphosate, which can chelate or bind up manganese and make it unusable in the body. Manganese deficiency with glyphosate exposure can cause male infertility due to decreased sperm motility, higher risk for ALS or Lou Gehrig's disease. SOD deficiency will negatively impact mitochondrial health, thus further impacting your methylation. Now, if you happen to have this gene, you will have multiple yellow or red SNPs in this area. Have your manganese levels drawn regularly, especially if there are any dietary changes. And have ferritin levels checked as well. If ferritin and manganese levels are low, the risk for cardiovascular diseases increases significantly. So make sure you avoid all GMOs no matter what. And for supplements, you'll need manganese, ferritin, multivitamins with antioxidants or EFAs, and don't forget hydrogen water. Hydrogen water can help with this. Mineral complex and a mitochondrial support. Now you're probably asking, what has this got to do again with the urea cycle? Well, it makes superoxides, which in turn creates neuronal damage and microglial activation, which means you're going to have more neurological conditions. So the GST and the SOD are indirectly part of the ammonia cleanup cycle, but they do play a major role in methylation health, mitochondrial health, and the neurological health that you experience with this cycle. So it's not specifically in the urea cycle, but it is within the ammonia cleanup cycle. So these are the genes that are in the ammonia cleanup cycle, also called the urea cycle. Now, you know what's going to happen next, right? I'm going to show you how the whole cycle works. So this whole cycle is really the ammonia cleanup or ammonia detox cycle, even though it gets named the urea cycle. Now, this all fits together and it plays a part. But this is where the actual urea cycle is in the ammonia cleanup or the ammonia detox cycle. And this part is using NOS to make arginine into nitric oxide, which also gets used in the mitochondria to make the urea cycle work. But this section of the cycle plays a big part of the neurological side of the house. Now keep in mind, these sections do all talk to each other. I just wanted to highlight the different aspects of the cycle for clarity. Alright, the step-by-step process of how this works. I'm going to do my best to make this as easy as possible, okay? This first step takes place in the muscles and the peripheral tissues. We're forming amino acids from those proteins like we've been talking about. The protein breakdown is taking place in the muscles. This breakdown of protein creates amino acids and it creates nitrogenous waste, which is highly toxic. Nitrogenous waste needs to be taken to the liver without ever going into the bloodstream. Now, the amino acids, which are nitrogenous waste, have ammonia ions. These are very bad for your brain and neurological health. So think of nitrogenous waste as ammonia ions. It's NH4+. That's nitrogen combined with 4 hydrogen atoms to make ammonia. If you look at the structure of an amino acid, you can see that it consists of nitrogen in the form of an amino group. Now, most of the protein breakdown occurs in the muscles and peripheral body, and the nitrogenous waste produced there must be taken to the liver. Because it is here in the liver, nitrogenous waste is converted into a less toxic water-soluble compound known as urea. Now, these nitrogen-containing amino groups cannot be released into the blood directly because it is free ammonia ions are highly toxic to our body. There must exist a way to transport nitrogenous waste to the liver without converting it into its ionic form that is free ammonia or ammonia, as that can lead to our brain, and that is very bad. Alright, so that is what takes place in this first step. Now let's take a look at the second step. This step is the process of carrying nitrogenous waste or ammonia so it can be taken to the liver. The first step is called transamination. It basically means transferring one toxic amino group to another. The point of this step is to be able to transport it without ammonia being released into the bloodstream. That's the whole point of this step. It's going to be transferring amino groups to other amino groups, making them bigger and bigger molecules. It's basically locking up that ammonia like a prison so it can't escape. It's going to transport the nitrogenous waste, which has ammonia ions, to alpha-ketoglutarate, and then to glutarate, and this is where your GAD gene comes in. Glutamate, where your GAD gene comes from, can carry excess nitrogenous waste and ammonia to the liver without releasing it into the bloodstream. That ammonia is locked up as long as your GAD gene and your glutamate is functioning correctly. Step number 2, which is called deamination, means it's liberating the ammonia from the glutamate. So basically that ammonia got released out on parole. It's not free in the bloodstream heading to your brain, but it's in the liver. So when the glutamate reaches the liver, the glutamate goes through that oxidative deamination to release that ammonia. It is the mitochondria in the liver that is the warden that actually sets the ammonia free. Now we're going to look at the illustration that goes with this. There are 2 steps that take place before the urea cycle begins. These steps are done in order to transport the nitrogenous waste to the liver without releasing it freely in the blood. The first step is called transamination, and the second is called the oxidative deamination. If you look at the word transamination, it is made up of 2 words, trans and amination. Trans, which basically means transfer of an amino group. Now what essentially happens is that amino group in an amino acid, which contains nitrogen, is taken from the amino acid and transferred to some other molecule. This molecule can be alanine or most commonly alpha-ketoglutarate. The receiving amino group gets converted to glutamate. This glutamate can freely circulate in the blood, carrying the excess nitrogenous waste with it without releasing it into circulation. So this is the first step that takes place before urea cycle begins, and this was known as the transamination. And as you can see in the reaction, We are transferring from an amino acid to another so that the excess nitrogenous waste of our body can be directly transferred to the liver without releasing it into the blood. When glutamate reaches the liver, it undergoes a second step. This is known as oxidative deamination. And as you can tell by the name, deamination, it basically means the removal of the amino group. So glutamate is the only amino acid that undergoes oxidative deamination to a significant extent. It liberates the free ammonia for urea synthesis. The ammonia that is liberated in the mitochondria of the liver by oxidative deamination is then used to synthesize urea by the cycle that is known as the Urea Cycle. The urea is far less toxic to our body than free ammonia and is a water-soluble compound, meaning it can be excreted in the kidneys in the form of urine. So now you know from where this ammonia is coming from and how it is being transported to the liver. Alright, now we're actually going to get into the actual part of the urea cycle. And don't worry, it'll come with a video. Okay, so ammonia combines with carbon dioxide. And remember, the urea cycle is made to get rid of ammonia and carbon dioxide, okay? But that ammonia and carbon dioxide gets turned into carbamol phosphate. This process uses 2 ATP, that's the energy your mitochondria kicks out, and it needs N-acetylglutamate. So again, we're using glutamate in the urea cycle. Now, carbamol phosphate and ornithine equals citrulline. And all we're doing is adding molecules together right here, okay? Ornithine picks up more ammonia from the glutamate and carbamol phosphate and turns it into citrulline. So you're basically gathering more of that ammonia and locking it up into bigger and bigger molecules. And that like I said, ornithine is picking up more ammonia from the glutamate and the carbamol phosphate, and together it's turning it into citrulline. This process of carbamol phosphate plus ornithine in order to make citrulline is called OTC, and this is where your OTC gene comes in. If this process doesn't work, this is a life-threatening and extremely toxic situation and can cause hyperammonemia and central nervous system damage. This is the most frequent urea cycle disorder, the OTC, ornithine transcarbamylase deficiency, or the OTCD. So if you have an OTC gene mutation, you're going to have issues with making this step of the urea cycle. Now, this step is happening inside the mitochondria. That's really important for you to remember. It happens inside the mitochondria, inside your liver, okay? Urea synthesis is a 5-step cyclic process with 5 distinct enzymes. The first 2 enzymes are present in the mitochondria, while the rest are present in the cytosol. In the first reaction of the urea cycle, 1 molecule of ammonia combines with 1 molecule of carbon dioxide, and this leads to the formation of a compound known as carbamol phosphate. This enzyme involved is carbamol phosphate synthase 1. And this reaction also uses 2 molecules of ATP. The phosphates, the carbamol phosphate is derived from ATP only. 2 molecules of ATP get converted into 2 molecules of ADP. Carbamol phosphate synthase 1, or the CPS1, is located in the mitochondria, so this reaction takes place in the mitochondria only. N-acetylglutamate is necessary for activation of this enzyme. Our next reaction also takes place in the mitochondria. The carbamol phosphate that we just synthesized from ammonia combines with 1 molecule of ornithine, and this leads to the formation of citrulline. Now let's understand what just happened in this reaction. Ornithine is also an amino acid, but it only has a role in the urea cycle. It is not part of any protein or any other biochemical cycle in the body. As you can see, the structure of ornithine, it already has 2 nitrogen-containing groups. In the urea cycle, the ornithine serves as a carrier, which picks up ammonia from the mitochondria by attaching carbomonophosphate with it, which leads to the formation of a bigger molecule, which now has 3 nitrogen-containing groups. And this is known as citrulline. The combination of ornithine with carbomonophosphate uses the enzyme ornithine transcarbamylase, also known as OTC. Again, you're going to remember what this enzyme does just by looking at its name. 1 molecule of inorganic phosphate is released in this reaction. So these are the first 2 reactions of the urea cycle, and these 2 reactions, the formation of carbomonophosphate and the combination of carbomonophosphate with ornithine, takes place in the mitochondria of the cells. So this part of the cycle happens in the mitochondria, utilizes the OTC, and utilizes the GAD. So you can see if your mitochondria is not working properly, it's going to hamper your urea cycle greatly. The OTC gene, as we talked about earlier, this is the one gene that can cause serious illness if it's not working properly. You have to take care of your liver and your mitochondria. If you are smoking, drinking, poor diet, etc., it can damage your liver, as well as acetaminophen and other NSAIDs, especially if you already know you have a methylation problem. Because remember, methylation occurs in the liver, and that affects gene expression. You do not want to cause an OTC deficiency because you're not taking care of your methylation cycles. Because this could require a liver transplant if you damage your liver bad enough, and it would cause hyperammonemic episodes. I cannot say that word. And the GAD, you need the glutamate in order to go to the mitochondria to make this process work. Now, in the last step of the urea cycle, we are going to leave the mitochondria and we're going to go to the cell cytoplasms that are inside of your liver. So it's the cells inside of your liver, the cytoplasm. Now bear with me a little bit here because this process doesn't exactly match the chart on the methylation cycles the way you think it does. This process is going to use more ATP, and we're just adding these molecules together until it breaks to urea or ornithine at the end of the cycle. Now, citrulline leaves the mitochondria to the cytoplasm of the cell. Citrulline goes through a few more reactions and produces urea and liberates more ornithine. Ornithine winds up getting recycled back into the mitochondria. Now, citrulline will add to aspartate, and this will wind up turning into argininosuccinate. Now, argininosuccinate is going to be broken down into either arginine or fumarate. Now, arginase breaks up arginine, and that is going to wind up resulting in either urea with the addition of a water molecule or ornithine. And then ornithine gets transported back to mitochondria, back with the carbomonophosphate to make more citrulline. And then the whole cycle repeats. Now I know this is confusing, but I still have that video to help make it a little less confusing. Alright, in the last section we talked about the process that takes place inside the mitochondria. And the end result was ammonia and CO2, which makes carbomonophosphate, which then makes ornithine, which then in turn makes citrulline. Well, now we're going to take the citrulline, and the citrulline is going to leave the mitochondria and go into the cytoplasm. The citrulline then leaves the mitochondria to enter the cytoplasm for the rest of the urea cycle. The citrulline undergoes a few more reactions and ultimately produces urea and liberates back the ornithine. This ornithine gets recycled back to enter to the mitochondria. So citrulline moves into the cytoplasm and gets condensed with one molecule of aspartate to form argininosuccinate. Aspartate is another amino acid, and this serves as a source of additional amino group that gets attached to the citrulline. This reaction is ATP dependent and is catalyzed by the enzyme argininosuccinate synthase. And in that reaction, the ATP is converted into AMP, and inorganic phosphate group gets released. So for now, we're just adding molecules, one after another. That has led to the formation of one big molecule. That is the argininosuccinate. We started with combining ammonia carbon dioxide, ATPs, which formed carbomonophosphate, which was then combined with ornithine to create citrulline. Was also added a molecule of aspartate to this, which led to the formation of this big molecule known as argininosuccinate. Now the next two reactions involve the systematic breakdown of argininosuccinate to finally release the urea. First, the argininosuccinate is broken down by the enzyme argininosuccinate lyase at this point here. This split leads to the formation of two molecules, arginine and fumarate. Now we have arginine that is produced, and it is broken down again, this time by the enzyme known as arginase. And this finally leads to the formation of two compounds, urea, and the second is the orthonine back in the mitochondria. One molecule of water is also used in this reaction. Now let's take a closer look as to what happened here. So we have the enzyme arginase that breaks up arginine here at this level. This part of the molecule of arginine combines with oxygen that is provided by the water molecule and leaves the formation of one molecule of urea. The two hydrogen atoms from the water molecule get attached here, and if you just pause this video for a few seconds and closely analyze, you will see that this leads to the formation of ornithine again. The ornithine then gets transported back into the mitochondria to receive another molecule of carbomonophosphate to form citrulline, and hence the cycle repeats again. The urea that is produced here is passed into the bloodstream, and since it's water-soluble molecule, it gets easily excreted in the urine. And so this is an overview of the topic of the urea cycle. I know that's a lot to digest, but it's out here for those of you who are good with science and want to know the inner workings of everything that happens. It's also the simplified version of what has been explained on the slides. I don't expect you to memorize this in any shape, form, or fashion. Just remember when it comes to ornithine and the ornithine transcarbamylase, that is your OTC gene, and you definitely need that one to be working to make this whole process work. The other thing I wanted to highlight was the arginine here. So you're using arginine in the urea cycle, right? But remember, we also use it somewhere else. So arginine gets broken down to arginase to make urea with the addition of water. It's also broken down into ornithine, which goes back into the mitochondria. And remember, arginine is also broken down by the NOS, and it's transformed into nitric oxide. And nitric oxide also gets used inside of the mitochondria and also helps with the brain and helps with the cardiovascular system. Because remember, with the BH4, you're not making peroxynitrate or superoxides, which are damaging to the brain. Now, if you have a disorder in the ammonia cleanup cycle or the urea cycle, if this cycle isn't working properly, there will be a higher accumulation of nitric oxide and ammonia buildup. Now, ammonia and arginine accumulation causes neurological symptoms like headaches, migraines, nerve issues, especially sensitive nervous system, stiffness, especially in the legs caused by abnormal tensing of the muscles, possible slower than normal growth, developmental delays, intellectual disability, seizures, tremors, which also can happen in BH4 cycle issues, difficulty with balance and coordination called ataxia. Arginine and citrulline are also involved in septic response. Now, immune responses contributes to arginine deficiency, and this is why it is so incredibly important for you to shut down your immune response via diet, lifestyle, and stress reduction. So remove those triggers, remove those allergens, every last one of them. Because if you don't, you're going to continue to mess with your mitochondria and all of your methylation cycles. Now, we've spoken about this in multiple sections of this video and previous videos that I have done in the cycle of illness. So it's extremely important that you do this. And no, it is not easy, but it's worth it in the end. Another thing I need to mention is high protein meals. Now we know high protein meals also causes BH4 depletion, which we need, and protein also turns into ammonia. So high protein meals, stress caused by illness, or fasting can cause ammonia to accumulate more quickly in the blood. This can and will cause a rapid increase of irritability and refusal to eat and possible vomiting. There's a chart here in the top right hand corner that has the different defects that can happen inside the urea cycle and the specific enzymes involved. I'm not going to get into great detail about that, but the table describes metabolic disorders related to each of the 5 urea cycle enzymes. All of the disorders always result in increased in blood ammonia, hyperammonemia, which leads to toxicity. Another urea cycle byproduct accumulates as well, depending on the involved enzyme deficiency. So, in order to heal any part of this due to methylation issues, diet and lifestyle choices need to be made. And you must heal the mitochondria, the liver, and the methylation to fix any of this. And remember, healing methylation helps affect the way your genes are expressed. So you can turn them up or turn them down. And we want to make sure that our methylation is top notch so that we don't get sick. The methylation can help control those genetic expressions. So the ammonia detox cycle, which is most commonly referred to as the urea cycle, but it's really all about detoxing your ammonia from your body. So this cycle is really comprised of several sections. There's the neurological side of the house where NOS breaks down arginine into nitric oxide. With the help of BH4, it helps detox out the ammonia and prevents neurological issues or brain damage or diseases. Also utilizes the GAD gene and also helps with the neurotransmitters in the BH4 cycle. Then you have the urea cycle, which is comprised of 2 parts. The part inside the mitochondria in the liver, and it utilizes the OTC gene and the GAD gene in order for it to work. And let's not forget the nitric oxide that the mitochondria needs for its basic functions, the cellular respiration, so that the mitochondria can even think about trying to do the urea cycle. And then there's the second part of the urea cycle that takes place in the cytosol of the cells within the liver. Now these little cycles within the whole all do work together, and if any part of these sections isn't working properly, you're going to get ammonia issues and neurological issues. And as we've shown so far throughout this video, if this cycle isn't working properly, just like the other methylation cycles, it's going to affect your mitochondria further, and it's also going to affect all of your methylation cycles. So you need to understand that keeping these cycles in balance is imperative. So how do we fix methylation overall? Now, getting a full genetic panel done is the fastest and easiest way to root out what genes and SNP mutations you may have to give you a complete picture of your health and methylation cycles, as well as your natural detox capabilities. However, by utilizing this video, the genes and SNP slides I've created, and looking at your moods, your symptoms, the foods you can and cannot eat, meds and supplements you can and cannot tolerate, all of that is telling you exactly where in the methylation cycles you're having issues, whether it be an excess or a deficiency. It can also tell you, especially with something like oxalates or antioxidant foods, for example, that you're having mitochondrial issues as well. Depending on what gene testing company you go through, just make sure they take a look at methylation genes. Here are a few options here. There's also a company called Genome It All. I've also used them and it's really good. But you can get what you need from 23andMe, and 23andMe usually goes on sale around Christmas and is cheaper. If you have a test done and your genes aren't all listed out for you, you're going to use the raw data to find out what they are, and this is what the raw data looks like. This site is by Genetic Genie, and it's actually really good. You're going to input your raw data twice, because part of it is for methylation results and the other part is for the detox panel. These are both very important for you to understand so that you know what's going on in your body. Now, the methylation panel is essentially going to spit out looking like this. You're going to want to look for the red and the yellow. The red means you received a mutation or a variant from both parents. And if it doesn't have color, look for the plus plus. If it's yellow or you have the plus minus, that means it's heterozygous, which means you received one mutation from one parent. With a homogeneous mutation, meaning you got it from both parents, that gene is going to express itself a lot louder than, say, someone who only got one copy. However, by balancing your methylation cycles, you can actually improve its expression a lot better. Now, the same thing will happen for the detox profile. And the detox profile is basically telling you the genes that you have that may be hampered, that isn't allowing your body to detox as properly as it should be. And the same rules apply. You're going to look for the homogeneous and the heterozygous. All of the genes in methylation and detox profile are going to be listed out in slides, as well as many extras that are popular, detailing what they do, their symptoms, what other genes they talk to, testing, and how to help heal it through diet or supplement. These slides will be posted after the video once I figure out how to post them on my social media platforms and blog. I made them specifically so that you can help figure out what genes you may or may not have on your own based on the symptoms, etc. Now, if you're thinking about treating your gene mutations with more meds or all of these different kinds of supplements, think again. Doing so without understanding how these genes are interacting with each other, especially within methylation cycles and mitochondrial damage, this could have very harmful consequences. It's important to understand that, like drugs, supplements are just as or even more potent than drugs. This also means they can affect other aspects of the body, its systems or organs, just like drugs. So it's very important to address healing these cycles with diet. Exercise, even something as simple as Qigong or Tai Chi, is extremely beneficial, and lifestyle changes like getting enough sleep, reducing stress and detoxing, etc., is very important. Now, one of the important supplements a lot of people take, especially in the mast cell community, is the quercetin. Now, it's recommended by everybody, but for some people it is extremely dangerous. And we did discuss this earlier in this video, and I have posted it on my site, the blog, and in other histamine sites as well. So we're working on healing the biochemical processes, driving all the methylation cycles, versus fixing the genes with supplements. With that being said, you may need a couple to help you get there. It's important to understand how these cycles work and where you're the weakest or have the greatest excesses in order to heal. But I must make this clear. Taking a supplement for everything will just further burden your liver, and you risk doing more harm than good when it comes to toxifying the liver, and it could also affect the kidneys by burning them out. Not to mention the other effects it can have on your other systems of the body. Even though you can't change your genes, working with the enzymes they code for can help adjust your body and brain's chemistry and adjust the volume of how these genes are expressing themselves. Genotype is the genes you were given, and phenotype is how they express themselves that gives you your diagnoses. The other thing I have to mention is this. You do not have to have a bunch of SNPs or genetic mutations in order for these methylation cycles to be off balance and affecting your health or moods. Stress, not enough sleep, poor diet, overexerting yourself regularly, your environment can all contribute. But getting the word out to doctors and finding labs to test the different levels can be a big help in combating mental and chronic illness, mast cells, and autoimmune diseases. Now, there are several protocols out there for methylation, and they could definitely work for you. But here's the catch behind all of this. It has to be hand-tailored specifically to you, based on all your genetic mutations and how your methylation cycles are working. There are no specific diets to follow. There are no, and I'm using air quotes here, give me a checklist of supplements for me to follow, end of air quotes, and you keep doing what you've been doing that is making you worse and your health worse. Those don't exist, and here's why they don't exist. because each person's individual methylation is going to be different. You have to make the call as to what's best for you. However, many come looking for help, and they're doing their best to accommodate their health needs, but they're still adding too much to their body. The foods, the supplements, etc. can still cause immune responses, and the body reacts, raising cortisol, and the body goes into stress. And if you remember in the inflammation video, you're going to start gaining weight because the body can't handle it anymore, and it's going to make that harmful white adipose tissue, that's your belly fat, and it just stores all the toxins inside of it because your body just can no longer process it. And it's a last-ditch effort to try and protect you. And like we talked about in the inflammation video, things like candida, SIBO, mold exposures, etc., all of those things boil down to an underlying methylation issue, or they cause it. Most health issues boil down to a metabolic disorder, and these fall under methylation, because methylation controls all those biochemical responses that are taking place in your body. Now, sure, there's all these little other factors that play into it. However, the larger, greater picture behind it all is methylation, your histamine, your inflammation, and your mitochondria, as well as your gut health, which makes up your immune system, and all of that plays a factor. There is a much bigger picture at play here. To throw it all off, all you need is a catalyst. And one is a viral infection, and I'm going to tell you right now, that scourge that has been plaguing us for the last 3 or 4 years is a huge catalyst to throw this entire cycle off. The histamine, inflammation, mitochondria, methylation, your immune system, all of it. And it alters your DNA expression, all of it. Now, I can't say what that is because the social media gods will freak out if I do, but you all know what I'm talking about. There's also medications, exposures to chemical toxins, environmental pollution, exposure to allergens, smoking, drinking, genetic mutations, improper diet like malnutrition, leaky gut, dysbiosis, microbiome imbalances. All of that throws this entire thing off. Now, don't even get me started on stress. Stress alone can shut down your methylation cycles hardcore. So you need to be able to manage your stress, because the more stress you're under, whether it's physical or emotional, it's going to shut down those methylation cycles. Not to mention, it's going to suppress renal function and digestion. And if you remember right, we talked about in a previous video those mirror neurons. So when it comes to stress, it doesn't matter what you're reading, what you're watching, or what you're thinking. To those mirror neurons, it is happening in real life and your body is going to react. That is what the mirror neurons do. And if your nervous system is already ramped up, it's going to make those reactions worse. And I am going to teach you how to fix all of this. Now, the MTHFR protocols given by Dr. Lynch and Dr. Dan Purser can be beneficial, but remember, you need to tailor it to you. You need to keep in mind everything we've taught you in this methylation video, and to also remember about fixing the processes versus fixing it with more supplements. And if you're not careful and you don't fully understand how these cycles work, you're going to wind up getting yourself into a whole vicious cycle that is extremely difficult to get out of. Now, I'm still going to teach you how to do it, but I'm just letting you know that the process isn't always pleasant if you're in a really bad vicious cycle. Now, you can see the close-up of these slides in the beginning of the video and also in the slides that I'll be posting after I post the video. So this is an older slide earlier in the process of me going through everything. So it's since been updated, but this is an old slide. And I wanted to show you that no matter what condition, symptom you have, it all winds up coming back to the cycle of illness. Everything you can think of comes back to the cycle of illness. And I tried to illustrate this in these two slides. Now, in each video, I got much further in depth with the different illnesses and how they're affected, and within methylation, what illnesses come from what sections, etc. But if you're suffering from this and you want to fix your methylation, you can't just fix methylation. You have to fix everything. You have to fix your histamine issues, your inflammation issues, mitochondrial damage, your leaky gut if you have one, or your gut microbiome, and your methylation cycles. Now, you can separate it a little bit to ease into it, but at the end of the day, you have to fix every single one of them to regain your health. Now, you can't replace what's gone or what's missing, but you can fix what's broken and heal it. And at the very least, improve your daily quality of life. All right, your action plan. Now, if you're humming along in life and everything is pretty much going peachy keen for you, but you just have a few hiccups, now you can use these particular nutrients in order to help you. There are 7 specific nutrients that can help the methylation cycles achieve optimal performance, even if you have genetic mutations that slow down the methylation cycles. 5 MTHF, that's your active folate, but remember to get your folate and folic acid levels checked first. And if you feel worse after taking it, stop. That means you have an overabundance of folate in your system already, and you need it to clear your system. But the best way to get the 5 MTHF is by eating a salad of dark leafy greens at least once a day. Methyl B12. Unless you have the COMT gene or nerve issues, then you want the adenosyl hydroxyl B12. And the best way to get this diet-wise is to eat a healthy, pasture-raised, organic, fresh, and reasonably portioned protein along with a dark green leafy salad. Vitamin B6. And good sources of B6 are cooked lean beef, beans, lean pork, salmon, tuna, apricots, spinach, prunes, sunflower seeds, and banana. Just look online for good sources of B6. Legumes are also a good source of B6, but you need to be careful with them because they can build up to toxic levels in your body if your methylation cycles are not working properly, and many folks cannot handle legumes. Vitamin B2. This includes your leafy greens, mushrooms, seaweed, pastured eggs, broccoli, green beans, bell peppers, winter squash, Brussels sprouts, sardines, salmon, sweet potatoes, and almonds, along with a few other items. And B2 is beneficial for energy production, promotes healthy skin, eyes, nerves, and muscles, which we need, and maintains a healthy liver. And the importance behind this is because it maintains a healthy liver. This is your riboflavin. It helps with your methylation, and methylation takes place in the liver. That is why it is important for you to have healthy levels of B2. And the next one is betaine. Good sources of betaine are wheat bran, but make sure you have no allergies to wheat, and 2, make sure it is not GMO, so it has to be organic. Quinoa, beets, spinach, amaranth grain, rye grain, kamut wheat, bulgur grain, sweet potatoes, turkey breast, veal, and beef. However, there is a disclaimer with this one. Do not take TMG, otherwise known as betaine, and TMG is that trimethylglycine, if you have the BHMT genetic mutation. This remethylation pathway number 2 is going to be very sluggish, so do not take TMG, otherwise known as betaine. And remember, TMG stands for trimethylglycine, so it's also giving you extra methyl. For some folks, that will give them too much methyl and cause symptoms. So with this gene mutation, just watch your foods or sups with this one. You'll generally want to look for mood changes, like, the mood just totally takes a left turn and swings one direction or another. You'll want to look for that, or if you start to not feel so well. Seeing that meat and those other foods that we just mentioned are good sources of betaine. If this pathway is pretty blocked, you're going to feel it more. So just keep in mind and pay attention to what you're eating. And then there's vitamin D. And many of us have vitamin D deficiencies. Make sure your number is around 100. It makes a huge difference in how your methylation cycles work and how you feel every day. And you need to be taking one if you live somewhere in a winter climate. If you do live in a winter climate or have the VDR gene mutation, you're going to want to keep monitoring those levels. Now, depending on what number you have, you can take a low dose vitamin D all the way up to approximately 15,000 IUs per day. The general rule of thumb is not to go over 15,000. Your body can't process it and it basically becomes waste. There are 50,000 IU doses out there. I don't recommend that unless specifically under doctor care for a specific reason. Vitamin K is also extremely important, and it helps your body's ability to absorb vitamin D. So if your vitamin K levels are extremely low, it's going to be harder for your body to absorb vitamin D. If you're on blood thinners like Coumadin or warfarin, you obviously can't take vitamin K to keep your INR stable. However, you can get nutritious versions of vitamin K, and you can even up them. You just have to adjust your meds, and the docs and the Coumadin clinics can help you with that. It will take about 30 to 60 days for your numbers to climb, so it's a slow, gradual climb. And it's good to try to split it up throughout the day and try not to take it all at once if your numbers are really low. And don't forget the importance of sunlight. Sunlight is also extremely important for your vitamin D levels. Now, there's only a few foods out there that are rich in vitamin D naturally. One of them is mushrooms. And a cool trick about this one is if you leave mushrooms out in the sun after you bring them home, they actually absorb more vitamin D, which means you get more vitamin D out of your mushrooms. Eggs is a good source of vitamin D. Whole milk, even raw milk, but just be careful of raw milk and make sure you're getting it from a reputable farmer. Fatty fish like salmon, herring, cod, sole, and cod liver oil. And some dairy like cheese, cheddar in particular. Yogurt, but make sure it's sugar-free yogurt, and also butter. Now there are cereals, etc. out there that are fortified with vitamin D, but here's the problem. It's usually processed foods, has lots of gluten or GMOs, and it has way too much sugar. And even though that's what makes it taste so good, that's exactly the type of thing we have to stay away from. It is not good for our methylation cycles, and it's not good for our overall health, period. Now, I get a lot of questions pertaining to what's the best multivitamin. Mitochondrial Restore, or MitoPQQ, and Neuronutrients are the best I found on the market to help support methylation and mitochondria. These ingredients inside of these all work together and complement each other and complement mitochondria and methylation. I am personally more partial to the Mitochondrial Store versus the MitoPQQ, but that is just me. Mitochondrial Restore, however, can get sold out and be harder to track down at times. So these make a good multivitamin when you put them together, one of the mitochondrial and the neuronutrients together. If you're juicing, though, you should not need these. But if you're looking for a good multivitamin, I recommend this brand and these two in particular. But these really help with methylation and the nutrients to keep it healthy. Just make sure before taking vitamins, supplements, etc., you have an idea of what your excesses and your deficiencies are. The last thing you want to do is make these problems worse. This is why I'm always talking about juicing and the benefits of juicing. And we will get into that in a few minutes. And P.S. I do not get discounts or endorsements or anything for recommending these. This is just what I have personally found that I feel is the best product out there for methylation and mitochondrial issues. This is just my 2 cents worth, but as always, use discernment because each of us are different. Okay, because methylation cycles get far enough off, we can wind up with either deficiencies or toxicities. And here is a chart for vitamin toxicity symptoms. So if you have too much vitamin D, expect more abdominal cramps, nausea, vomiting, calcium crystal deposits that will affect the liver, kidney, lungs, and calcium salts are supposedly irreversible unless I find a way. However, I do not know. Vitamin A, water in the brain, vomiting, tiredness, constipation, bone pain, brittle nails, hair loss, and birth defects. Now, vitamin B6, this is a popular one, especially with the American Standard Diet. You can wind up with mobility issues such as tingling and numbness in the hands and feet, trouble walking, trouble grasping small objects. Now, it says this is difficult to reverse, but if you do the juicing, you can most definitely reverse this. So, vitamin B6 through fasting and juicing, you can reverse this. This is where the hydroxyladenylyl B12 can come in handy because it helps with the myelin sheathing and with nerve damage, but just make sure you don't have too much B12. Vitamin C, if you have too much vitamin C, kidney and gallbladder stones in those prone, for those of you who are oxalate sensitive especially, but normally it just makes really expensive urine, which means you're just peeing it out. Now, folate, if there's too much folate in the body, this is another big popular one. I can't say this word right now. Pernicious anemia and kidney damage. Too much folate in the body also can cause damage to organs, cancers, especially colon type cancers. So this is not an all-inclusive chart, but this gives you a general idea. If there's too much vitamin B12, you could have diarrhea, swelling, and blood clot in the legs. If you have the MTHFR, it also increases your chance in blood clots. And also the swelling in the legs can also come from just eating the wrong foods and drinks, especially carbonated sodas. So anything junk food can trigger this if you're extremely sensitive and methylation isn't working properly, especially if you're suffering with inflammation and a significant amount of mitochondrial damage. Too much vitamin K could result in anemia in adults and possibly even death in infants. Niacin, if there's too much niacin in your system, flushed skin, nausea, diarrhea, and liver damage. So for those of you who flush really bad when you get niacin, you might want to get your levels checked medically to make sure you're not giving yourself too much. Vitamin E, if you have too much vitamin E, you could wind up with headaches, tiredness, double vision, diarrhea, and vitamin A, D, and K deficiency. So toxicities can also rob you of other cofactors, enzymes, and vitamins and minerals for your body to run properly. So like we've been saying, you got to stay in the Goldilocks zone, not too much and not too little. There are also very specific actions you need to take in order to help your methylation cycles work and in order to help them to heal. You need to switch to a healthy, organic, whole foods diet. Depending on what condition or diagnosis you may have received, as well as the status of your methylation cycles, this will dictate the majority of your diet. The methylation cycles will tell you what foods you can and cannot tolerate, as well as how much of a particular food group you can safely have. Just keep in mind that if your methylation cycles are out of balance, you can heal them and bring them back into balance. Doing so will give you more food options so you can have a more balanced diet. So with methylation issues, the best way to eat is a good-sized portion of leafy greens and some protein with it. These pictures are the perfect representation of what you want to aim for. You're also going to want to add a starch or a carbohydrate that is whole foods as well. Now keep in mind this is all based upon what you can tolerate, but this is the general rule of thumb. You have to get away from packaged or processed gluten, corn, soy, GMO type foods, sugar, caffeine, etc. And you want to stay around the outside edges of the aisles at the grocery store, where all the fresh produce, organic products, and fresh meats are kept. And stay away from factory farmed fish or meat. You've got to get away from the standard American diet. Sure, it tastes good, but it's absolutely terrible for us, terrible for your methylation cycles, especially if you already have pre-existing methylation issues. If you have mast cells, autoimmune, or chronic illness, that generally means you have a methylation issue. This food pyramid is not your friend. There are serious issues with the current models of our food pyramid. For one, grains is what it says you want the most of. That is actually terrible advice. They're all pro-inflammatory, especially with the rise of GMOs. Soy, corn, and wheat are almost all GMO. And we have talked about how bad GMOs are in the inflammation video. There are still some grains out there that are still GMO free, but soy is all GMO. and GMO foods are taking over the food chain. These are damaging to the body, and I illustrated this in the inflammation video. If you're looking for gluten-free products, keep in mind that much of that has corn or other grains that are also GMO. So you basically want to eat that extremely rarely. Corn is pro-inflammatory, and we want to avoid pro-inflammatory foods. You want a diet rich in whole foods, fruits, and vegetables, with some meat and dairy products, and completely avoid the junk food altogether. It's got too much preservatives, chemicals, food colorings, fillers, additives, etc. It's absolutely horrible for us, for inflammation, for our mitochondria, and for our methylation. We have to go back to the old ways of farming, local farms, keep it local as much as possible, and use sustainable methods to protect our lands and waters, and do things like we did in the old days, backyard gardens, etc. And cow farts are not going to destroy the planet. They actually help fertilize the land in a healthy, sustainable way, as well as rotating crop fields. It's the chemicals and pollution, as well as runoff or venting from plants, that do the most harm. We also need to fix the air we breathe, and part of that is the chemicals and the pollution. In the mass cell world, we say we're the coal miner's canary. We will feel and know something is wrong long before the rest of the population. Those with significant methylation issues will also feel it. All the things I've mentioned here will help people get healthier and stop the rise in the epidemic of chronic illness. And the one thing we know about trying to fix our health is that we have to go back to the old ways, the way our great-grandparents did things before the Industrial Revolution, the boom in plastics, chemicals, convenient meals, etc. Now don't get me wrong, there's been some great advancements, but we have to keep it clean living, clean eating, clean breathing, sustainable, etc. All of these things help fix methylation and also helps fix your health issues. So you want to eat approximately 9 cups of dark leafy greens a day, and I'm not joking. This is partly why juicing is so important for the healing path. You want a base of approximately 3 cups dark leafy greens, 3 cups of sulfur leafy greens like kale and spinach, and when you can eat veggies, or if you currently can eat veggies, you want 3 cups of brightly colored veggies of your choosing. You're going to want to eat a diet rich with sulfur foods. This will help mitochondria to survive and help boost your glutathione levels. It helps improve methylation with nutrition while also healing your mitochondria, which in turn also helps your methylation. The sulfur foods will help support the brain, the mitochondria, and toxin removal because it helps boost glutathione levels as well. The liver and kidney need sulfur foods in order to remove the toxins from the bloodstream. One of the most nutritious, but not necessarily the greatest tasting, is kale, one of the most nutritious leafy greens chucked with sulfur. If you can tolerate it, the cabbage family like broccoli, cauliflower, Brussels sprouts, kohlrabi, collards, kale, rutabaga, and turnips are also rich with sulfur, as is garlic and onion. And just keep in mind when it comes to garlic and onion, if you have a lot of neuroinflammation, you may need to cut those out temporarily, or any disease that may affect the brain can also be triggered by garlic and onion. So just keep that in mind when you're adding garlic and onion. One thing to point out, if you're sensitive to sulfur foods, make sure you're getting enough molybdenum. This helps you to tolerate sulfur foods. And the neuronutrients without iron actually has molybdenum in it. You need fresh, organic, grass-fed meat, nothing else. If you are what you eat, and they ate a diet steady in GMO corn, antibiotics, etc., you are eating it too. If their bodies are damaged from the GMOs, like we showed you in the inflammation video, so can yours from eating it. Grass-fed only, or it'll affect your cells, your methylation, and your health. And stay away from those factory farms. That's why you want organic grass-fed meat. It is extremely important, and that is why I am repeating it again. You also want fresh, grass-fed, organic organ meat. If it is not organic, do not eat it. That is where the toxins go and store in the organ meat, especially somewhere like the liver, because the whole purpose of the liver is to help you to detox, and so is the kidney as well as some of the other organs. So for healing, you do need this type of meat, but you can use ancestral supplements. It's organic, it's grass-fed. The kidney and liver both help with DAO, which is a histamine neutralizer, and it helps within the gut. And you need to understand that any DAO supplement that you take will only help in the gut. The liver capsules also help replace the vitamin A deficiency that mast cell patients, autoimmune patients, and chronically ill patients tend to suffer from. Between the liver, the kidney, and the carrots and the juices that we'll talk about here shortly will greatly help in aiding the vitamin A deficiency and reversing it. And for mast cell patients, one of the main deficiencies for mast cell patients is vitamin A. Now, if you can't tolerate these initially, that's okay. This is a sign, though, that your whole cycle is out of whack, which means you've got some serious healing to do. You most likely have a damaged gut lining, like leaky gut or something equivalent, or some type of dysbiosis, like candida, SIBO, etc. And this can raise your histamine levels too high. So your gut is going to need some healing. Or you can take DAO with it. If you have the DAO mutation, you are definitely going to need to be taking DAO with every single meal. You're going to take it approximately 15 minutes or at the same time as you sit down to eat. And if you still cannot tolerate DAO, that tells me your gut is extremely damaged and you need to fast and heal your gut lining. It also means that your methylation has slowed drastically and it cannot clear histamine efficiently. You could have the DAO or SHMT mutation, both of which help clear histamine, but this is also being further impacted by low methylation. And that means you also have damaged mitochondria because that's what feeds your methylation cycles to begin with. So what do? You fast and then you rebuild. Rebuild the gut, the mito, and heal the pathways in methylation, thus helping genetic expression, which we will be discussing how to do this in a few moments. You need to reduce stress. Stress can be defined as a state of worry or mental tension caused by a difficult situation. Stress is a natural human response that prompts us to address challenges and threats in our lives. Everyone experiences stress to some degree. You've got to take a look at your life, your lifestyle, your habits, and reduce as much stress from you that you can. You can't avoid all stress. It's basically unavoidable. However, you can reduce the stress that you do have control over. You can also control how you respond to stress. Personal and emotional stress can be created by how we interpret our situation. Sometimes we have to change how we see things. Most of the time, it is an illusion, or rather a representation of our inner world and inner turmoil, whether it's our fears, our disappointments, etc. This is where the practice of discernment can be very helpful. And discernment is basically just the ability to see through the illusion, to be able to perceive, understand. And it says to judge things clearly, but to perceive it without judgment. Just observe it as it is, especially the things that are not obvious or straightforward. So you can see through the illusion and see it for what it truly is. And that is discernment. A good example of discernment is when we're dealing with other people. When it comes to other people, there are egos involved. We are seeing past their ego and seeing them for the person that they really truly are, past the disappointments, the hurts, the fears, the injuries, etc. Because a lot of times people say and do things. We project things based on past experiences that created our perceptions to begin with. Being able to see that in itself is discernment. And believe it or not, using discernment helps a great deal with helping us to cut down our stresses because we can see through the BS. Everything happens for a reason. Whether or not you choose to see the lesson or the blessings is up to you. And the only constant in this world, this universe, and in the cosmos is the fact that nothing is permanent. It is forever changing. Hence the saying, this too shall pass. So take solace in knowing it won't always be like this. It's just an opportunity to help us grow. It's not happening to us, it's happening for us. And how you respond to it is what's important. And you'd be surprised how much the universe mirrors our inner turmoil or our inner peace. But that's a whole quantum mechanics, quantum entanglement, science dealy that we won't get into here. But just be aware of it, and who knows, you might actually start noticing it yourself. So controlling how we respond to stress is not always easy, but with practice, you'd be surprised how resilient you can become. Meditation practice can be a valuable tool here for managing stress and being more resilient. It also helps calm our nervous system, recenters us, and helps us to cope. We've spoken previously how stress can single-handedly make methylation cycles come to a screeching halt. But it doesn't just affect your methylation cycles. It also affects your cells, your mitochondria, your immune system by shutting it down, as well as the nervous system and even your gut microbiome. And just as a side note, stress can also shut down your digestive system. So stress is a major factor for your health and can be the vast majority of doctor visits. Keep in mind, your genetic expression is directly related to the genes you have inherited, the environment and lifestyle you live in, which will in turn directly impact your physical and mental health and your genetic phenotype, which is how it makes you you, the wonderful you that you are, and all the challenges and insights and love that you are. And seeing that stress can arrest your methylation and methylation controls your genetic expression, it's no wonder why stress leads to such suffering. So take stock of or inventory of your life. Slow down, keep calm, be positive, take it easy. Unplug, please, we need to unplug in this day and age and enjoy your life. It's not selfish for you to take care of you. Make sure you have fun, breathe, relax, go outside and get plenty of sun, and don't forget to meditate. It'll help you to sleep better, help bring down your blood pressure if you have high blood pressure as a result of stress, improve digestion, reduce muscle tension, and help with regulating the immune system. So make sure you're taking good care of yourself and reduce some of those stressors you can control. It's important for your health and well-being, as well as your methylation. Get plenty of sunshine, because sunshine helps methylation. So make sure you're spending enough time outside every day. We've already discussed how important vitamin D is to your methylation. Methylation is in the liver, and vitamin D from the sun goes to the liver, which then goes through the circulation to target tissues needing it. It helps the liver, the kidney, the brain, the arteries, the nerves, the muscles, and helps with detoxing the body. It is critical for the breakdown of dopamine and preventing an overabundance of stress hormones like epinephrine, norepinephrine, and adrenaline. It is critical for maintaining proper balance of the neurotransmitters, various mental health aspects like depression, seasonal affectiveness disorder, aggression, ADD, ADHD, bipolar, as well as diseases like cancer, Parkinson's, dementia, etc. Anything that basically affects neurotransmitters, or neurotransmitters affect it, as well as your nerves. It's also critical in aiding the BH4 cycle and the Urea Cycle so that the body can appropriately detox. Not to mention, it helps your cells, your mitochondria, the energy you feel every day, and your muscle and motor function. We've talked about vitamin D extensively in this video, and you can find more information in the genes and SNP slides I've created to accompany this video. Exercise. Exercise is another wonderful way to help improve your methylation. But you need to make sure that you have a daily, consistent exercise routine. Key emphasis on daily and consistent. And it needs to not be too strenuous. The idea is to detox, reset, and heal the body. Strenuous exercise or overexerting yourself is a stress on the body, and it can raise those stress hormones. especially if you have the COMT gene mutations and you're low on vitamin D. It can also make methylation weaknesses worse, put further strain on inflammation, the cells, mitochondria, your nervous system, and cause more damage overall. The idea is to find something in the middle ground, not too much and not too little, what I've been referring to throughout the videos as the Goldilocks effect. However, for those detoxing and having a really hard time, extremely gentle exercise is the best and all you really need. But it has to be daily and it has to be consistent. It will initially raise homocysteine levels. There will also be an increase in ammonia levels, especially if you're fasting or detoxing at the same time. However, the consistency is what lowers that homocysteine and ammonia levels overall in the long run. This is a good thing, and it'll take a week or two before you start really noticing the difference when it comes to homocysteine levels. It'll be tough for some folks at first, but stick with it because it will come down. From personal experience, it usually takes a week or two, and if you just start with something slow and gradual, by the end of the first week or two, you're going to start noticing a big difference. Even gentle exercises help to detox the body and clear out the toxins and help with the body to heal. We all know a sedentary lifestyle is bad for your health, but even folks with significant POTS, which is postural orthostatic tachycardia syndrome, can still get some exercise and it can help in the long run. For those unfamiliar with POTS, you can pause the video here to read the different types of POTS. But the main takeaway here is that if you have it, then you generally feel better sitting or laying down. We'll get into the different types of exercises available to you, but even those with POTS still have exercises available to them even in bed. This exercise will help it from getting worse and prevent toxin buildup and damage to the body due to inactivity. You generally want to stick with something simple like walking, stretching exercises, Tai Chi, Qigong, and yoga. Each of these have beneficial benefits to your overall health. It helps you to move and also helps calm and clear the mind like a meditation. This helps heal the nervous system, improve flexibility, strengthen muscles and balance, and helps your body detox and heal. The 3 types of exercise I recommend and teach those with chronic illness is yoga, Tai Chi, and Qigong. These gentle forms of exercise can help maintain strength, flexibility, and balance, and could be the perfect activity for the rest of your life. It also helps create a heart and mind-based type meditation involving breath work. In order to heal, you do need this heart and mind connection. Tai Chi and Qigong both follow the philosophy of Qi and the yin and the yang. Qi is an energy force thought to flow through the body. Tai Chi and Qigong is said to unblock and encourage the proper flow of Qi. Tai Chi is slower in mastering this, whereas Qigong is actually the art of effortless power, which is cultivating a body's energy. This method is thought to work much faster and help give you energy. I always have folks start with Qigong first in case Tai Chi is too much for them. Plus, Qigong can help get the energy moving in your body if you've been sick or run down. And I'm not just talking about Qi, I'm also helping with your body's natural energy that you feel on a daily basis. Tai Chi and Qigong, which are opposing elements thought to make up the universe that need to be kept in harmony. Some may call this as duality. Tai Chi and Qigong is said to promote this balance. In science, we know it's fact that the universe, the cosmos, that nature hates a vacuum. Everything has to be kept in perpetual balance, and your body is the same way. So, Tai Chi and Qigong, there are similarities and differences. The similarities are that it improves blood pressure and reduces cardiovascular risk factors. It improves brain health and cognition. It improves posture and balance and prevents falls. Improves strength and mobility, improves sleep quality and mood, improves joint health and reduces pain in people with osteoarthritis, supports the immune system to work effectively, and prevents illness and has a meditative quality. It also helps people heal for those who have had injuries or have chronic illness. Now, the differences between the two: Tai Chi is fluid, slow motion. It is generally done in a standing motion with a few different exceptions. It requires more energy and stamina, and it takes time to learn the series of movements, and it can be more difficult. Now, Qigong, on the other hand, is stationary, repetitive, and a much slower motion. It can be done standing, sitting, or in a lying position. And this can be done with people with limited energy, and simple movements are much easier to learn. Tai Chi is often described as meditation in motion, but it might as well be called medication in motion. A growing body of carefully conducted research is building a compelling case for Tai Chi as an adjunct to standard medical treatment for the prevention and rehabilitation of many conditions commonly associated with age, injuries, or chronic illness. An adjunct therapy is one that is used together with primary medical treatments, either to address a disease itself or its primary symptoms, or more generally to improve a patient's functioning and quality of life. Conventional medical science now knows that Tai Chi masters have always known for centuries that regular practice leads to more vigor and flexibility, better balance, and mobility in a sense of well-being. Cutting-edge research from Harvard Medical School also supports the long-standing claims that Tai Chi has beneficial impact on the health and heart, bones, nerves, and muscles, immune system, and the mind. Qigong uses posture, movement, breathing, sound, and other elements to help the individual improve their mental, physical, and spiritual well-being. It uses breath to move energy and invokes a meditative state. In fact, it works really well with yoga. You wouldn't think it does, but it really does. It has both psychological and physical components, and it does involve the regulation of your mind, your breath, and your movement and your posture. In most forms of Qigong, the breath is really slow, long, and deep. And breath patterns may switch from abdominal breathing to combined breathing with speech sounds. There is another aspect to Qigong, and that is called the Qigong tapping methods. When physical or emotional stress blocks the flow of Qi, practice such as acupuncture, acupressure, and Qigong tapping help release it. The vibration moves Qi so you don't hold on to things. As the vibration goes through your body, it opens channels and joints and releases tension. However, we want to avoid the tapping method, especially initially. This may be something you can do down the road, but initially you want to avoid it altogether. The tapping method follows the energy lines in the body. Those lines also fall in line with the lymph nodes, your nervous system, etc. Tapping, when the body is damaged, detoxing, or healing, can raise your pain levels dramatically. I cannot begin to tell you the amount of people who have contacted me specifically for pain after doing the Qigong tapping massage. And personally, I've also done this and learned that lesson the hard way as well. So stay away from the tapping. Plus, many of us are sensitive to pressure at this time, and if your cells are damaged enough, or your nervous system is sensitive enough, or you've got too much norepinephrines, adrenalines, epinephrines running through your system, it's going to raise your pain levels more than you can handle. This also makes you release too many toxins at once. So initially, stay away from the Qigong full body tapping at least for the first 6 months of your healing journey. And that's if you're doing the full juicing and the water detox and fasting method. If you're still eating, that might be even longer yet. Yoga. Yoga is a group of physical and mental practices or disciplines which originated in ancient India and aims to still the mind, recognizing a detached witness consciousness, untouched by the mind, or the chitta, and mundane suffering, the dukkha. There is a wide variety of schools of yoga, practices, and goals. Traditional and modern yoga is practiced worldwide. As a platform used strictly for physical, mental, and emotional wellness, with all spiritual references and implications stripped away from them, anyone can benefit from a daily yoga practice. Yoga improves strength, balance, and flexibility. Yoga helps with back pain relief. Yoga can ease arthritis symptoms. Yoga benefits the heart health. It relaxes you to help you sleep better. Yoga can mean more energy and brighter moods. And yoga helps you to manage stress. And yoga also promotes better self-care. One of the best yoga guides and series of videos I've found on YouTube so far for those with chronic ill issues is Yoga with Adriene. They're gentle, they're slow, they're much easier. She even has a few for seniors. They're a great way to incorporate them into a routine if you're just starting on your healing journey or struggling to begin a routine to begin with. So, in case you haven't realized the common theme here, mindfulness-based interventions help decrease anxiety, depression, stress, pain, and helps improve general health and mental health. These practices also appear to reduce inflammation and increase immune response, in a good way. And for those of us struggling with chronic symptoms or illness, because everything is connected as we discovered in methylation, it can really mess with our mind, our thoughts, and our reactions. A mindfulness-based exercise is a crucial part of our healing journey. It does so much more than just help heal our bodies. It also helps us to heal our hearts, our minds, and our spirit, and greatly improve our quality of life. And I can tell you from personal experience, this really can be difficult to do and to live with on a daily basis. But health is wealth, and you deserve it. Just by adding in a mindful-based intervention, you'd be surprised how much it can truly, truly help you. If you're bedridden or chair-ridden, there are multiple methods you can employ to help you as well. On YouTube, you can find bed rest stretching routines, so if you're stuck in bed long periods of time, doing this 3 or 4 times a day can be extremely helpful. If that is still too much, you can do Tai Chi or Qigong bed exercises that are slow, gentle, and help keep the blood and muscles moving. And there are plenty of chair exercises on YouTube you can find as well. Whether your spine, shoulder, hip, arthritis, whatever you have going for you, whatever your case may be, you can find it. One search criteria you can use is senior, by adding the word senior to whatever it is you're looking for. I have found that if you're in particularly rough shape, the senior routines are perfect, and there's far more variety. If you're looking for more exercises that are faster paced, like Zumba for example, just use the senior versions. No matter what exercise you choose, if the regular kind is too strenuous, choose the senior versions. And remember, if you have the COMT or the double COMT gene mutation, just keep in mind exercise can trigger it further. So keep it gentle and work your way up. And make sure your vitamin D is at the proper levels to support the workout. YouTube is free and has so many options available, including doing exercises while you're stuck in bed or in a chair. So make sure every day you are doing at least one routine a day. It is so important for your healing journey to make sure you have daily and consistent exercise. Sleep. Sleep is so important for improving methylation. You don't even realize how important it truly is. The general rule of thumb is to get 7 to 9 hours of sleep, approximately 2 to 3 hours before midnight. And there are very good reasons why you want to do this. Methylation follows your circadian rhythms. That's your body's natural clock. Which means when you're sleeping, your methylation slows down, you detox less, the body heals, and it makes methyl for the following day. For some of you, you may notice when you get tired or towards the end of the day, your symptoms start getting worse, especially if you suffer from the itching variety like hives or flushing. Your body is trying to tell you that it needs rest. If you're trying to tough it out and stay awake at night, it'll be a stress on the body, and the body will activate its responses with cortisol and adrenals, especially if you have the double COMT. And when you're finally ready to go to bed, poof, you will be wide awake. Many will struggle with sleep at night because of it, especially if you're drinking caffeine during the day, because you're chewing through all your methyl and altering your biological clock. This generally winds up resulting in wanting those late night snacks. So if you have significant methylation issues and chronic health issues, you're actually doing more harm than good. You're better off ditching the caffeine altogether. And I can appreciate how difficult that can be. So listen to what your body is telling you so that you don't have to listen to it scream at you. Your methylation is following your body's natural clock, and that clock may be off, but we can help heal that. So let's talk about, because this is part of methylation in the body clock, let's talk about why you're waking up in the middle of the night. If you wake up in the middle of the night with terrible symptoms, it is because your methylation is slow at night. You're not detoxing as much as you would if you were drinking water or moving around. Many believe that this is a histamine dump. And histamine does play a role in the waking response, but that is not the case that's happening here in the middle of the night. In reality, the toxins have built up in your body and they can't get out. So the body's stress response has kicked in. And keeping 20 to 40 ounces of water on your nightstand and chugging it will release those toxins and help flush it out and neutralize the histamine buildup inside your body. Just make sure that water is fresh every single night and make sure there's a lid on it. It has to do with how it absorbs carbon dioxide. So just make sure it's fresh every night and there's a lid. And this trick really does work because histamine is water soluble. And you will be able to go back to sleep within 30 to 45 minutes. Yes, you will have to use the restroom more. And believe me, I know. But it's better than suffering. But it also has to continue to cause damage to your cells, organs, and systems if you don't drink that water. It will hamper methyl formation, rob you of important nutrients, enzymes, cofactors that run methylation for the following day, and you'll still feel terrible the following morning. It just keeps you stuck in a negative feedback loop. And remember, the water thing is only temporary. It only comes sporadic after the initial detoxing is complete. If you generally feel worse in the morning and feel better throughout the day, basically the same thing is also happening. That's generally a sign that the slower methylation caused a toxin buildup overnight in your body. This means you'll need to be drinking 20 to 40 ounces of water when you get up in the morning. It'll neutralize the histamine, rehydrate the body, and get those toxins flushed out. You'd be surprised how much we suffer from chronic dehydration on a daily basis and just how much it affects our health and how we feel, including fatigue. So basically, you're looking at needing water, healing methylation, preventing toxin buildup, and one last thing to point out, if you have sluggish bowels, leaky gut, candida, SIBO, etc., this causes reabsorption of the histamines and toxins. So plenty of water and appropriate sleep to balance things is needed. So what is so important about sleep, methylation, and your circadian clock? Well, let's take a look. So the body has a natural flow to it, and it matches up to the natural world, or the world that's taking place around you. All organisms have evolved to exist in a rhythmically cycling environment driven by the 24-hour day and seasonal variations. As a result, they have adapted their physiological rhythms to mirror their environment. There is an intrinsic, genetically encoded clock mechanism in your body. And the diurnal environment is basically the weather outside, whether it's day or night, hot or cold, sunny or cloudy, summer or winter, etc. This all plays a big part on circadian rhythms and methylation. This is why so many people also suffer from things like seasonal affectiveness disorder. This is why a good night's sleep is absolutely critical to your health, especially if you have known methylation issues. Now we're going to talk a little bit about this so that you understand why it is so critical for your overall health and why you need to take your sleeping patterns extremely seriously. Your internal clock has a schedule that it keeps. Now it varies slightly from person to person. However, it works pretty much like this. At midnight, you are sleeping, and at approximately 0 to 100, you should be in your deepest sleep. At 04:30 a.m., generally, you have the lowest body temperature, and at approximately 0600, unless you're getting up earlier, is when you generally have the sharpest blood pressure rise. Part of this is due to histamine regulation that is part of the sleep-wake cycle. At 07:30 a.m., you should no longer be secreting melatonin, and the sunlight should have turned that function off. Now, there is an exception to this rule. Say like you live somewhere like I do, where it's dark all winter long, like it is up here in northern Alaska, where parts do not see sunrise for almost 2 months. At 10 a.m. is hopefully when you're at your highest alertness. At 14:30, and that's military time, which is 2:30 p.m., is when you generally have your best coordination. At 15:30, which is 3:30 p.m., is the fastest reaction time. 1700 or 5 p.m., the greatest cardiovascular efficiency and muscle strength. 18:30 or 6:30 p.m., highest blood pressure. 1900 or 7 p.m. is the highest body temperature. At 2100 or 9 p.m. is when melatonin starts secreting again and you start the biological clock cycle all over again. Now, if you're a shift worker, this can royally mess with your biological clock as well. As one myself for 16 years, I am still feeling its effects 15 years later after the fact. There is a reason they say shift work takes time off your life. It's hard on your body and it can mess up methylation as well as your circadian rhythms further, especially if you already have pre-existing methylation issues. So, methylation issues can actually mess up your body clock even worse, and it can turn into a negative feedback loop between the circadian rhythm and your methylation. So let's look at how these two affect each other. Okay, I'm going to try to explain this as simply as possible. So don't get hung up on the science, just understand the important part here is how that the biological clock, your circadian rhythm, and methylation talk to each other. And remember, methylation controls genetic expression. That's really important for you to understand. So our cells have DNA and RNA. DNA, those are our genes, our genetic code. RNA, or ribonucleic acid, has been long overshadowed by its more well-known counterpart, DNA. As a fundamental molecule of life, RNA plays a critical role in cellular processes, and that's what I need you to remember here. It plays a huge role in how your cells work, okay? Now, methylation works on the RNA inside of your cells. So the RNA within your cells, methylation methylates the RNA within the gene that runs your biological clock or your circadian rhythms. It adds 2 methyl groups to the RNA. So methylation-dependent RNA processing controls the speed of the circadian clock within your cells. This is important because if your methylation isn't working properly, it can alter your body's natural rhythms, the internal circadian clock, and we do not want that. If your circadian genetic clock is off, as well as your DNA methylation, plus the effects of your environment that it's having upon you, will have a very large impact on your daily overall health. A disrupted clock will generally result in poor sleep quality, depression and mental health issues, cardiovascular diseases, hypertension, fatty liver disease, insulin resistance or type 2 diabetes, impaired muscle function, shift work, jet lag, aging, erratic lifestyle, as well as methylation impairments can help create a disrupted clock. It can also change how your body uses and creates insulin. If you don't make changes to correct your methylation and heal your body's natural cycles like your circadian rhythms, it can actually cause long-term epigenetic changes in your body, and you do not want this. Methylation and circadian rhythm issues are also a huge factor behind neurodegenerative diseases. So circadian rhythm and neurodegenerative diseases go hand in hand. And because it all ties in also with methylation, you have to heal all of it. And you have to make sure you get yourself on a consistent, steady sleep cycle every single night. Now, you can generally heal this provided you haven't triggered a significant neurodegenerative disease. So, in order to maintain a healthy sleep-wake cycle, you're going to make sure you get plenty of sunlight. You need to make sure you get exercise every single day. You want to keep your naps short, especially if you have COMT, nothing more than 20-30 minutes. You need to avoid caffeine, avoid using electronics in bed, and make sure you build a consistent sleep schedule 2 to 3 hours before midnight to help rebalance and reset that clock. But this is why you need to have a consistent sleep schedule in order to improve your methylation. If you have poor gut health, you may want to look at taking probiotics to help heal your gut. The gut microbiome is essential in the overall health of your body. It houses your immune system, helps neutralize histamine in the gut, and provides a plethora of biochemicals that help host a number of systems, organs, functions, etc., including nutrient absorption to feed the cells, which in turn then feed your methylation cycles. It will also help you to tolerate different types of food, and as well as RNA transcription and cellular health. Butyrate is one of the biochemicals made by a healthy gut microbiome. It helps prevent many inflammatory and metabolic diseases, including Crohn's and ulcerative colitis. It also helps modulate the immune system by lowering the inflammatory markers that are common with inflammation and autoimmune disorders, while also promoting anti-inflammatory signaling. And by doing so, this chemical promotes healthy and balanced microbiota and even protects against colon cancer. It's also associated with neuroprotective effects that benefits the brain and the nervous system. It targets many of the pathways associated with the progression of diseases like Parkinson's, Alzheimer's, stroke, autism, and other neurodegenerative diseases, thus leading to a diet being the simple way to improve disease outcomes. Plus, antibiotics, antipsychotics, calcium channel blockers, proton pump inhibitors, NSAIDs, these different kinds of medications will affect your microbiome. And antibiotics are perhaps the most notorious medication for disrupting healthy gut bacteria, but they're not the only one. But if you're taking any of these drugs, you may find yourself needing to take probiotics on a regular basis. These are the 2 probiotics that I generally recommend people use. The main reason being you need to keep our histamine levels down so our whole body can heal. You're going to want to address and eliminate all the toxins, triggers, including emotional, and habits we run into on a daily basis, like caffeine, sugar, alcohol, smoking, cannabis, poor sleep schedule, lifestyle, etc. All of this has to be stopped in order to heal. We've already discussed throughout this video and other videos the negative side effects of these items. Really take a look and an honest assessment of your life, your goals, and what you want to achieve. All of these little things can add up really quick and affect your overall health. Many of us are already chronically exhausted, and a good part of that is dehydration. So make sure you're also drinking more water, and remember that caffeine forces you to chew through your methyl, your vitamins, your nutrients, etc., especially if you have the calm tea and a heightened nervous system. If you keep all of these in mind, you can help improve and heal your methylation. The last thing you can do is supplement with proper glutathione. Now, you can heal without taking a single glutathione supplement. It is 100% possible, but there are a couple people out there who may actually need it. We have outlined in great detail how methylation works, the vitamins, minerals, supplements, etc. that you can use to help heal methylation in the overall cycle of illness. We've also outlined the diet and the steps you need to take in order to heal it. If you understand how these cycles all work together, how it ties into the different systems and organs in the body, and how it affects your overall health, then you can take charge over your health issues and start living a much better quality of life. Teaching and learning these processes taking place behind the scenes in the body, it can actually help patients with chronic autoimmune, mast cell, and even mental health issues. Everything is tied together, and it always comes back to these cycles. The current systems in place are fantastic for emergency medicine, but when it comes to treating chronic illness, we tend to still suffer greatly. So how about we change all of that and be a powerful force for good and for change? These videos are dedicated to all of you who suffer on a daily basis and your families. Love and light, happy healing, God bless. If you made it to the end of this video, please hit like, subscribe, and share it. Type hallelujah in the comments below. It really helps the algorithm and helps other people suffering find these videos as well.